Hey guys, welcome to this session by Intellipaat. Data scientists use statistics as a tool to identify and determine the underlying patterns, trends in large amounts of data and use it for their company's benefit. In this session, we are going to learn statistics for data science comprehensively. And also guys, before moving on with this session, please remember to subscribe to our channel so that you don't miss our upcoming videos. Now let us take a quick glance at the agenda. So guys, we'll start off with the introduction to statistics. Moving ahead, we'll be looking at sampling techniques in statistics. After that, we'll look into central tendencies. After that, we'll learn the concepts of variation and correlation in statistics. Furthermore, we'll be looking into normal distribution. After that, we'll learn empirical rules and z-scores, and finally we'll be learning linear regression because it is one of the important concepts in data science. Also guys, if you want to do an end-to-end certification training on statistics or data science, we Intellipaat provide you with that, and you can check those details in the description. Now let's begin with this session.
Let's understand what is statistics. Statistics is a branch of mathematics that deals with collection, analyzing, and interpreting large amounts of data. So we live in the world of data today. Data is everywhere, and you yourself are creating data merely by existing. Even if you're not interacting with any social media platforms, even if you don't have a phone, you're still creating data about yourself. Now, how is that? Your social numbers, such as your voter ID numbers, your Aadhaar card numbers, your employee ID numbers, they are data about you. They help to identify you or locate you in a specific context. What's more is your banking transactions, the things that you've bought online, your loans, your credit scores, all of that is also data about you, and they can help identify banks and companies and government to make important statistical analysis and inferences about you. Things such as whether you should be provided the next loan that you're applying for. This is what credit scores are there for. They help them decide whether or not you've taken loan previously and you were able to pay it off before or well before the expected date. Are you good for your money? All of these kinds of things that impact your daily life are predicted and calculated using statistics. It's not the only thing. In your daily life, statistics is being used all around you, all around the world, and we'll take a look at that one by one. But to understand what statistics is, it's a mathematical concept that allows you to derive information based on the data that you have about a specific topic. You can do this for yourself as well. You can take some data that you have collected about you, such as the daily expenses or monthly or yearly expenses that you have, and you can understand when does your expenses rise and when do they fall. What could be the reason behind that, and you can correct for them as well. So as you can see, it's a really important tool for anyone of any field to understand what statistics is. So why is statistics important? We've understood what it is and what can be done with it. But why is it important? What benefits does it provide to a normal person such as you and me? And is it really important for us to understand this? Let's take a look. So statistics allows us to derive knowledge from large data sets. As I've already discussed, data sets don't really need to be large, but if you have large data sets, then the knowledge that you have derived have higher chances of being accurate or reflecting the real world. And this knowledge can then be used to make predictions, decisions, and classifications. These decisions could impact your daily lives, and these decisions and predictions and classifications can be performed by you as well if you know these statistical concepts and if you have collected these data about yourself. So it's not just about yourself. You can compare your spending with other people by collecting the data that they spend, or collecting data about their spending or their expenditures as well. And you can also take a look at your career graph. You can take a look at salary hikes. You can compare whether you are getting the appropriate salary hikes that you should be getting depending on the kind of work hours that you've been putting in. There's a lot of things that you can do, and all of that could be performed using statistics. Now, statistics is really important in the sense that it's being used in daily life uses. So even if you are not using statistics to do something about the data that you have, many companies are doing it for you. If you're using Netflix, then many movie recommendation engines such as Netflix, Amazon Prime, and so on, they use statistical analysis to gather what kind of movies you like, what kind of movies do people of your age, your background like, and they recommend movies to you based on that. You can also make decisions based on that, such as whether you should take an umbrella outside or not, based on whether what the weather should be. Now, weather forecasting is also something that statistics is used for. You can also perform classifications, you can perform time series analysis, you can understand what would be the price of stock in coming days. Now, these are obviously not 100% accurate. Sometimes weather forecasts are wrong. Sometimes the decisions that you take about whether or not the weather is going to be like a particular thing that you have in mind, and it's not like that. Whether or not something is matching to the thing that you have, that's not really what statistics is about. It's about making a decision about a trend, understanding where things could go. It's not 100%, it's not exact science. You are not going to get a 100% answer for everything, but it's a good indicator of what you should do based on the data that you have. Now, where is statistics used? You've heard me say countless times that statistics is being used in your daily life, whether you use it or someone else is using it for you. Let's take a look at that. So, statistics is used in various fields. So, let's take a look at some of them. Medical research. Medical research uses statistics extensively, mainly to form hypotheses and reject hypotheses about drugs. So, if you've ever wondered how does a medical professional comes to the understanding whether a drug is working or not, let's say that they've created a new vaccine for a specific disease. Now they want to test whether that vaccine is working or not. How do they test it? If there's a person and they inject it with that vaccine, and if he recovers, does that mean that the vaccine is working? Because if it's so, then just one person is not enough. There are in a particular vaccine test, there are hundreds of people, and if you inject them with the vaccine, and if it's not working for everyone else but it's working for one person, do we reject the vaccine or do we accept the vaccine? If not, then what is the number of people that it should work on? What should be the profile of those people? Does the age of the person matter in this case? All of this is taken care of by statistics. So in medical research, statistics is used extensively. It's not just for understanding whether a particular vaccine or a tablet or a chemical is working for a particular disease or not. There are many other things that statistics allows medical researchers to do, but this is by far one of the most important aspects that medical researchers use statistics for. Then comes stock market. Stock market is one of those fields where statistics is used extensively, and it's used especially by those who invest in stock markets, mainly because they want to predict whether investing in a particular stock is going to be helpful for them or not. Are they going to lose money, and if what is the risk of investing in a particular stock? Are they able to sustain themselves even after that risk provisions? If the worst case scenario happens, would they be able to survive? And if the best case scenario happens, what would be the profit? All of this is taken care of by stock market. In stock market, the data about a particular company's financial records, about their credits, about their stock market scores, everything is available for people to take a look at. So if they want to make predictions using statistical analysis, they can do so very easily because the data is already available. They just need to do the brunt of the work to get knowledge out of the data that is available for them. Then comes sales projection. In case you've worked in a company before where sales is important, you'll understand that sales is by far the most important aspects of many companies. If they're selling a product, they need to project what would be the sale of a particular product at a particular month, or at the end of a particular month, or a particular time period, such as a quarter of a year, that is, or 3 months, and understand is the sale really up to the mark. So if a particular product that has been sold for the last 4 months, taking a look at the trend that it has shown, the trend of the sales that have shown, and we try to project it for the next 6 months, if it's not up to the mark, then that product is not doing well and it could either be taken off the sale, or you could understand how what are the concepts that, what are the things that are not letting it be sold more, and you could correct for those mistakes. So sales projection is what is used to understand, to project in future what would be the sales. Now of course, as I've already told you, it's not going to be 100% accurate. If you have predicted that 10 lakh units of a particular mobile phone will be sold in the month of September, it's not exactly the case that exactly 10 lakh units will be sold. But if in the previous months 7 lakh units were sold and in the next month 10 lakh units will be sold, then you can understand that the trend is rising. So in 2 months, in one consecutive month, we are getting an increase of 3 lakh sales. What could be the reason for that? Maybe proper marketing and all that. So all of that is understandable by statistics. Many companies hire really good statistical and data science experts. They take a look at the sales projection, they try to isolate and identify the causes for it, and they try to replicate it more and more. This is what helps great companies survive. And then finally, weather forecasting. I think we all know what weather forecasting is. We all know weather forecasting uses statistics, but weather forecasting uses something called multivariate analysis. Multivariate analysis basically means there are several concepts or several factors that are influencing the weather on a daily basis. It could be the pressure, the air pressure, the wind flow, the direction of the wind. There could be a lot of things like the temperature and all that. And everything is important when you're trying to understand the weather forecasting. All of these things are taken into account and then the weather is forecasted. Is it 100% accurate? Not really, but it tells you a general trend of what could happen. So it's more accurate than it's not. So that's what's important. So statistics is used in all of these fields. These are really small set of statistics and very well-known small sets of these statistics. We all know that these, or at least we know some of these concepts are using statistics in really in-depth analysis. So we understand that these departments are using statistics, medical researching, stock market, sales projection, weather forecasting, but there are many companies and they're using it for many other purposes. Now let's take a look at sampling. Sampling is the process through which we take a subset of our data from a larger set. So let's take a look at it. So sampling is the process of collecting data to perform analysis on it, or choosing a subset of data to perform analysis on it. Suppose you have 10 million records in your data set. Now, how do you choose a specific subset of data to perform analysis on it? Now, you might be wondering, why is this important? We can just select any random 10 points if you want to perform data on 10 points, or perform statistical analysis on 10 points, and then we do that. Or you might be wondering, why do we actually need to sample our data? Why can't we just perform statistical analysis on those 10 million records? Well, first thing to understand is that statistical analysis, although very important, is very time consuming. Even for a computer, it has to churn through a lot of data, perform a lot of complicated calculations, a lot of arithmetic, a lot of number churning is required for getting accurate results. So instead of doing it for the entire data set, we do it for a subset. Suppose that you have a data set of all this information about all these 7 billion people across the world. It's a hypothetical situation. You are not going to have information about that, but let's say that you have that. Now if you want to perform a statistical analysis on that, you want to check whether the whether something is true for everyone across the globe. You can, for instance, instead of choosing all the 7 billion people and then performing the statistical analysis and the numerical calculations on the entire 7 billion people, you can choose a specific subset of it. Now, how you choose the subset is really important, because you don't want to choose a data set in which you only include people from a particular country but not from the other country. That would, in some cases, lead to a biased data set, a data set that contains only a specific subset of people. So that's important. Similarly, if you're trying to perform an organization-wide statistical analysis, let's say that you are working in a multinational company and you want to perform some statistical analysis on an organization's employees, and there are, let's say, 25,000 employees. Now, for you to perform statistical analysis on 25,000 employees is not really viable. So what you can do is you can choose a specific subset or small subset of that data, make sure that it accurately represents, or make sure that you've selected in a way that every record in that 25,000 records had equal likelihood of getting selected, and then you selected them in that basis. So that's one way of doing it. So this is why we perform sampling, to get a small subset and perform statistical analysis on this. A small subset that accurately represents, or more or less represents it approximately well, so that could be performed. We could perform statistical analysis on it. The sample should represent a large subset. So that's what's important here. And before we begin, we should understand what is sample and what is population, because this is terminology that you're going to come across many times, and if you're trying to learn statistics, you've come across this already. So population is the entire data set, and such as the whole population of a country. And sample is a subset of that data. Population is the entire data set, and sample is the subset of that population which we are going to analyze to gain knowledge from. So suppose you're trying to perform some sort of an analysis on the people of a particular country, let's say India. Now there are 1.3 billion people in India. Now trying to perform statistical analysis on that big of a data set is going to be really challenging. So in order to reduce our burden and computational intensity, what we're trying to do is we're trying to choose a small subset of our data that is somewhat representative of the larger subset. So we try to gather data, try to choose around 20,000 people from 1.3 billion people that accurately represents the entire 1.3 billion people demographic. Now it's not necessary that we choose 1.3 billion. Let's say that we're trying to perform statistical analysis on people of India who are senior citizens, who are above the age of 60. Now, then that is our entire population. Everyone in 1.3 billion people who are above the age of 60 is the population, not the entire country's population, but just the subset that we're interested in. And if the size of that data set is really large, then we choose a small sample of it and we try to make it as fair as possible so that any person could have been randomly given a randomly chosen list. We choose someone randomly in that list. So that's the point. Population is the entire data set that we are interested in, not the entire data set that represents a particular group, and sample is the small subset of that population. If you're trying to perform statistical analysis on an organization, but only the senior members of the organization, then you have a smaller population. And from that smaller population, you can choose even a smaller sample. That's what's important here. Let's understand sample frame. So sample frame or sampling frame as it's also commonly known is a list from which a sample is selected. So this list could be anything. When I'm using the word list here loosely, list doesn't necessarily mean a physical list that you need to create, although it could be a physical list. It's just a collection of data points. That's a list. So for instance, the citizen register for a country. So if you're part of a country and you're taking a look at their population register and you're trying to understand the amount of people, their age, nationality, their income, family, number of people in the family, so on and so forth. So that's the sample frame. On the other hand, if you're trying to perform statistical analysis on an employee, on all the employees of a company, then that's your sampling frame. That is the data set from which you can choose your sample. So again, it's the same paradox that we had earlier. We need to just understand what is it that we're trying to perform the analysis on. If you're trying to perform analysis on every employee ranging from an intern to the CEO, then we use the entire company's list. Otherwise, we choose a specific subset. Let's say that we want to perform statistical analysis on the high paying side of the company. So we want only the senior members, people who earn above a specific threshold or per annum, and we perform statistical analysis on that. So that is what's important here. We're trying to choose a sampling frame is basically a list from which you choose a subset to perform statistical analysis on. Let's take a look at sampling error. So a sampling error is something that leads to a sample not being accurately represented in a population. Now, instead of me explaining to you theoretically, let us take a look at what that would mean. So I have this Excel sheet. I have bumped up the font size so that you can see what I'm trying to do. Now, let's say that I'm trying to take a look at a list of employees. So EMPLOYEE ID. Let me just expand the column. So let's say that the employees are, okay, there are 10 employees and let's give them a name, AB. So these are all the employees we have. These are just a sample list of employees. We have 10 employees. They have an employee ID ranging from 1 to 10. And we have employees with the name of A to J. Now, let's say that this is just for an example. Let's say that it's not 10, it's 10,000. So now I want you to select a subset of this employee. So how do you go about doing it? because and the method you choose is incredibly important here, because if you choose, let's say, the first 5 employees, let's say that your threshold is that you want 5 employees, or you want to reduce this list by 50%, so you choose the first 5 employees. Now the problem is, let's take a look at that gender. So if the first 5 are all male and the last 5 are all female, and if you choose the first 5 employees to perform your statistical analysis on, then you have chosen a you have chosen a subset of your data, or you've chosen a sample that's biased. That's an error in your data. Now, everything that you perform is not going to represent the 50-50 gender ratio that this company has. So if you're trying to perform statistical analysis on what kind of products that does a company's senior level executives like, then you have only taken the male perspective into account and not the female perspective. So that could be a problem. Let's say that you don't do that first 5, you choose the last 5. You're running into the same problem again. You're choosing only females. And let's say that you choose this, then you are only getting one female out of all the females. And if you're choosing it like this, then these records, the first record and the last 4 records, they have no chance of being selected. So this is not an accurate way of doing it, or a correct way of doing it. There are many other ways that you can get errors like this. Let's say that there's age involved. Let's say that there's salary involved, and the subset that you're interested in is based on age, and then you're getting an error. Then you don't have if you don't choose it correctly, then you're not accurately representing or reflecting the entire population in your sample. So that is an important error to take a look at. There's also non-sampling error. So non-sampling error occurs even if you perform all this sampling correctly, even if you try to do it with all good intentions and do it with as much accuracy and as much good intentions as you can. There's still reasons that you get a biased data set. Let's take a look at why. Suppose that this is the information that I have. Now, non-sampling error mainly occurs because of you're not getting proper data or properly collected data. Instead of this, let's say that I got a data set to select from, in which I had 8 male employees and 2 female employees. Now, even though the company has 50-50 gender ratio, I've only gotten the data set that I've gotten is not accurately represented. So no matter how I choose it, even if I choose it like this, I'm still not going to get if I choose it like this, I'm still not going to get correct representation. Now that is a problem, and that means that our data set is not correct. Our data set is biased. On the other hand, if we get only the list of employees of young employees who were hired after 2010, then that is also a problem, because we want a wide spectrum of opinions. So we need people who have been hired before that as well. Now, it's not always the fault that you are getting incomplete data set. Sometimes what happens is the data was not collected. So let's say in the case of age of or the experience of a person, let's say the maximum experience that we're getting is 10 years of experience of a person, even though there are people in the company available who have had 25 years of experience. Now that could be that before the 10 years, they've only started keeping record of their employees since the last 10 years, and not before that. Everything else is not in the list that you're taking a look at. So that could be a problem. So these are the kind of errors that you need to take care of. These are called non-sampling errors. Now, if you take a look at the company and you don't get the accurate representation, then that is the problem that you're facing. And even though you try to perform good sampling analysis from that, you can still run into some great errors and incorrect or incorrect measurement or bias. So to understand incorrect measurement, let me just show you. Let's say that you're also calculating the temperature. Let's say that this is not the list that you're trying to do. Let's say that you're trying to calculate some statistical weather forecasting. You're interested in the temperature of the particular place. Let's say that the temperature ranges from 50 degrees to from 30 degrees to 40 degrees. Now, depending on how the temperature is taken and how long the period was, this is going to be a problem. Let's say that for some of the years the temperature has been taken in Fahrenheit. In others it was taken in Kelvin, and in others it was taken in Celsius. It could be that the company who was taking the measurement was going back and forth between what measurements to take care of. Now, if this is not mentioned and we are only given numerical details like 87 degrees Celsius, 84 degrees Celsius, 104 degrees Celsius, 107 degree Fahrenheit. Now let's say Kelvin is 275, 321, 320, and for degrees Celsius you're getting 27, 26, 31, 32, and 30. Now, when you take a look at the data set, it's extremely varied. And this is not an information that you're getting. This is just for your reference. Let's say that this is the information that you're getting. Now, the problem is that you have no idea why some temperatures are 276 degrees while others are 87 degrees, because if you take a look at it, you can't understand whether it's degree Celsius, degree Fahrenheit, degree Kelvin, and that could really lead into some errors. So this could be because of inaccurate measurements as well. Just delete that and let's move ahead. So when the data is being collected, that's also important. This is why we need to take care of that as well. Suppose we have census data from people from a country or a particular state or particular district. There also we could have incorrect samples. There also we could have problems. So we need to first analyze the data that we're getting the sample from so that we don't introduce a non-sampling error. Then we need to perform our sampling as accurately as possible. And let's take a look at some of the methods through which we can do that. The first is random sampling. So as the name suggests, random sampling is the process of selecting a subset or the sample from a population in such a way that every data point is equally likely to be included in the sample. So every data point has a fair chance of getting included in the sample that we're selecting from the population that we're selecting from. So again, to give you an example, let's say that now it's representing properly. Now I have 5 males and 5 females. Randomly selecting them is going to be a little difficult. So let's say that it's not going to be very difficult, but it's easy to understand. Just make sure that you're putting your head in the right place. So if your thought process in the right aligns, we want to make sure that these 5 female employees and these 5 male employees are equally likely to be selected if we select randomly. So to do that, what we can do is, firstly, as we have already done, we have taken 10 employees. So we know that the employee IDs go from 1 to 10. If this is not the case, then we can take a look at some other measure. But here we have an employee and we have a list of employees. We are given a list index assigned to the employees. Now, if I want to select employees, what I can do is, firstly, I can decide the size of my sample. So let's say that I want to reduce it by 50%. So for that, I need to select 5 people from this list of 10 people. To do that, let's say that I just randomly select 5 employees. Randomly, that means from the range of 10. So I select 1, I select 5, I select 8, I select 10, I select 3, right? So these are all randomly selected people. Now I have 1, 2, 3 male employees and 2 female employees. So again, the sample is not going to be extremely accurate representation, but we're getting 60-40 representation, which is to say that we're getting around 50%, which is quite accurate of the one that we already have. Now the thing we need to understand is that since we have selected them, one potential issue that you can run into is that when you're selecting these samples, you are selecting them in and then reselecting the index. So let's say that I come up with 10 random numbers from 1 to 10 as 1, 2, 7, 2, 5, 4. Let's say 7, 2. Now the problem is that I've selected the index 2 twice. So make sure that you understand this. Many people just discard the next number to be something that other than what has already been selected. So that's one way of doing it. So just make sure that you're doing it correctly. The reason why random sampling works so well is because we are just randomly selecting any record that we can. And sometimes that's not always correct, because sometimes you get, if you're randomly selecting, you could put, if you have a large data set, then you could have 4 of male employees and 1 of female employee. So it's good technique, but it's not perfect. If you have a really large data set and you have accurate representation, then it's random sampling works really well in that scenario. But how do you correct for mistakes like this? That is for our next sampling method will tell us. So we understand random sampling. We just choose randomly out of a list of all the people from the population. We randomly select just a few people. So with that in mind, we run into an error in which if our data set is not really large, then the problem occurs that we might end up selecting data that's not accurately representational. Even though we might not be selecting it in a way that is completely malicious, we are not trying to select the people from a specific gender in our data set. We're just doing it randomly, but still there could be issues. So to overcome that, we come to stratified sampling. So stratified sampling is the process of dividing your samples into layers or groups and then performing random sampling on each group. So let me give you an example. Let's say that instead of 10, we have 12 employees, 11, 12. And yeah, so now let's say that I want to perform stratified sampling and the sample size is 12 and I want 50% of it, that is 6 employees. So to select that, firstly I take a look at the deciding factor. So I'm selecting them on the basis of gender. I want them to be accurately representative of the gender. So to do that, what I can do is I can firstly perform my stratified sampling in this group. It's an entirely male list. It contains only one portion of the entire group, and the other portion is contained in the list below. So let's say I wanted to select 6 people. There are 2 genders. So that means I want 3 out of each, right? That would be an accurate representation of the list that we have. Now, in case we have 40, 60, then we could select it in a different basis. So now what we can do, in this, I select 3 people randomly. Let's say I select 1, I select 2, I select 5. These are randomly selected. Let me just give them a color to tell you. And then in the other group, I select 3 people randomly again, 7, 8, 9, and 10. And you have a randomly selected list. It's accurately representing the population that we have. We have 3 females and 3 males out of 5 females and 5 males. So this is what stratified sampling does. The word stratified comes from the word strata, which basically means a layer. So we divide them into groups, or we divide them into layers, as many people would call it, and then we choose a specific subset of that layer or of that group to get an accurate representation of the entire population. That's one way of doing it. Random sampling is good when you just have people that you want to select and there's no need for accurate representation of a particular group. On the other hand, stratified sampling is good when you want to perform random sampling, but you have to take into account certain divisions in your data set, such as a group or division based on specific gender, specific age groups, anything like that. Now we come to systematic sampling. One major issue with the previous examples is that you need to have the entire list with you in order to perform the sampling. Let's say that I am working in some department in which data is coming in regularly. So I can't select data on this because I can't select data, or I can't select the data points that are going to be included in my subset or in my sample if I don't have the entire list. If I have 3 people, then I can only select out of 3 people in the next day. If I get 3 people more, then I can only select out of 3 people, and that is going to be a problem. And if the next day I get 7 people, then it's going to be incredibly difficult to make sure that I'm selecting them accurately. So I need to get the entire data set beforehand. Now, that's not always the case. It's not the ideal situation. Sometimes you can run into issues that are not based on that. So how do you correct for them? You come to systematic sampling. Systematic sampling is the process of selecting your samples by picking every kth element in your population. Now, k could be any number that you want, from range going from 1 till the number of people that you get, and you don't need a list for this. That's the extreme advantage of systematic sampling. Let's take a look at how to perform this. So let me just write the date on which these data points are collected. Let's say that's collected first of a particular month of a particular year. These are collected on the second, and these are collected on the third. Now let's say that the k I choose is 2. That means I will select every second data point. This person comes in, I don't choose them. This person comes in, this is the second point, so I choose this. I move ahead. This person comes in, I don't choose it. The next day I keep the index and I choose this because it's the second person. Even though they have not, we have not seen them previously, they're still, the list is still going on and the calculation is still going on. Second person gets selected, second person gets selected, second person gets selected. As you can see that we are excluding the first person and including the second person. So that's how you can take advantage of the k sampling. K could be anything that you want. Make sure it's not really big. Make sure that if you're only getting at max 3 people or 4 people in a day and you select 15, then you're not never going to get the accurate representation or never going to select anyone that you want. So with that in mind, understand that this is going on. But one issue that you could run into is that this is not for every scenario. Let's say that I have a sample in which first person is male, second person is female, first person is male, second person is female, and this is the sample I have. If I choose k is equals to 2, then I only get female employees in my company to be taken as the subset or this sample of a population. That is going to be not indicative of the kind of problem that I'm trying to solve. So I'm not going to do that. So take a look at the data set. If your data set is in arranged in a particular kind of group or a particular kind of pattern that such as first employee is male, second is female, first is male, second is female, then kth employee is not going to kth or systematic sampling is not going to make sense for you. But if you have data set in which people are coming in regularly, this is for clinical studies or for test studies. If you've seen this, many people who go into a clinic to consult a doctor, the receptionists or people there sometimes give some of them a list or a questionnaire to fill out. That is to judge the performance of the clinic or some other problem that they might have, or maybe some medical survey to fill out. This is done using the systematic sampling because you have no idea how many people are going to visit your clinic in a particular day, in a particular shift of a person. So this is why systematic sampling is useful. You just take a look at the name of the person, and mention them in a register, and then give them a number from, give them an incrementing number from the previous number. So the previous person was 1, then you give 2, 3, 4, and you select the kth employee for the scenario. And this is how that would work. So hopefully you've understood this, and let's go ahead. Now let's take a look at central tendencies. So central tendencies, as we've already discussed, take a look at the definition, is used to indicate where does the middle or the center of the distribution of a data lies. So central tendency basically is used to find out where does the most amount of values that our dataset contains cluster into. What is the range in which our dataset clusters into? So if we have a data set in which majority of the values are between the values of 4 and 10, then we have our central tendencies lying there. We have different ways of calculating different central tendencies, and they tell us different things about our data. So we have mean, we have mode, and we have median. So these are different metrics that all come under the umbrella term of central tendency. Central tendencies contain mean, median, and mode. These are different measurements of our data, and they tell us different things about the data that we have. Some are more important than others, and some have some categories as well, and we'll take a look at them one by one. The important thing to understand is the concept of central tendency tells us where does the majority of our data lie. What is the range in which the majority of our data lies? What does that tell us? And then when we go into detail, we try to understand what does this range of the data tell us, and what can we extract of value out of this information. Let's take a look at mode first. Mode is used to indicate the most frequent data point, or in other words, the one which occurs the most number of times. So if we have a data set in which we are trying to calculate the most frequent or the most popular choice, this is where mode comes in. Let's take a look at that. This is what we have from previous data sets. Let me just remove it. Now let me just show you. Let's say that you are trying to perform a survey between 3 products. Let's say the products are P1, which is the first product, P2, which is the second product, P3, which is the third product. Given a choice, a customer is given a choice to buy one of these 3 products, or considering all of them are of the same price and everything else is the same, and they are being judged on their quality of aspects. Then which product will the customer buy? This is something that a customer will choose out of the 3. So let's say that you perform this for 10 people, and Let me just remove this. So these are our choices. And the first person chooses P1, second chooses P2, third chooses P1, fourth chooses P1, fifth chooses P1, and then the other one chooses P3, then chooses P2, then sorry, P2, P1, P3, and P1. Now, if I were to just calculate the number of people that chose P1, it's 1, 2, 3, 4, 5, 6. So 6 people chose P1. Then we have P2, and 1 and 2 people chose P2. And you can probably guess the 2 people chose P3. So if I were to ask you, okay, what is the mode of this data set? You're probably going to, I think the question is quite clear. Mode of the data set is the value that is the most frequent or the occurs the most number of time. P1 is the most frequent choice, so P1 is the mode of our data set. So what does mode tell us? Well, not much other than the fact that P1 is the most popular choice among people. This kind of statistical analysis is useful when you're trying to perform some sort of an analysis of whether or not a particular product is popular among a particular group of people. Let's say that this was the result that we got from people of the age of 18 to 25. So a particularly young demographic likes the product P1 more. Now, if we were to, let's say, go the other way and ask senior citizens, let's say people over the age of 60, and if we were to ask them the same question, and let's say that the answer we get is, instead of me writing it out, we get P1 was selected by 2 people, P2 was selected, P, P2 was selected by 3 people, and P3 was selected by 5 people. Now, the most common answer in this scenario is P3. So this is what we try to understand using mode, which is the most popular. So if you're trying to figure out which product is more popular, what movie is the most popular among your friends, what kind of movies are most popular among your friends, what kinds of songs do a people of a particular country like, what kind of movies, songs, what kind of people, what kind of things, what kind of food, what kind of cuisine. These are the kind of things that mode helps us answer. So mode is very useful when you're trying to figure out most popular among a data set. Let's move on. So now that we know mode, the next thing we need to understand is median. So median is the middle of the data. So when I say middle, I mean if we are to lay out the entire result that we have in ascending order, median is the middle of our data. What does the middle or the value at the dead center tell us? So if the data is arranged in ascending order, then the data element that occurs right at the center is the median. So let me just show you. Let's say that instead of this, I have a particular group of people, right? And I want to calculate these people are arranged in the number of years of experience. So let me just write it, years of experience. And let's say that we have a data set that looks like this, 9 and 10. This is what we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the years of experience of people. 10 employees, all of them ranging from 1 to first employee has 1 years of experience, second 2, 3, 4. This is all arranged in ascending order. If you don't have that in ascending order, you can arrange it yourself. It's perfectly reasonable. It's like sorting a list. It's easy to do. And now let's say that I want to find the median of the data. To find the median of the data, what I can do is I can, for instance, take the middle value. So there are 10 values. I need to take the fifth value. But since this is an even number of results, I can't just take the fifth value, because if I take the fifth value, which is this one, there are 4 values on top and 5 values, 1, 2, 3, 4. Oh yeah, so that would be a problem. So for me to do that, 1, 2, 3, 4, 5 values at the bottom, that would not be an accurate mean. The accurate mean would be the average of the 2 values. Now if I take the average of 5 and 6, I will have to do 5 plus 6 divided by 2, which is 11 by 2, which is 5.5. And that is our median. That's the median that we get by choosing these 2 values. So we have 4 values above the median, 4 values below the median, and this average is 5.5. Now if I didn't have that, if I only had odd number of values, that is 9, 7, 3, something like this, then I can easily take the middle value, which is the fifth value. 4 values on top, 4 values on bottom. So that way we can distribute our data and understand what is the median of the data. Now, as you already know, that mode is useful for, yeah, so we're trying to find out the most popular thing in our data set. So median is used to, it's not extremely useful, but it's useful in very specific use cases. When we're trying to find out the middle value of, we're trying to find out the median or the middle value in a group of things. So here it tells us that the median, you've heard of median salary, you've heard of median household prices. So these are the kind of things that we calculate using median. So median tells us the middle value. Now we can compare them and contrast them to the end values and find out what is the how the distribution is. So to give you an example, let's say that I have 2, 3, 4, 5, and then that's 10, 15, 18, 25. Now the median value is 5 and the value at the end is 25. So we can compare and contrast that there are some people that there's a disparity between the number of people that have particular years of experience, and this is the kind of thing that median is useful for. Now median isn't extremely useful, we don't use it for a lot of things. As you can see, it has a very niche use case, very particular use case, so we don't use median that much. And then comes something that we use a lot of times, mean. Mean is something that you must have all come across. It's a very popular statistical analysis tool. We all use mean in our daily life, even if we don't call it mean. So mean is basically the average of the data, or in simpler terms, it's the sum of all the values divided by the total number of values. It's presented, and it's called the Greek letter sigma is used to represent the summation of all that. So let me tell you how to do this. Let's say we have this, and I wanted to calculate the mean of the value, right? So I had 2, 2, 3, 4, 5, 6, 4, 2. So this is what we have. Now I don't need to arrange it in ascending order to calculate the mean. Let's say that this is the years of experience in a new startup. So I get 2 plus 2 is 4, plus 3 is 5, plus 4 is 9, plus 5 is 14, plus 6 20, plus 4 24, and finally 26. So we have the cumulative sum is 26. Now we have 8 values. So if I wanted to calculate what does the mean of my data is, I need to firstly calculate the sum of the entire data set, which I have calculated to be 26, and the number of records I have is 8. So 26 divided by 8 is 3.25. So I get the mean of my data is 26 divided by 8, which is equals to 3.25. Mean is the average. We calculate average on a daily basis. We calculate the average income of a particular group of people, the average income in our household, the average incentive we get, the average tip we leave. There's the average annual income of a particular substrata of a person, of a group in a country. We calculate averages on a daily basis. What is our average expenditure? How much do we spend in our entire month? So to give you an example, let's say this is the most common thing you can understand. Let's say that you spend this many thousands of rupees per month. Let's say 12, 14, 15, 18, 10, 8, 5, 18, 15, 14, 12, 10. Let's say that these are the expenditures of yours on a monthly basis in thousands. So you get 12 plus 14 would be 26, plus 15 would be 26, plus 10 is 36, 36 plus 5 is 41, plus 18 would be 41, 51, 61, 59. Then plus 10 is 69, plus 8 would be 78, plus 5 would be 83, plus 18 would be, let's say that the calculation of all of this is done and the average is coming across 150, right? Let's just skip the calculation for now. We get 150, and now we want to calculate the average that you spend on a monthly basis. So what you can do is you can just divide it by 12. So what we're trying to do is we're trying to calculate the average. So we divide 150 by 12, and what we get is 12.5. So the answer would be you spend 12.5 thousand per month on an average. And then you can take a look at the data and you can understand, okay, so this is fine, this is fine, this is fine. In the fourth month of April, you spent way more than your average. In the other months, you're spending somewhere across it. In the sixth and seventh month, you spent really less, and then you can take a look at the influences that that month had. Maybe it was some party, maybe it was your birthday, and you spent a lot of money. So you can do these kinds of statistical analysis to understand where how do you spend the money, how does your expenditure goes, which month influences the majority of your expenses, which month influences the least of your expenses, and why is it so low in particular month and not in some other month. So it's very useful in those scenarios. Now, mean are of two types. First is the trimmed mean, second is the weighted mean. We'll take a look at them one by one. Let's take a look at trimmed mean. So trimmed mean is used to deal with outliers, data that is so far from what you do, one particular data that is really has a really high value that is influencing the mean of your data. So let's take a look at that. So to understand what trimmed mean is, firstly we remove some data from both the ends to get rid of the outliers. So let's take a look at that. Here we have our data set. Let's say that we get the same data set back, but let's say in the last 2 months, instead of 12 and 10, let me just get a new data set. So let's say that you spend less, you spend 5, 6, 7, 5, 5, 5, 6, 7, 9, and in the 6, 7, and the last 2 months you spend really high, let's say 20 and 25. Now, if I were to calculate the mean, let us just calculate it one by one. 5 plus 6 is 11, plus 7 is 18, plus 5 is 23, plus 5 is 28, plus 5 is 33, plus 6 is 39, plus 7 is 46, plus 9 is 55, 61, and now we add 20 to it, we get 81. Now we add 25 to it, so we get 106. If we calculate the average or the mean of this, we would have to calculate it by 106 divided by 12, which is 8.83. So 106 divided by 12, which is equal to 8.83. Now that's the mean, but as you can see that the last two values, they are really high. Maybe this was just some sort of an anomaly that these months you needed to spend really more because you were traveling some other places, or you needed to shift your house from one location to another, and that's why it cost you so much. So let's say that this is just one time anomaly and this is not happening again and again. So but this is a large data set and you don't know whether that's the case, and this is influencing your data really badly. So to get the mean, what you can do is you can take off the first two values and take off the last two values as well, and you get only this data. So if I were to take this here and then calculate it, 7 plus 5, what is 7 plus 5? It is 12, plus 5, 17, plus 5, 22, plus 6, 28, plus 7 would be 35, plus 9 would be 44, and plus 6 would be 50. So here when you take a look at the average, it's 50 divided by, and what we have here is 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 values, and the calculation when we do it, we have 50, which is the sum. So 50 divided by 8 is going to be equal to 6.25. So that's the mean that we're supposed to have. The reason that we are getting 8.83 is because some expenditures are really high. So instead of it being 6.25, we are getting 2 point some value more than this, 2.5 thousand more than this, which is really high. So why did we scrape off the first two and the last two values here? Now this is a little difficult to understand. So what we're doing is we're getting the first two values, we're getting the last two values, and we're scraping it off mainly because the outliers don't need to be right at the bottom. They could also be at the top, and we want to just make sure that we're getting the center of our data. So let's say that instead of 5,000, it was 1 and it was 1. Now this could also negatively impact your data. So in order to get rid of that, what we do is we remove this, and what we get is 6.25, which is the correct value. Let me just remove all of this. Hopefully this was easy to understand. And let's move on to the next one, which is weighted mean. Now weighted mean is used to calculate mean of certain values where a certain value is supposed to have more importance or more value or more weight. Now it's used to calculate certain values that are supposed to count more in some context. Let's say that we're calculating the average of a grade of a student based on the grade distribution. Now this is something that is done using weighted mean. Let me give you an example. So I have prepared an example before so that I don't mess it up. Let's say that you have 3 quizzes in your entire academic year. The first quiz covers 10% of the syllabus, the second quiz covers 20% of the syllabus, and the third quiz covers 70% of the syllabus. Now, and then there's the final quiz, that's the final exam, we're not calculating that. Now what we're doing is we're getting these three values. Let's say that the weight of you get whatever marks you get for the first quiz, you get the 10% of that mark. Whatever marks you get for 20% in your final grade, it would count as the 20% of your final grade. And whatever marks you get in the third quiz, the 70% of it would be calculated for your final grade. So if you were to get these marks out of 5, or let's say out of 4 or whatever, out of 5 of your average grade, then you will be getting 3.5 divided by 3 plus 3.5 plus 4, and 7 plus 3.5 divided by 3, which will get around 3.5, which is considered to be your average grade. Now we know that that is not the case because we have not taken these weights into account. We have not taken 10%, 20%, and 70% into account. So if we were to do 10% here, what we do is we take 10, we divide it by 100, which is the 10%, and then we multiply it by 4. We get 0.4. So out of 1, you got 0.4. So then you get 3.5, and then you get 3, and out of that you got 3.2. That's your average grade, not 3.5. So this is where weighted mean comes into play. This is not the only case that this is there. We can also take a look at other things like calculating the increment of a person based on the years of experience they have and many other factors. Many other variables come into place when we try to understand the averages of particular groups. So this is where weighted means come into play. And again, these have really specific use cases. So you need to take care of whether you to use weighted mean, to use trimmed mean, or very mean, mode, or median, depending on what you're trying to get. Mean is useful for calculating simpler means. If you have outliers in your data, you can use trimmed means. And if you want to calculate mean by giving certain values, certain more value, if there are certain data points that are more valuable than others, then you use weighted mean. So now let's take a look at variation, or variation in our data to be more specific. So what is variation? Well, variation in statistics is used to show how data is dispersed or spread out in our data set. So several measures of variations are used in statistics, but variation is mostly used to calculate if we have a center of our data, if we have calculated the central tendencies, the mean, mode, and median, then how far away is our data points from the one that we have? How much is the variation? For instance, if we have a data set that most of its values are 4, then the variation is not that much because most of the data is 4 and the other values that we have are 3 and 5. So the data is quite compressed. So it's not extremely spread out if we consider it on a number line. On the other hand, if we have data set from 1 to 10,000 and every number has a value of 1, 5, 7, 4, 3, then it's very spread out. There's an extreme amount of variation. It's difficult to get sense of data like this. However, we don't get a data set which has that massive of a variation. We usually get data set that's a little more compressed. So let's take a look at how or what are the kinds of measures that we can take to understand the variation in our data set. So we have range, we have quartiles, and we have variance. Range, quartiles, and variance are one few of the ways that we can take a look at to understand the variation in our data. So quartiles are also known as quantiles. So if you come across this terminology, then don't be confused. They mean the same thing. We have range and we have variance. Let's take a look at them one by one. These are important concepts to understand once you're trying to interpret the data and understand how dispersed the data is, how different the data is, what's the variation, what's the variance, how much different is it from the mean that we have, how far away is one data point, or how likely one data point is to be far away from the mean of the data or the center of the data. Let's take a look at range first. Range, as the name suggests, is quite easy to understand. Range is the difference between the highest and the lowest value in our dataset. Range tells us the difference between the lowest and the highest value in our dataset. So let's take a look at that, because sometimes people get confused with what range means. Let's say this is the data and we have 5, 10, 12, 11, 2, 5, 1. Let's say it's 10, 11, and 15. So this is the data that we have. Now to do that, firstly we have to calculate the minimum and the maximum value. This is easy enough. You just go from top to bottom calculating the minimum and the maximum. Right now both are 5. Maximum is 10, minimum is 5. You keep going and you find minimum is 5 and maximum is 10. So when I ask people, oh sorry, maximum is 15. So when I ask people what the range of this data set is, many people get confused and they tell us the range is from 5 to 15. Now, if you are taking the word range quite literally, then this is exactly what it means. 5 to 15 ranges between the values of 5 to 15. However, in statistical sense, this does not make a lot of sense. So in statistical analysis, the way we do it is we go 15 minus 5, maximum minus minimum, highest value minus the lowest value, and we get 10. So this is the data that we have, and this is the range that we have, 10. So this is what we have. This is the range of our data. Now as you can see, range isn't the most optimum way of doing it, or finding the deviation, or finding the spread or disperseness of our data, mainly because if the data has outliers, then range gets skewed quite easily. We have 15. Now if I want to calculate the range of a data set that has 95, now the range of our data is, it looks like 5 minus 95, which is 90. So you would think that the data, whatever the starting point of the data is, it would have values ranging from the starting point plus 90. So if starting point is 5, which is the lowest value, plus 90 is 95. However, majority of our data lies between 0 and 12, 0 to 15, let's say. And only one data point, which is the outlier, is 95. So this could negatively impact our data really badly. So this is why range is useful, but once we make sure that the outliers are not there and the data is completely standardized, which is a little difficult to do. However, range is still useful for smaller data sets like the one we are seeing here. Now the question comes that what does range tell us? Well, it tells us the width of our data. It tells us quite literally the range, the width of our data, how many, what is the range, what is the disperseness of our data. So if we have a data set that has higher number of variations, let's say that I have 1 million records, but all the values range from 5 to 25. Yeah, Excel is causing some issues here. Never mind. So you get 5 to 25, right? 5 to 25. I don't think it was. Yeah. So let's say that this is the range that I get. So 10 million record, 10,000. Let's say 10,000 records, and the range is from 5 to 25. So you can easily understand that this data set is really concise, it's really clustered. So the range is quite small. Range is 20. 25 minus 5 is 20. Now again, if we had the same thing, but the range was not from 5 to 25, it was from 5 to 5,500. This is a problematic thing, because now our range becomes from 5,495. This is our range now. So as you can see, here the data set is quite dispersed. assuming that these are not outliers, 5 to 55,000 are normal range of numbers, and numbers are equally distributed across this range. Then we have a really wide variety of data set, and it's got a really large set of variation. But here we only have 20 value. We have only the width of 20. Here we have massive width. It's 10, even more than 20 or 20 times more than what we have here. That's a problem. So we need to understand why we use something like this. It's because we needed to take a look at what's the variation, and this is only good. This is a really simplistic measure, but it guides us in the right direction. So that's why we use it. So let's move it to the next direction. We look at percentiles. Now, to be quite honest, percentiles are not really something that we use to calculate the range of the data, but there's when we are moving on to quantiles or quartiles, there we use percentiles. So it's important to explore what percentiles mean. If you're studying in a university, if you've studied in any sort of university, you've gotten a percentile score sooner or later. You come across this score in your schools as well, or especially in colleges and universities, the percentiles are used. Or if you want to take a look at percentiles used at other competitive exams as well, so that's where they are used. Now, percentiles are scores that are used to describe the value below which some observations fall. Now, that's a very vague definition, but it's quite accurate. I'll explain to you in a moment using an example, but to understand it right now, just take a look at the example that we have in the text format. If X is the 70th percentile, let's say that you are a person who's gotten a result, and at the bottom of your result, it says, congratulations, you've achieved the 70th percentile. That means that 70% of the other data points, you could think of it as 70% of the other students who took the same test that you did were below you. So you are above 70% of all the people that you took the test with. So to give you an example, let's say out of 100 you scored 95. Now, when you hear the word out of 100, many people think that out of 100 I scored 95. That means I got 95%, which is correct. But then they think they got 95th percentile as well. Now, that is incorrect, mainly because it doesn't matter what the score is or how much you got it from. What we're trying to calculate here is not what the percentage is. That's what we use the percentage for. In the percentile, we're taking a look at how many people you've gotten more numbers from. So let's say that there are 100 students in your class and you got the 5th rank. That means, or you can say you got the 4th rank. That means from rank 1 to 95 are below you. So you've got the 96th percentile. 95 people are below you. That's what percentiles mean. Percentiles are used to calculate how better are you compared to the rest of the people in the sample. Rest of the data points in the sample is you, or rest of people, depending on what the data is all about. If you have a drug or you have a potential vaccine, and we take a look at how many people have, let's say there are 5 vaccines, and since there are 5 vaccines and you have one vaccine that scored the 4th highest. So if you take a look at it, that means that you are 80% in the 80th percentile. 5 people or 80% of other records are below you. So that's what this means. Depending on what data that you have, you can take a look at percentiles. You can understand what that means. But this is what percentiles are useful for. Now, why are we learning percentiles if they're not a part of calculating the variation or variance in the data? Mainly because it's not just percentiles that are useful, but we use quartiles. Quartiles are extremely useful. Ask any statistician that you can come across. Quartiles are used on a daily basis. So let's try and understand what quartiles are, and we'll take a look at a few examples along the way as well. So quartiles are used to break the data into 4 parts, so as to better find the spread of the data in a way that is not that influenced by outliers. So if you have some data and you're afraid that outliers might skew your data, what you can do is you can choose a quartile method. That will tell you approximate answers. And you've already calculated one of the 3 quartiles that we calculate, and I'll show you what that means in a moment. Let's take a look at that. So quartiles are used to calculate firstly, there are 3 quartiles. Q1 is the first quartile, Q2 is the second quartile, Q3 is the third quartile. Quartile 2 or Q2 is the 50th percentile. Just calculate it. The quartile 3 is the 75th percentile, and quartile 1 or Q1 is the 25th percentile, right? So now the question comes, what does that mean? Let me show you with an example. Let's say that we are calculating height of people in centimeters, right? So we are arranging that in a format. So let me just take it away from here, paste it here. This is just for our reference. Let's say 144, 155, 156, 157, 158, 159, 160, 167, 170, 171, 172. Let me just remove these two. So let's say that there are 9 records and we want the 50th percentile. 50th percentile would mean that 50% of the data is above and below it, and we're right there. So in this scenario, 50th percentile, as you can, if you try to think about it, it's the median of the data. This is what I meant when I said that you have already calculated the one of the quartiles. So when we're trying to calculate the 50th quartile, what we're trying to do is, firstly, we have arranged it in ascending order. We take all the records, we take a look at the number of records, we have 9. Right in the middle would be this, and this is the 50th percentile. So Q2 lies here. Now, as you can see, we have 4 records below, which is approximately 50% of the records below our percentile. So that's what this means. So this is what Q2 is. Q2 is the second quartile. Now, how do you calculate the first and the second quartile? We can do it like this. Now, let's take a look at this. Don't think about this range. Just think that this is removed like this. And we're trying to calculate the quartile in this range. Okay, so in the range from 0 to 4, above the first quartile, the way we calculate it is we take a look at the number of records. It's an even number of record, which is 4. 4 divided by 2 is 2. These are the 2 records that are in the middle. Now we can't just choose one for the quartile. Instead of calculating the median, the quartile is considered to be between these two. So these two values are considered to be a part of the first quartile, not the third quartile, but the first quartile. Similarly, these two are considered to be part of the third quartile. So the third quartile lies here, second quartile lies here, first quartile lies here. So now if we are to understand what quartiles are, they are a way for us to understand our data more. You can think of it as range, but a little more subservient to outliers. So we don't have to worry about outliers that much. This is the third quartile, this is the second quartile, and this is the third quartile. We get 3 data points and we understand which one is used for what. Now the question becomes, what happens if we have an even number of data? So let's say I will paste this here. Let me just remove the quartiles. And now we have to calculate the second quartile. So we have 2, 3, 4, 5. So these two will be part of our second quartiles now, because we have even number of data. And this is, if you want to calculate the median, then sum them up and then divide them by 2, it would be 159.5. So this is the second quartile. The first quartile would be 1, 2, 3, 4, 5, and so first quartile would be here, and the third quartile would be here. We just take a look at the numbers between them and find its median. We find the numbers above the second quartile, we find its median. That's the first quartile, that's the third quartile. That's what we mean by quartiles. So that's how quartiles are calculated. They are easy to calculate. They give us a better indication of how our data is spread out. Much better than range. They are less prone to outliers. Unless your data is so dispersed that outliers are really easy to catch, then that's a problem. Now that we're done with quartiles, now quartiles are expressed in percentiles. So first quartile is the 25th percentile, which we have already seen. Second quartile is the 50th percentile, which is also the median, which we just saw, and the third quartile is the 75th percentile. So again, let's take a look at the data to make sure that we understand it correctly. 75% of the data is above this, 50% of the data is below this, 50% of the data is above this, and 75% of the data or 25% of the data is above this. So that's how we calculate quartiles, and that's why percentiles are useful when understanding quartiles. Now let's take a look at interquartile range. So we had range before, but it was very easy to get influenced with by outliers. So the range was very much influenced by the outliers, but interquartile range is a little different. Let's take a look. Interquartile range is the difference between the lower and the upper quartile, that is Q3 minus Q1. This gives us a better idea of the range of the data. So this helps us understand how our data is spread out, and it's not that influenced by the outliers. So if we have this, we get this. Now we have 170 as the third quartile. We have 156 as the first quartile. So if I had to calculate the interquartile range, I would just do 170 minus 156. So 166 and 4, 14, and we have 14 as our interquartile range. So this is how much our data is spread out between our quartiles. If this is a massive difference, then our data is really spread out, and if it's not a massive difference, then it's not that massively spread out. That's the first thing. Now, many people think that median could be used to do the same thing. That's not really the case. We're trying to look at the extreme ends of our quartiles and find the distance between them. That's what tells us how spread out our data is. If this was a large data set and the quartile was 140, then we could probably understand that our data set is very widely spread out, or more widely spread out than it was when it had 14 as its interquartile range. So it's a really good measurement, but it's less influenced by outliers. Outliers are really the things that we need to watch out for when we're trying to calculate range of any sort, whether it's the interquartile range or the simple range. This is why we use percentiles, because percentiles are not that influenced by interquartile ranges. They help us understand what we're trying to do, and they give us a more accurate representation of the data that we have at our hand. If we were not using percentiles, then our range would be 144 minus 170, and since there are no outliers, it's fine. But let's say the outlier was 198, or even not 198, 222, or let's say some crazy number 568. Now, even though there's an outlier, my range is perfectly fine. Let's say that the outlier here was 14. So it could be because of incorrect measurement. It could be that generally is an exceptional case in our data set. So that could be it. That's our data set. That's what interquartile ranges are all about. Let me just delete that for you. And let's take a look at something else. Now let's take a look at correlation. So correlation is something that you might have come across many times in your life. Correlation is a term that is used to measure the strength of a linear relationship between two quantitative variables. Now, this is a very jargonistic definition, so let me break it down for you. Suppose you're trying to calculate, suppose you have a data set in which you have your height and your age. So as your age increases, your height is also going to increase. So that is what is known as a positive correlation. So this is what we're trying to calculate. Correlation is calculated as in terms of correlation coefficient, which is basically a number from -1 to +1. And we'll take a look at what that means, but this is what the formula looks like, as you can see down here. Let me just, yeah. So this is what the formula looks like. Now, some of it might look familiar to you, some of it might not. So let me just show you what that means. So this is the summation symbol, the sigma symbol that we have already seen. It means sum up whatever I have on the right of me. So what we have is x minus x bar. X bar is the mean of x. We're trying to calculate the correlation between x and y. These are the two variables. This is why we get this correlation coefficient r and subscriptive x and y. So the correlation of x and y is equal to summation of x minus x bar, which means just as we calculated standard deviation, what we need is the mean of x, and we want the difference between each individual observation and the mean. So we do that, and we calculate the sum of that. We calculate y minus y bar, which is each individual observation for y and difference between its mean, and we take the So we take the product of those numbers and then we sum them up. How does that work? We'll take a look at that in the example that we have. But as of now, you need to understand that this is what is happening. Then underneath it, we're doing quite similar thing. We sum up the x minus x bar whole square. So we take the difference between the mean and individual observation, we square them and then we sum them up. We do the same thing for y and then we calculate the under root of that or square root of that. So this summation of x minus x bar whole square looks like the standard deviation of x and similarly standard deviation of y. So this is what we're trying to do here. Now formula is quite simple, but the idea that correlation is trying to get across here is not that what the formula is trying to say. The idea that we're trying to get across here is what is correlation and why we use it. So correlation basically allows us to check whether one variable has any influence on the other variable. Does increase in one variable lead to an increase in other variable? And if so, then how strong is this correlation? If it's really strong, that if I increase one variable by some degree, the other variable will be increased by that degree as well. If it's negative, then it will be decreased, and we'll take a look at what that means and why that's useful here as well. As of now, let's take a look at the example. One other thing that I'd like to mention is that it's a linear relationship. That means linear basically means a straight line. So basically what it means is that if I were to create a scatter plot out of this, and if I were to draw a straight line from right between the scatter plot, then that would show if the scatter plot is following that line, that means there's a strong correlation. So we can also take a look at that as well. So let's take a look at the formula and let's try and implement correlation here. And this is the data that we have. Now it is a little overwhelming to take a look at. I've done most of the calculation for you so that you don't have to see me do these calculations by hand all by one. So let me just explain what this means. Let's say that we're trying to calculate the temperature and price of a product. So temperature is the temperature outside and price is the product that the amount of product that was sold at a particular temperature. Instead of it being price, let me just call it amount. Now it makes sense, and let me just expand this column so that it makes sense. Now temperature is x and amount is y. We're trying to calculate as does increase or decrease in temperature have an effect on the amount of items sold at a particular day. So these are the temperatures. These are the amount of prices that we have sold. So does if I have a higher temperature, does that mean that more of this product is going to be sold? Is going to be sold? Well, let's take a look at that. First things first, we need to calculate the mean of x and y, which we have already done. So the mean would be if we sum it all up and then divide it by, in this case, 12. Similarly, if we sum it all up and then we divide it, let me just do it, and then we divide it by 12. The mean of x, which is x bar, is 18.7, and mean of y, which is y bar, is 402. So hopefully mean is easier to you to understand. It's the average of the data that we have for each point. So for x or for the temperature, 18.7 is the average temperature. For y or for amount, 402 is the average amount that's sold across the entire data set. Now what we do is we calculate x minus x bar. Here, instead of writing x bar, I have written mean of x because it's more easier to understand. So what we're doing is we are taking x, which is 14.2, and subtracting the mean, which is 18.7. So 14 minus 18.7, 14.2 minus 18.7, as 14.2 is smaller, we get negative 4.5. Similarly, 16.4 minus 18.7, we get negative 2.3. And you keep going down and you see since 11.9 is small, we get negative 6.8, negative 3.5, negative 0.2 since it's just 0.2 away from the mean, which is 18.7. And then we come on to the positive side. So since 22.1 is greater than 18.7, we get 3.4, 0.7, 6.4, 4.7, negative 0.6 because 18.1 is smaller than 18.7, 3.9, and negative 1.5 again because 17.2 is smaller. Now we will take care of the negative part of it, but firstly we need to calculate all of this. This is calculated for the temperature. Now let's calculate it for the amount, which is y, which is calculated in this column. So the mean is 402, and if we subtract 215 from 402, we get negative 187. Similarly, negative 77 for 325, negative 270, negative 70, and finally 406 is just 4 more than the mean, which is the difference that we were looking for. Then 120, 10, 212, 142, 19, 43, and 6. So these are the observations minus the mean of the data that we have. We don't need to sum them up as of now because that won't be necessary. If we take a look at our formula again, we don't need the sum of individual columns subtraction from the mean. We need the sum of that product. So now we calculate the product. We go on this side, x minus mean of x, which is this column, multiplied by y minus y of mean of y, which is this column. So we multiply negative 4.5 by negative 187. Let me just show you that that's entirely what we have done. Okay, let me just open up calculator. We have negative 4.5 multiplied by let me just take a look at the scientific calculator, because in Windows for some reason this does not work. So 0 minus 4.5, which will be negative 4.5, multiplied by 0 minus, and we have 187, so 187, and we have 841.5, and we just round it up to be 842. I have unfortunately opened up something. I need to close it. Okay, now that is done, here we have it. So we have calculated this. It's 842. When both of them are negative, then we get a positive result. If one of them is negative, then we get a negative result, and if both of them are positive, then also we get a positive result. So we have 842, 177, 1476, 245, negative 1, 4087, 1357, 667, negative 11, 168, and negative 9. So all of these values are calculated using this. As you can see, 6 multiplied by 1.5 is 9, and it's one of them is negative, so we get negative 9. We do need the sum of this because as we look at the formula, we have summation of x minus x bar multiplied by y minus y bar. This is how the formula gets interpreted and expressed. We calculate each individual term and then we move outwards. We calculate x minus x bar, we calculate y minus y bar, we multiply them, and then we move outward and sum it up. So this is 5325. Then we move on to square them. So why are we squaring them? Mainly because in the denominator we need the square and the under root of the square. So we go there, square it up. Again, squaring anything, whether it's negative, whether it's positive, all of that is going to lead us to a positive result. So we do that. X minus a mean of x will be the thing that's squared, which is this one. So negative 4.5 is squared. We get 20.3. We get 5.3, 46.2, 12.3, and it's negative 0.2. If we square it, we get 0.04, which is approximately 0, so we take it as 0. 3.4 square is 11.6, 0.7 is 0.49, which is approximately equal to 0.5, so we take it as that. 41, 22.1, 0.4, 15.2, and 2.3. So all of that is done. Now we do the same thing for y minus mean of y, or y minus y bar. Again, taking a look at the formula, we see we need to calculate y minus y bar whole square sum as well. So for that, we need to calculate y minus y bar. And we calculate it. We get this huge number, 34,969, which is approximately equal to 35,000, but for the sake of clarity, we're keeping it precise. 5,929, and these are the whole large numbers that we get by squaring these numbers. And as you can see, these numbers are pretty large, so when we square them, you are going to get huge numbers like that. And finally, square of 6 is 6. We get that, and we sum them all up again. Sum of x minus x bar whole square would be 177. Sum of y minus y bar whole square is 1,74,557, or 174,757, depending on where you are. So now what we need to do, we need to calculate the entirety. Here's what we have. We need to divide x minus x bar and y minus y bar whole y minus y bar sum, which is this. We need to divide 5325 by the under or square root of the product of 177 and 1,74,757. Why is that? When we take a look at the formula, summation of x minus x bar whole square, summation of y minus y bar whole square, we need to multiply both of these values, and then we need to take a look at the under root, and then we need to divide it by this. So let's take a look at that. Let me do this in this format. We have 5325 divided by the under root of, okay, so this is not working. Let's just under root the summation. So 177 multiplied by 1,74,757. This is going to be a big number, and this is what we get. We take the under root of it. It's somewhere close to what we have already, so we can see the number is going to be somewhere around 1, and we take 5,325 and then we divide it by it, and we get 0.957. So the correlation we're getting is 0.957. So this is our correlation, and yeah, this is our correlation. We're getting it by dividing this. Let me just write it out. 5,325 divided by 177 multiplied by 1,74,757. So this is the calculation. This has led to this result, which is our correlation. And here we are. So as you can see, this is a really mathematically intensive computation. We had to calculate a lot of things based on these two values. So suppose we have a really large data set, then that would be really difficult for us to calculate. This is precisely the reason why we don't use these the entire population, and we take a look at a small subset, which is called the sample, and then we calculate the statistical analysis using the sample of the data. So this is what it means. As you can take a look at it, it's pretty easy to understand. It's not that difficult. We have again, let me just reiterate what we did, because it could be a little confusing. We have temperature, we have the amount. We want to calculate whether or not this influences this, and for the result that we've gotten, it strongly positively correlates with the temperature. So if the temperature rises, the amount of the items sold would be rising as well. If the temperature decreases, then the amount of product being sold will decrease as well. If this was negative 0.957, then that would be opposite. As the temperature increases, the amount of product sold would be decreasing, and as the temperature decreases, the amount of products sold would be increasing. So now let's take a look at what we did, just to reiterate so that you can understand. What we do is we take these values. This is x, this is y. We need to calculate the correlation between x and y. Now calculate the mean of x, calculate the mean of y, because in the formula it states that we need to calculate the mean of y and mean of x so that we can calculate the other values. Now calculate another column in which we take a look at the observation magnitude of a single observation minus the mean of that column. So here we get these values. Similarly for y, we do the same thing and we get these values. We don't need to sum them up. We move along, and then we need to multiply these two values to get the final value that we need, and then we sum it up. Here is what we have. Then we move along and we get the square, the mean of as the observation minus the mean of the observation, mean of the entire column, and this is what we get. For that, we calculate the sum of that. We do the same thing for y. We calculate the sum, and finally what we do is we plug all the values that we have calculated so tirelessly, and we plug them into the formula, and here's the number we get. To reiterate, the number is going to range from -1 to +1. This is what we'll be getting at. So this is -1 to +1 is what we'll be getting. Do you want? So this is what we'll be getting. I think Excel was having some issues there. So this is the numbers that we'll be getting. No correlation coefficient will go beyond -1. No correlation coefficient will go beyond +1. To get complete one correlation is you want to correlate one column with itself. So if I had a column that had three values, 10, 12, 14, another column it had the same values, 10, 12, 14, and if I have to find the correlation of these two, this would be positive one. So this is what it means. Okay. So we find the correlation. If it's somewhere close to 1, then it's highly positive correlation. If it's somewhere close to -1, it's highly negatively correlated, and so on and so forth. And we'll take a look at what that means in a moment. So this is how you calculate these things. This is how you interpret it. It's a lengthy calculation, I will admit, but it's easy to do with calculators, or sometimes a program will do it for you. But for a large data set, doing this is going to be a little difficult. So with that in mind, let's move ahead and see what else we have. So now that we have done correlation, let's take a look at positive correlation. So positive correlation is a term that is used to describe a positive linear relationship between two quantitative variables. So we have positive, negative, and no correlation. These are the three kinds of correlation that we have. Positive correlation is used to describe a relationship that we just saw. As the temperature increases, the amount of the product sold increases. Let's say that the product is ice cream or some sort of cola, some sort of soft drink. So things like these increase their sales when the temperatures increase. Similarly, their sale decreases when the temperature decreases. So this is how you calculate that. This is what positive correlation actually means, that it increase in one aspect is going to lead to an increase in the other aspect of your application. So with that in mind, let's take a look at no correlation. So no correlation describes no linear relationship between the two quantitative variables. So suppose we find the correlation between them to be 0.1, negative 0.1, 0.2, negative 0.2. This is really low correlation. And for us to, we don't really have to think about that kind of correlation. That's not really significant correlation. So we can term it as no correlation. That is to say that this has no impact on X has no impact on Y, or Y has no impact on S. To give an example, let's say the height of a person, does it have a correlation with the mood of a person? How does a person feel? Well, there's no significant interpretation that could lead us to believe that yes, this does happen. So that's no correlation between X and Y. If X was the height and Y was the mood, or X was the height and Y was the income, then that would be no correlation. So similarly, we have negative correlation. So in negative correlation, what we have is we take a look at the negative linear relationship between the two quantitative variables. So to give you an example, as the age of a person increases, their bone density decreases. So this is what is known as a negative correlation. Increase in one quantity is leading to decrease in another quantity. When we find the correlation coefficient for these two variables or these two values, it's going to be somewhere around -0.7, -0.8, -0.9. Above -0.5, it could be considered strong, and as close as it gets to -1.0, it's considered to be that strong of negative correlation. If it's really strong negative correlation, that means slight increase in one would lead to slight increase in the other. It would be inversely proportional relationship, if you can think about that in that manner. Now we've understood this, but one other concept that I'd like to introduce to you before we move on from correlation is the topic of causation. So I'm just opening this up so that you can take a look at something else. Correlation is not equal to causation. That's a really important aspect to understand. Just because we randomly select two values, we calculate the correlation, and that means that and they have really strong correlation between them. That doesn't mean that increase in one is the exact thing that's leading to increase in other thing. That could be purely coincidental as well. So we need to understand this. We need to take this into account when we're trying to deal with negative and positive correlation. So to give you an example, let's say that you're trying to, let me just go down here. Let's say that you're trying to calculate the correlation between temperature and stocks. STOCKS. Sorry, I misspelled it. Now, if I'm trying to calculate the correlation that temperature and stocks have, let's say that the correlation comes out to be 0.7879. right? That's a strong positive correlation. But does that mean that increase in temperature is leading to increase in stocks? No, of course not. That would not be a substantial evidence for any kind of thinking. So even though you get positive correlation out of two variables, that doesn't necessarily mean that you're going to get that means that one variable has strong influence over the other. If it's in a controlled environment, you need to take a look at a lot of things. You need to firstly take a look at the variables. You need to take a look at what they mean, how they go, how might they influence each other. If they do have positive correlation, then you take a look at whether or not that positive correlation indicates some sort of influence of one over the other or something else. So all of that is taken care of by correlation. That's why we need to understand correlation. That's why we need to use correlation in a way that makes most sense. So if this was negative 0.79, it would be the same thing, mainly because we don't know, because even though it indicates strong negative correlation, that doesn't mean that it's equal to causation. That's the reason that it's causing the stock markets to decrease or increase. So with that in mind, let's take a look at what else we have. Just move it up. So we've taken a look at positive correlation, we've taken a look at negative correlation, and we've taken a look at no correlation. Positive correlation means increase in one value is leading to increase in another value. No correlation means increase on one value or decrease in one value has no impact on the other value. And negative correlation means increase in one value is leading decrease in other value. Correlation ranges from -1 to +1. And one other thing that I forgot to mention is that this the correlation coefficient that we're trying to calculate has a special name. It's called Carl Pearson correlation coefficient. So it's called Carl Pearson's correlation coefficient. There are other correlation coefficients as well. There's something called Spearman's rank correlation, in which you try to find the correlation between the ranks of particular things. If you rank it from 1 to 10 based on their magnitude and so on. So if you're trying to if you're trying to find correlation between these kinds of things, then take a look at Spearman's rank correlation. Let me just write it out. Spearman's rank correlation. I guess you can see it. Now that's why we use that, and this one was Carl Pearson correlation. This is by far the most widely and commonly used one. So let's take a look at what we have next. So now let's take a look at standard variance and standard deviation. So this would be the first time we'll be using a mathematical formula to calculate something, and it won't be very difficult. We'll take a look at what that means and how to calculate it and what that signifies in a moment. Firstly, let's understand what is standard variance, what is deviation, and why are we taking a look at them simultaneously? Why not one by one? Well, standard variance measures how far a set of number is spread out from their average. Standard deviation is used to express the magnitude by which the number of a group differs from the mean of for the group. Now, it's a little difficult to understand, but when you take a look at the formula, you can understand why we are using them one by one. They're the exact same formula. The only difference is that standard deviation is the square root of standard variance. So when we calculate standard variance, when you take the square root of standard variance of a particular data set, you get standard deviation. So the way we're calculating it is, first of all, standard variance is denoted by S square, which is the square of standard deviation. So what we do is, firstly, we calculate the mean, which is recognized by X bar. So let me just show you. When you take a look at this, so this is what is called X bar. X bar is the mean of the data. So we calculate the mean of that data. We calculate the difference between the mean and one particular row of data. We calculate their square and then we sum it up. So when you see this symbol, which looks like a perpendicular M, or M that's rotated 90 degrees, it's called sigma. It's used to calculate the sum of a particular group of data. And n minus 1 means whatever number of records we have minus 1 from them. So that's what it means. Now now standard deviation is exactly the same thing. As you can see, we have sigma, which is the summation, we have x, we have negative or minus symbol, we have x bar, which is the mean, we calculate the square, we calculate the difference, we square it up, we sum it up, we divide it by the number of values minus 1, and then we take the under root. That's the only difference. So when we take a look at the standard deviation and standard variance, the only correlation or relation between them we find is the you can take a look at the square root. Now, one thing to understand is that standard deviation and standard variance are quite useful because they are one of the most used tools to understand how varied our data set is. This is why we use standard deviation and we use standard variance. So as you can see, this is for, as you can see, the formula says sample variance and also says sample standard deviation. So what does the word sample represent here? If you think about it, we have already discussed sampling our data and getting a small sample out of a large population. Now, for various statistical reasons, people have started to use n-1 for sample variance, and for population variance, when you're calculating the variance in the entire list that you have from which you selected the sample, you don't use n-1 as the denominator, but you use n, simply n. Now, it's not going to be a huge difference, but since we're taking a small part of it, we correct for it by reducing the number of samples. So that's what it means. Now, if you're using standard deviation, standard variance for a population, then you use not n-1 as the denominator, but n as the denominator. Other than that, it's the exact same thing. So with that in mind, let's take a look at an example. I have already created some data and we'll take a look at them one by one. So this is the data that we have. First thing we have to calculate, if we take a look at the formula once again, is we have to, we're calculating the mean of the data first. So to do that, let's just calculate the mean. Mean would be, and to calculate the mean, we first need to sum it up. So let's take the sum of the data. 5, let me just move this a little aside so that I can do a cumulative sum and understand what the data is. 5 plus 7 is 12, plus 4 is 16, plus 4 is 20, 28, 36, 45, 45 plus 7 would be 52, and plus 8 is 60. So this is our sum. We get 60 as our sum, and mean would be 6. Since we have 10 data elements, the mean would be 60 divided by 10, which is 6. So we've gotten 6 as our mean. So now we need to calculate x minus mean. Let me just remove this. This was just for our convenience. Cut this, paste it here. Here we are, what we have. So x minus mean would be 5 minus 6, which is negative 1. 7 minus 6, which is 1. 4 minus 6, negative 2, negative 2. 8 minus 6 would be 2, would be 2, 9 minus 6 would be 3, 7 minus 6 would be 1, 8 minus 6 would be 2. So now we need to calculate the square of it. Square of 1 is 1, square of 1 is 1, square of 2, negative 2 is 4, square of negative 2 is 4, square of negative, so square of 2 is 4, same as negative 2, 9, it's 1. Now for some reason Excel is giving me some error, so I'll just write 1 like this, and 4. This is what we have. Now what we need to do when we take a look at the formula again is we have this symbol called sigma. We've calculated the mean, we have calculated the difference, we have calculated the square of the difference. Now we need to move a step out and we need to sum it all up. Let's do the summation. To sum it all up, we just need to go from the top. 1 plus 1 is 2, 2 plus 4 is 6, plus 4 is 10, plus 4 is 14, 18, 28, plus 4 is 32. So this is what we have, and finally what we need to do to calculate this standard variance is n minus 1. So n in our case is 10. So variance would be 32 divided by 10 minus 1, which is 9. So to calculate the sample variance, all we have to do is we need to just calculate 32 divided by 9, and we get 3.5 as the result. 3.56 is actually the result, but let's just call it 3.56. So that's the result that we have as of now. Now, if this was the entire population that we were calculating the result from, then we would go 3 by 32 divided by 10, which would be 3.2. But as of now, we are calculating the sample one, and mostly this is the one you will use to calculate the sample deviation. After that, all you have to do, we have calculated the variance. Now the deviation would be the square root of 3.56. So to calculate this, all we have to do is calculate the square root of 3.56, which is 1.8867. So we could calculate 1.89. And there you have it. You have 1.89 as the let me just write it. Standard variance and standard deviation. So this is how you calculate standard variance and standard deviation. In case your data was really spread out, then this would not be the number. You will get some large number like 12.5 or something like this. So if you wanted to calculate the variance of two data sets, then you can calculate it using this. Now, why is it useful? Let me just remove it all. In case you wanted to take a look at it again, you can just take a look at it now. I'll be removing it now. So why is it useful? Because it helps us understand our data more. Let's say that I have data that has 5 records. All of them are 5. The mean of this would be 5. Another data set that I have, let's say here I have 4, 4, 5, 6, 6. Calculate the mean of this. 6 plus 6 is 12, plus 8 is 20, plus 5 is 25, divided by 5 is 5. Now the mean is the same thing, but the data is not the same because we have difference in data. Now this is a really small difference, so that doesn't really matter, but this is what it means. To calculate a standard deviation of this, we'll get 0, and for this we'll get something along the lines of 1 or something like this. So as you can see, standard deviation tells us the missing part of the story that the mean could not tell us. It tells us that how the data is spread out across the mean. So if it's just everything in the data is just as same as mean, then you get a standard deviation of 0. Else you get a standard deviation greater than 0, standard variance greater than 0, and you can just calculate the under roots and all that to calculate the variances and deviations from the standard data set that we have. Okay, so now that hopefully you've understood what standard deviation and standard variance is. For most cases, we calculate the n minus 1 using the sample variance formula, not the population variance formula. We use the n minus 1 as the denominator, and to calculate the deviation, we simply calculate the square root of sample variance. Now, if you have standard deviation and you want to calculate the sample variance, just square it and you'll get the same result. So that's what that means. So now let's take a look at normal distribution. Normal distribution is quite an important topic in statistics. If you have tried to study statistics before, you might have come across this topic as well. And this has to do with the distribution of the data that we already have, the shape of the distribution, and what does it tell us. So normal distribution is a term that is used to describe the distribution which when plotted gives us the shape of a bell curve. So if you've ever taken a look at a bell, it looks like this. This is sort of like a dome shaped. This is what it means to have a bell curve. As you can see, the first image or the first sub image in the image is negatively skewed. It's not entirely a bell curve because it's tilted or skewed slightly towards the right. So that's a negative skew. And similarly, the third image is positively skewed because it's tilted or shifted to the left hand side. So it has a mean of 0 and standard deviation of 1. Now mean of 0 is a little difficult to understand. So mean of 0 is just an assumption that we make. It's not necessarily the case that the mean has to be 0. It's just the mean is in the center is what it's trying to say. And everything on the left is in negative and everything on the right is positive. That's also an assumption. So the standard deviation of 1 basically means that we can express our data more clearly. We'll take a look at what that means in a moment. Firstly, let's take a look at what it means. If you take a look at the images that we have right at the bottom, you can see that it's a distribution of frequency and data. So when you take a look at this in the normal distribution where there is no skew, both mean, mode, and medium all fall on the same axis. Now, that's also an assumption. It's not necessarily the case that they will fall on exactly the same axis, will be the exact same location. There would be slight deviations, but mostly they'll be very close. On the other hand, positively skewed mode is on the leftmost side, then there's median, and there's mean. And as you can see, most of the data is on the left hand side of the mean and very less of the data is on the right hand side of the mean. And quite similarly, we have data in which we have everything on the left hand side, and on the 50% of the data is on the left hand side and 50% on the right hand side. That's the normal distribution. And with the same thing, very less of the data is on the left hand side and very much of the data is on the right hand side. That's why it's the negatively skewed data. So this is what normal distribution means. So that's what it means. But what does it matter how the data is skewed? Well, as it turns out, it matters quite a bit, because if your data is negative, if your data is distributed normally, then there's a lot of assumptions that you can make. There are a lot of formulas through which you can essentially calculate the probability of randomly choosing a data and getting it in some part of the distribution. So let's take a look at that. That is what is known as the empirical rule. The empirical rule tells us the exact same thing that we just said. So let's take a look at what that means. Let's take a look at the empirical rule. So as you can see, it's the same image that we had for the normal distribution. Let me just show you. If you take a look at the normal distribution, it's completely bell curved, and mean, mode, and median are right at the center. We have the same thing here, but there are a few numbers right below it that describe -1, -2, -3, and 68.3, 95.4, and 99.7. So let me just explain what that means. So using empirical rule, so let me just explain. Empirical rule is used to remember the percentage of values that lie within a band around the mean of a normal distribution, with a width of 2, 4, or 6 standard deviations. So let me just explain. Let's say that the standard deviation of our the mean of our data is 65, and let's say the mean is 50 and the standard deviation is 10. If I wanted to calculate where, if it's a normal distribution, then I can quite correctly say that approximately 68% of my data would lie somewhere around 50 plus minus negative plus minus the standard deviation. So it would be from 40 to 60, and my 68% of the data will lie here. Why? Because that's the way the normal distribution is spread out. That's the shape it makes, and when you calculate the area underneath the shape, this is what we get. So let me just show you. Okay, so here we have -1 standard deviation, here we have +1 standard deviation, and here we have 0 standard deviation. And mean is, let's say that mean is signified by mu, and it's equal to let's say it's 50. Similarly, we want to take a look at standard deviation. Let's say it's called S, and it's equal to 10. So our data is not really spread out, and it's somewhere clustered around the center. Now I wanted to check how much data does lie between my standard deviation of ±1. So we take a look at this. So 50 minus 1 times the standard deviation, which is our standard deviation is 10. So 50 minus 10 is equal to 40. So starting from 40 and then ranging till 60, because 50 plus 10 would be 60, which is this one. So we're getting 40 to 60, we are getting 68.3% of our data. Similarly, if we move, instead of 1 standard deviation, we go to 2 standard deviations, we get, let me just clear it all up, erase all link on the slide, and let me just show you once again. Yeah, so if it's 2 standard deviations, then we have 50 minus 20 to 50 plus 20, which is 30 to 70, and we, from within those values, we get 95.4% values, and 3 standard deviations we get 99.7%. Now another thing to understand here is that if we have this, then what is the if we have the normal distribution and we can calculate this, then that makes it really easy for us to understand many other things about our data as well. We can confidently calculate how much data lies below a certain point, if it falls here. So let's take a look at that. Here, let's say that I have a data point. I have some data. I'm not going to show what the data is because that's not really relevant here. Let's say the mean is 65.5 and the standard deviation is 14.5. Now I want to calculate, let's say we have to calculate all the points. So mean times 0 standard deviation. So let's say SD. Yeah. So let me just expand this out. and we'll be calculating this for all. Let me just move this aside so that we can just calculate it, and we'll calculate it for all the points that we have. So in our presentation, we'll take a look at the image. We have -3 to +3 standard deviations because it explains most of our data. Yeah. So this is the formula that we have. 0 standard deviation, we will have 1 standard deviation, 2 standard deviation, 3 standard deviation, 1, 2, and we will have 3 standard deviations. We want -2, -1, and here would be the -3. Similarly, -1. Paste it here. -1. Instead of it being -1, we need +1, +2, and +3. So what does this mean? Let me just take a look at this first. Yeah, now we have it completely. Let me just expand this out. And now if we plug in the value, which is 65.5, let me just open up the calculator. So it would be 65.5. We go up 65.5 multiplied by, and here we'll be taking a look at 2 standard deviations. It's not multiplied, actually, it's addition. So we need to add 1 standard deviations, 2 standard deviations, 3 standard deviations, so on and so forth. Let me just correct this mistake of mine. Yeah. Now if we take a look at this, 14.5 multiplied by -2 multiplied by 14.5, and we have 29. So if we add 29 to 65.5, we get 36.5. So here's 36.5, and if we add 29 to 65, which is, let's say, 29 plus 65.5, we get 94.5. And similarly, we'll get the same thing here. If we calculate the standard deviation multiplied by 2 standard deviation, here is 14.5, as they've already calculated here. So we get 14.5 multiplied by 2, it's 29. Oh, so this is for this. Yeah. And now let's take a look at 65.5 minus 14. It's 51.5. And if we add 65.5 plus 14.5, we get 80. And finally, we just have to do the same thing. 14.5 multiplied by 3, 43.5, 43.5, 65.5 minus 43.5, and we get 22. So at the top it's 22, and at the bottom it's 65.5 plus 3 times, it's 45.5, right? 45.5 plus 65.5, and we have 111. So this is how the distribution looks like. And now all we have to do is we have to figure out what is the what does our data look like. So when we take a look at this, 68.3% of our data is spread across 1 standard deviations away from the mean, both front and back. So if we calculate this range, 68% of our data lies from 51.5% to 80%. This gives us a good understanding of what our data is. So if somebody says, what is the probability that if I randomly choose a value in your data, it would be between 51.5 to 80%, and it would be 68%. This is the kind of question that empirical rule lets us answer. So this is 68%. Similarly, if we take a look at 2 standard deviations, so if somebody says, what is the probability that I randomly choose a data point in your data set, and I get a value between 36.5 and 94.4. So this would be in our data set. If I take a look at this correctly, this would be 95.4. And similarly, if it's 22 and 111, then we get 99.7. And if we take the entire data set ranging from the smallest to the largest value, then that's 100%. So that's how you calculate this. Now let's say that that was not the question. So it's 68.3%. At the mean, it would be 50%. 50% of our data is here. Then we go up and we go down. So we have 68.3% and we divide it by 2, we get 34.15. So all we have to do is we have to add 34.15 to 50 and 84.15%, and we subtract 34.15, we get 15.15. If 15.85, sorry, 15.85. So if you want to check 84.15 minus 15.85, we get 68.3%. So this is what the distribution looks like. Similarly, we can go a little back as well. If we take a look at the data, so we have 65.5, and if we subtract 36 if we calculate that and that, we can get that as well. So if somebody says, what is the probability that I choose some data that's up to 65.5, that's 50%, because 50% of our data lies still here. Then if somebody says, what is the probability that I get data that is below 51.5%, that's 15.85%. And you can go along these lines and understand what is the probability of other things as well. Similarly, if somebody says, what is the probability of getting data that's below 84.15%, below 80, that's 84.15. And if somebody tries to find out data above this, then it's 84.15 minus 100%, so 15.85%, which is exactly this one. So this is how you can calculate the probability of people choosing some data point that is that falls within some purview of your data. Now the question becomes, when is it useful? Well, it's useful in statistical analysis when we try to figure out what is the probability of one person choosing some data that's here. Now you might be wondering that that's a bit easy to do, because we are only asking questions like the data point that we have, that's 1, 2, or 3 standard deviations away from our data set. So if we're checking what is the probability of getting 65.5, that's exactly our mean, and no one's going to ask that. So if that is your question, then there comes other things such as z score and all that, which we'll take a look at now. But to understand this is what happens. We take a look at the mean, we take a look at the standard deviation, we add and subtract it. This is only applicable to the normal distribution. Empirical rule is only working on normal distribution. If you don't have a normal distribution, this is not going to work. So take a look at normal distribution. If it's not normal, then try to add more data, subtract more data, try to figure out whether it's normal or not, and then normalize your data there as well. Here it's 95.4% of data, and we have 68.3 from the middle. So if we calculate 95.4 minus 68.3, so the data is 27.1%, and if we divide it by 2, it's 13.5%. So we can just take a look at this. We can just go 13.5% minus 15.85%, and this is what we will get. And similarly, if we add 13.5%, then that is what we will get. So 13.55, 15.85 minus 13.55, we get 2.3%, and 84.15 plus 13.55, and we get 97.7%. This is the data point that we are getting. If I take a look at this now in a presentation, yeah, so 90, this is what we are supposed to get, and this is the data set that we get. So this is how you can calculate all of it. When you take a look at it, this is what it looks like. This is the if you take a look at the data that we have, then that's the percentages that we get. 95.4%, sorry, 95.4% is supposed to be. So wait, okay, yeah, so 50%, 84.1% is what we're getting, and then 84.1 plus 13.6. Similarly, we can go 18 minus 34.1 minus 13.6. So 50 minus 34.1 minus 13.6. And it's 2.3%. So we're getting it correctly here, and this is what we're getting here as well. And finally, if you want to take a look at the entire data set, then that would be 97.7%, 99.7%, and 0.03%. So that is it. That is what we get. And let me just add it here, 99.7 and 0.3. Okay. So now what we're trying to do is we're trying to find out what is the percentage of values that we get between that. So that allows us to find out the probability that a person will take in some data. So if somebody says what is the probability of me choosing a value that's below 94.5 in your data set, that is a mean times 2 times the standard deviation, mean plus 2 times the standard deviation. I need to correct these as well. So this is what you get when you do this. You get 95.4% of your values are below this. So if somebody chooses or tries to choose data between this, then they're going to get 95.4% chance of choosing a value between 94.5. So this is what it means. And now let's take a look at this. Is for a very standardized example, but if you were to expand it out, then what will it look like? So let's take a look at Z rule for this. That's what it means, the Z score. So now we'll take a look at z-scores. Z-scores allow us to apply empirical rules to not just the cut points or the standard deviations or the data points that are just 1, 2, or 3 standard deviations away, but any data point that we want to. So firstly, let's take a look at what z-score means. Z-score is a measure of how many standard deviations below or above the population mean a raw score is. A raw score is basically any data element, any value of x that we choose. So here's what we can do, and it can be placed on the normal distribution curve. Again, these scores only work for normal distribution. If it's not normal distribution, if it's skewed to the left or right, if it's positive or negatively skewed, then that is not going to work. Now, as you can take a look at this image and this image, you can see that they are positively correlated. So as you can see, these scores are exactly the same as here. There's 0, then there's -1, then there's -2, then -3. These are the z-scores of the cut points. So any point that's -1 standard deviation away from the mean, that will have a z-score of -1. Similarly, -2, similarly -3. But if you move ahead and see how can we calculate the z-score of a particular value that doesn't fall on these points. So how do you calculate z-score of something that falls here? So there's a formula for it, and then we have to take a look at a table called z-score table. Let's take a look at the formula first. This is what the formula looks like, where the z-score is calculated by subtracting that score from the mean and then dividing by the standard deviation. Let's take a look at this with the example that we had previously seen, empirical rule. So this is what the table looks like. We have mean, then we add standard deviation. Let me just correct them once and for all. We have to add it, add this, and add this. Now that we have that, we have to calculate the z-score. So here I have just taken the liberty of calculating, just correcting these values to match the values that are here. These values in which we have 68.3% of data, 34.1 from the mean on the left side, 34.1 on the right side, and that's how this looks like. So that's what it means. And now let's take a look at this. So we have mean and we have standard deviation, and what we can do here, if let's say that I wanted, I can easily calculate what would be the probability of something that, if I want to take a look at the probability of getting something between 65 and 80. So if I want to calculate the probability that a person picks one value from our data set and the data set is between 65.5 and 80, the probability will be 34.1. Similarly, if somebody wants to pick between 80 and 51.5, so if we take a look at this, this would be 34.1 plus 34.1, which is 68.3. So that's how you can calculate that. Now, if we move ahead here, let's say that these are scores, and you say, okay, I want to choose a student in your classroom, but what is the probability that I pick a student whose score is below 50? So let's say X is 50, right? So according to the formula that we had seen, let's take a look at this one. So again, yeah, so this is what the formula is. Z-score will be calculated like this. I would have to go to here. Z score would be the score minus this mean, which is 65.5, and this would be divided by, let me just put this inside brackets, and this would be divided by 14.5, which is the standard deviation. So let's pull out our calculator to do this. Let's remove all other values. 50 minus 65.5, it's negative 15.5, and we divide it by 14.5, and we get 1.068. So this is the value that you will get if you want to take a look at the z-score, but that's not really the probability, that's just the z-score. So when you want to take a look at the probability of something, you just need to go to new window and go and Google search z table. You can download a PDF version of this as well if you're using it again and again, and there's a website called ztable.com. Open that website, and the score that we had gotten was negative 1.06. Let's call it negative 1.07. So we go down, and this is the table for the negative values. Right down is the value for positive value. So we take a look at the negative values. The value that we are interested in is negative 1.07. So here we go to negative 1.0, and 0.7 is, if you take a look at the table, 0.7 is the last third column. So negative 1.0, and then the last third column is 14.23. So this is the probability that we will calculate, that will get this 50, which is 14.3. Now similarly, if I had x is equals to 90, what would be the probability? Now we could very easily understand that if it's 90, then it's between 80 and 95, and so it's going to be between these two standard deviations. We take a look at the image that we had earlier just to calculate. This one was 84.5, so it's going to be somewhere around 90, right? But how do you calculate it exactly? Just like we did before, we'll calculate it using the same formula: 90 minus 65.5 divided by 14.5. I'm not putting brackets here, but you can take a look at that. Let me just put it so that it's easier to understand. So now if we calculate this, 90 minus 65.5, this would definitely be positive, divided by 14.5, and we get 1.689. Let's call it 1.69, right? So we take a look at the table here, 1.69. What we have to do, we go to the positive table, 1.6 on the left hand side and 9 would be on the right hand side. So here 95.45%. So we're getting 95.45% for this. Where is it? Yeah. 1.69, 95.45%, or 0.9545 would be the probability. But if we were to convert it to percentage, then 95.45. That's how you calculate the empirical probability of something in a normal, selecting a particular value in a normal distribution using the z-score. So again, just to reiterate, firstly, we calculate the empirical score. That's only done using the standard deviations and the mean of the data, and that tells us how far away from the mean is a particular data point. So two standard deviations away, or one standard deviation removed from the mean and one standard deviation added from the mean, it covers around 68.3% of our data set. We go up, it's 95. We go one step up, it's 97.7% of our data set, and we go one step up, then it's 100% of our data. So that's how you can calculate standard cut points on our data. But how do you calculate the probability of selecting something using the standard, using the z-score? So we take z-score for this. Firstly, we take the mean, we take the standard deviation, we take the number as x. So we take the number as x to be 50, then we plug it into the formula that we have just taken a look at. Yes, the formula: x minus mu divided by, say, standard deviation. Mu is the mean, so 50 minus 65.5 divided by 14.5, and we calculate this and we get the value. We take a look at that in the z table. So we open the z table, we go into the negative formats, and we take a look at that negative 1.07, negative 1.0, and 7 is 14.23, and that's what we calculate here. So that's how you do that. It's very easy to understand once you get the hang of it. And with that in mind, let's move on to the next topic. All right, so now let's take a look at linear regression. It's one of the most important topics that you can learn, and you can use it to make predictions on your own data. So let's get started. So linear regression is a commonly used technique in predictive analysis that allows us to make predictions based on the data that we already have. It is used to create a model that can predict dependent variable using an independent variable. So dependent variable would be the y-axis, the thing that you're trying to predict, and the independent variable is the x-axis, the thing that you're using to make the prediction. So to give you an example, let's say that you have a house, or you want to predict the house price in a particular time. So to do that, you would first need to take the price of the house during a specific period of time, and you need to then use the house. You then need to use the area of the house as the x-axis, and y would be the price of the house. So how does it relate with the area of the house? So how, if the house has a large area, then we get to pay more price, and if it's smaller area, then we get to pay smaller price. But the thing is, how do you calculate what price should you pay depending on what are all the houses and what are all their areas and what are all their prices? So this is where this comes into play. So the formula is quite simple when you take a look at it. It means that y, which is the house price, would be equal to the population y-intercept. Y-intercept would be, if you make a graph out of all the data that you have, the line that will be determining the price of your house, where would that line start? Where would we start drawing that line from the y-axis? That would be the y-intercept, and the population slope coefficient would be how tilted the line should be in which direction should it be tilted. So that's what is called population slope coefficient. It's the independent variable is the thing that we're trying to predict. So in place of x, we'll be putting in the area of the house, and then finally there would be some error. So our data will not exactly match up to what we have. There would be some issues with the data, and we'll take a look at what that means. So here's the first thing. Simple linear regression is useful for finding relationships between two continuous variables. If you have two variables, you can find you can find the relationship between them. One of the variables is called the predictor, and the other variable is called the response, or the dependent variable. So independent variables and dependent variables. Independent variable is the one that's on the x-axis. That's the one that we have with ourselves, and the y-axis is the thing that we're trying to make a prediction on. So as you can take a look at the examples down below, if we have some data point, we create a scatter plot out of it, and then if we pass a linear line through it, linear is the straight line, then does that in some way or the other may help us understand the data that we have. That's what's known as a linear relationship between the data components of x and y, or the independent and the dependent variables. So this is what it looks like. Let's take a look at this, the tenure and the monthly charges. So let's say that we were to graph it. This is what the scatter plot would look like, and this is what we get. Now, after we have created linear relationship, we can draw a straight line using that linear relationship. And now let's say that somebody says, I want to make a prediction of how much should be the price or monthly charges, given 45% or 45 would be the tenure. So to calculate that, let me just take out my pen. What we do is, firstly we take a look at the x-axis. Here is where, let's say 45 is here. We cast a straight line till here. I guess I couldn't pass a straight line, but here's where it will be, and then we pass a straight line till here. So it will be somewhere around 70. That's how you make predictions using linear regression. So with that, let me just remove it all once again. Erase all ink. And now let's move forward. So again, this is what the formula looks like. In general, the data doesn't fall exactly on the line, so the regression equation should include some implicit error term. Now the fitted values or the predicted values are typically denoted by y hat. So y would be our intercept, our coefficients, our value of x plus some error. This error would be the difference between the prediction that we made and the actual answer. And the predictions are basically just intercept plus slope multiplied by the x value that we have. So if the slope value that we get is greater than 0, then that's a positive relation. Or you can say that when x increases, y will also increase. or you can also take a look at this as positive correlation. Similarly, if b is less than 0, then it's negative relation or the negative correlation. And here's where the error come into play. The error here is the difference between the predictions and the line that we draw. So let's say that this is the line that we draw between age and salary. We get this line, and now the predictions that we have made is the difference between the points on the scatter plot and the line that we have made. We calculate the distance, we sum it, we square it, we do a lot of things. Let's see what we do when we want to calculate it. Let's say these are the three lines that someone gives you and says, let's try and figure out which one is the best line for us to make a prediction of in a linear regression algorithm. So these are the three things. So how do you do it? Well, quite easily, you just calculate the actual minus the prediction and square it. Squaring it basically because even if the numbers are different, then negative numbers and positive numbers still equal. When we square a negative number, we get a positive number. So that's why we square it. The one that has the lowest value of the residual sum square, which is also known as RSS, which is the error here, is the one that's the best here. So in our case, the orange line, which is the middle one, is the best. Then that's the blue line. Then it's the green line. Now let's take a look at some example to understand how to do this. Okay, so this is what we have here. Let me just, yeah. Now, if I were to take a look at some example, here it is. I have some example. Let's say that this is X and this is Y. X could be the hours the person studied, and Y could be the score that they obtained or something like this. So it could be anything. This is just for an example. So the first thing that we have to do, let me just go back to the formula so that you can see. B0 plus B1 X1. So Xi. So to calculate it, I have to go here. Calculate the mean of X, which is 3, which is just 5 plus 4 plus 3 plus 2 plus 1 divided by 5. 15 divided by 5 is 3. Similarly, we divide this, which is 20 divided by 5 is 4, and we get the mean of X and Y. Now we calculate X minus mean of X. This is what we get. Y minus mean of Y. This is what we get here. And then we calculate the square of these X minus mean of X, and we get the sum of that value to be 10. So 2 multiplied by 2, negative 2 multiplied by negative 2 is 4, negative 1 multiplied by negative 1 is 1, 0 multiplied by 0 is 0, and similarly 1 and 2 multiplied by themselves is 1 and 4. So we calculate the sum of them and we get 10. And now we calculate the sum of multiplication of mean of X and mean of Y, X minus mean of X and Y minus mean of Y. So we get negative 2 multiplied by negative 2 is 4, 0 multiplied by negative 1 is 0, 0 multiplied by 1 is 0, 0 multiplied by 1 is 0, and 2 multiplied by 1 is 2. That is 6. And now what we have to do is we have to find out these things. So B1, which is the intercept, is going to be the mean divided by 10. 10 would be the number of values. So we do this. 10 is this, which is X minus mean of X raised to the power of 2. So what we do is we calculate the 6 and we divide it by 10 and we get this, which is this. Basically what we're doing is we're calculating this and we are dividing it by the X minus mean of X square. So this is what we're doing. It could be a little counterintuitive to understand, but once you do understand it, you will understand it quite easily. Let me just again copy and paste it. For some reason Excel is not working correctly. Let me copy, paste. Yeah. So this is what we've calculated here. Let me just expand this here. And this gives us B1, which is the slope. So slope is 0.6. And since it's positive, that means that the line is going to be straight up. And now let's calculate the intercept using this formula. So one formula that helps us calculate intercept is mean is equals to the intercept plus the slope multiplied by the mean of X. So I calculate mean of X here is, as we know, 3. So we take 3, we multiply it by the intercept that we calculated, which was 0.6. This would be 0.18. And this is when we plug it into the formula, we get this. So 4 equals to B0 plus negative 0.6 multiplied by 3. 4 is equals to B0 plus 1.8, and B0 is equals to 4 minus 1.8, which is 2.2. So this is the value that we get. So we have calculated both B0 and B1. Our calculations are done. And this is the equation that we come in when we plug it into the equation that we have. So this is the equation we have, B0 plus B1 multiplied by x of I. So when we go back to it, this is the equation that we've come up to, and when we plug all the values of x in this, these are the values that we get as predictions: 2.8, 3.4, 4, 4.6, and 5.2. Now, as you can see, they are not that same as the y we have. These are the values of y that are actual. These are the ones that are predicted. And now we need to calculate the error. To calculate the error, all we have to do is we firstly need to calculate the actual y minus the predicted y. So actual y here is 2. 2 minus 2.8 is negative 0.8. 4 minus 3.4 is 0.6. 5 minus 4 is 1. And 4 minus 4.6 is 0.6, and 5 minus 5.2 is 0.2. So as you can see, our predictions are quite close to what the actual values are, but they are not there. So now we square them so that this negative value doesn't cancel out the error. Even if the error is in the negative value, it's still an error. So we calculate the square of this 0.64, 0.36, 1.36, 0.4, and we get the error to be 2.4. So this is the entire error of our line, and we get the correct line here. Now, in case this was sometimes when we try and figure out instead of doing it this way, instead of calculating all the values, many computer algorithms, what they do is they randomly set these values of B0 and B1. They create a line, then they calculate the error, and they shift the values of B1 and B0 in such a way that the value of error changes. And if shifting it in one direction reduces the error, then they keep shifting it in that direction, and as soon as the error starts increasing, they start moving back. So that's how they do that. Now that we have done that, and we have understood linear regression, and we've also understood how to calculate the error.
So the next few minutes, the next few hours of our session is going to be focused around a few tricks of the trade on how a data science interview is generally like. Data science interviews are slightly different from other interviews, from your regular software. From a regular software job interviews or IT interviews. Um, the approach is a little different. The level of questioning is a little different, and the type of questions are very different. And what the recruiters look for is also slightly different from other interviews. So what we'll try and do is we'll try and throw some light on what it means to be in a what it means to have to be a part of a data science interview. The next few hours, I'm going to talk about my experience of taking interviews and my experience of attending interviews, both mine and my colleagues, and then within the organizations that I have been. I've kind of put together that experience of mine, and in general, the data science community, and I've put that together, and then we'll talk about that. Okay. Um, the types of data science roles, right? What are the different kinds of data science roles that are typically available? Let me just write it as four major types of data science roles. So there are four typical types of data science roles, or rather 80 to 90% of the data science roles can be nicely categorized into these four categories. All right. The first is, of course, data science consulting or data science consulting or services teams, where a data scientist is essentially a part of the consulting division of a given organization, and he or she is expected to talk to a customer, yeah, and deliver solutions based on the requirements that a customer poses. Now, under the data science consulting or data science services, again, this is generally of two types. I think I should probably edit it as we go along. One is technology consulting teams, and the other is strategy consulting teams. Your technology consulting companies are like your any other data science or any other services consulting companies, like for example your Infosys, TCS, your Accenture, Cognizants of the world. I mean, these are the major names. Of course, there are of course a lot of other companies that do consulting as well. For example, the team that I am a part of in Microsoft, I am into services, I'm into consulting. Similarly, Amazon also has their own consulting team, Amazon Web Services has their own consulting team. Google Cloud has their own consulting team. So there are a lot of consulting teams that are available outside, which help customers solve problems. While that is technology consulting, strategy consulting companies like your Bain, McKinsey, Boston Consulting, and your Deloitte, EY, and so on. These are strategy consulting companies, KPMGs, and they are they are not heavily focused on, while they're of course not heavily focused on the technology per se. As a data scientist, you would be helping the frontline consultants, the strategy consultants, derive some meaningful information out of data. So while in the first case, while in technology consulting companies, as a data scientist, you're expected to front face the customers, talk to the customers, gather requirements from the customers, and build AI solutions, build AI data science solutions. The second category of teams, second category of work is your strategy consulting companies, where you, I mean, you will get a chance to talk to the customers, but you are not there to build an extremely complex solution. But what you're doing there is you're essentially helping the businesses make sense out of data, right? Um, you're helping your frontline consultants make some sense out of data. All right. So two types of work that we're talking about over here at this point. Um, and we'll dig into each of these in more detail as we go along, right? We'll talk about how, from a skill set standpoint, how each of these roles is different from each other. Um, the next category is captive or in-house data science teams. Like, for example, take Airtel, for example, Airtel or Vodafone, or let's say your Geo, right? All these telecom companies, they have their own product. Their primary business is telecom. While their primary business is telecom, you would also have data scientists who are working for Airtel, for Geo within their organization themselves. So think of yourself also as a consultant, but you are within the organization. So in the first case, you are a data scientist who is from a different organization, helping them solve the problem. While in the case of a captive or an in-house data science team, you are inside the organization. You are one among the insiders. You understand the business very well, and hence you're expect. So you still get to solve a lot of data science problems, but all the data science problems that you will get to solve are for that organization only. Take the example of scientist in Airtel, for that matter. You would be solving different problems. Like, for example, you would be solving churn prediction for Airtel. You would be solving potential customers, prospective customers for Airtel. You would be solving what is the best offers that you should be providing for Airtel, and so on and so forth. So everything that you would do, there are different kinds of problems that you would be solving as an Airtel customer. As an Airtel employee, you would be working within their organization. Most of the companies these days actually have their own internal data science, captive data science teams. Um, if they cannot afford, or if the internal data science teams are not very tech savvy, that's when companies decide and say, Airtel decides to say that, okay, this particular skill set, we are not it's not available within our organization, and we'd like to solve this problem in a much more robust fashion. That's when they say, okay, let's look out. And that's when they reach out to your technology consulting companies, like your Infi, whatever, and they reach out to them and take help of them to solve problems, right? So they outsource work to them. That's the two kinds of uh, that's basically the primary difference between a captive data science team and an in-house data science team. Sorry, an in-house data science team and a consulting team. The third category is product development teams. Take, for example, this particular, in Microsoft PowerPoint, if you just go to design, and I'll show you a small example. If you go to design, and you on the right top, you have something called as design ideas. Right? You see these design ideas over here. So these design ideas, yeah, I click on that, the complete layout changes, right? Now, simply speaking, this is also a data science solution, right? what they're doing over here is they're making use of AI. They're trying to understand the content that is available here, and based on the layout, they're trying to map the content in my slide to one of the many layouts that are available to them, right? So, and based on that, they're also defining a color scheme and so on and so forth. So this is a nice AI problem at the background that they're solving. But who's solving it? There's somebody who's actually solving it, right? Um, like for example, somebody is actually building that building that recommendation engine internally to make sure that the product is enhanced, right? Take for example somebody who's working with the go to webinar team at the background, who's looking at these call logs and then trying to make sense of um, at what time is the call are the calls dropping, when is the somebody is trying to make sense out of all the information that is coming out of this particular product, right? So product development data science workloads are of two kinds. One, um, you're helping somebody build a new feature, right? A new intelligent feature, right? Like for example, building this design ideas feature in Microsoft PowerPoint is is driven by a data scientist in the Microsoft PowerPoint team. So you work for the PowerPoint team, you are building new features for PowerPoint, and you are essentially trying to bring in all possible intelligence to make sure that the Microsoft PowerPoint as a tool or as a product is getting better and smarter and smarter by the day, right? That's the kind of work that you would be doing in the case of a product development team. The other variant, when you're working inside a product development team, is when you are monitoring the monitoring the performance of a particular product. So currently there are so many features that are available in Microsoft PowerPoint. All of us, even, I mean, honestly speaking, we don't even know what features are available, right? So there are certain features which are useful, there are certain features which are not useful. When a new feature is deployed, how do I know if somebody has liked that feature or not? Right? I'd want to make sense out of that information as well. So as Microsoft, I'd like to I'd like to make sense of if there is somebody, if my customers are liking a specific feature that I have rolled out. Right? How would I know that? If people are frequently using it, if they are using it time and time again, if a lot of customers are using it, if there's some stickiness to that particular feature, and if the feature does not have any glitches, if there are no bugs in that particular feature, then I can assume that my customers are using. So devising those kind of ideas is also, or those kind of analysis is also something a data scientist would do when associated with a particular product team. Okay. um, so in short, what we're trying to say is when you are a part of a product development team, you are trying to make use of AI, machine learning, or data science to help build help build AI driven features, or you are also helping data scientists, or also helping your product teams make sense of data that is being generated from tools, from these products, right? There is a lot of data that is generated. You're trying to understand, do some root cause analysis and try and understand if a particular product is being used well or not, and so on and so forth. Okay, that's the kind of work that product development teams essentially do. The fourth is research work. Now, let's be very honest, research is something that is definitely beyond our league right at this particular point. Now, this is not because it's not that we are not capable of getting into research teams. Absolutely no, it's not about capabilities. It's simply about the depth of knowledge that we really require to move into a research team. So if you were to be a part of a particular research team in a given organization, so for example, you would be working on cutting edge technologies. You would need super so in the field of AI, you would be working in, let's say, the most advanced algorithms. You would be working on the driverless cars and things like that. So you would be working for the future. Essentially, that is what the research teams are, right? So in short, with the skill sets that we have, and we are looking at people who have extensive educational background, who've done a lot of research work in the past, to be a part of such research teams in general. Um, I think as a budding data scientist, I think I would try to concentrate on the first three. I try to get into any of the first three, again based on your request. As a new data scientist, as somebody who's moving into the industry, I would be looking at one of those three categories of work. Now, coming to the differences between each of these roles, right? A data science consultant is expected to have very, very good communication skills, right? When I say very good communication skills, it's not that the person should be able to speak great English. It's not just about the language. It's also about the ability to articulate complex data science concepts in a very, very simple manner, right? Complex data science constructs, complex data science algorithms, or the complex analysis that we generally perform in in a very easy and a consumable form. Take for example, explaining a linear regression output to someone who does not understand data science. How would you explain a linear regression output to someone who does not understand data science? Or take for example, how would you explain a decision tree algorithm who does not understand data science? How would you do that? Can you think of ways and means to explain it to someone who cannot understand data science? That is the kind of skills we're looking at. So you should be very, very conversant. While you of course have to be tech savvy, you need a good exposure to technology across all these roles. Across all these four roles, your primary skill set is of course machine learning, AI, and data science. I mean, your data science is your primary skill set. Everybody should be very good with data science here. The thing that differentiates from one role to another role is the type of role and the quality and the other ancillary skills that are required for you to be a part of that particular team. For example, in the consulting team, you will require extremely good communication skills. You should have the ability to, you should be um, you should be open to first talking to customers, receiving feedback from customers. At times the conversations could be very, very tough, because you should also have the ability to quickly empathize with the customer. When I say empathize with the customer, it's essentially about understanding what his problem is, trying to make it your own, right? And try to make it your own, and try and find a possible data science solution to him, right? In most conversations that you would like to have with your customer, the most important skill that I have learned over a period of time is the art of listening, right? You need to listen to their problems. So because in most cases the questions could be like, most of the customers, and I'll tell you this, right? We're working with a diamond manufacturing company in Africa. I'm not saying people in this particular country in Africa or this particular diamond mining firm doesn't understand data science, but they have their problem. The problem that the plant, that the diamond mining company has is, look, we have a lot of mining equipment that is there in the that is outside today, that basically mines diamonds from the ground, that drills into the ground, and excavates. We have a lot of machinery that does this excavation, haulers and diggers and your excavators and so on. But the problem that we have is that if any of these equipments go down, then we are in deep, deep trouble. So the biggest problem that we have is that um, these machines of course do generate a lot of data, because all these machines are very big excavators. There are a lot of sensors on it, a lot of data is generated, but we don't know how to use that data. We don't know, and we don't know when a machine is likely to fail, right? So we would want to make sure that we'd want to ensure that we want to maximize the amount of time that they're working for. That's a business problem that they have. It's a genuine business problem, right? Where is data science here? The problem statement that was mentioned has nothing to do with data science, right? So as a data scientist, what you are expected to do in that particular conversation is you're expected to talk to them and understand and convert that business problem, the complex business problem that they've mentioned, into a nice problem that you could solve as a data scientist. Okay, so they would require you to identify when a machine is likely to fail, because if they can identify when a machine is likely to fail, then they can automatically go and try and fix that particular component even before it actually fails. Service that particular component if it actually fails, because if it fails, then it's a big problem. If it fails, then there is a huge issue, because then the machine is going to go down, and so on and so forth. So even before, if it actually fails, if I'm able to predict, then that is amazing. How do I predict? Okay, I have sensor data, and I need to predict, will a machine fail or not? Great. That's a classic. So that's when you go back and you ask him this information. Are you capturing sensor data? Yes, we are capturing sensor data. Are you capturing the failure related data? Let's say the customer is also capturing failure related data. And then you ask the customer, okay, where are these stored? Who is responsible for all of these? And that's when you try and get some technical details out of that conversation, convert that into a data science problem, use that information, and solve a simple binary classification problem. For you, it is a classification problem. For them, it is some IT solution. God knows what the IT solution is. That's okay, it doesn't matter. You are solving data science at the background. You are doing some predictive, it's called as predictive maintenance. You're trying to predict when a machine component is likely to fail. These are the kind of skill sets that a data scientist is supposed to have when you are in a consulting environment, right? Converse with the customer, convert a complex business problem into a data science problem. That's fun. When you are, as opposed to, let's say, when you are in a in-house captive data science team, you are in a data science team within an organization, meaning you are doing data science, some kind of analysis on the kind of products that are available outside today. You're solving various problems there. So in such a case, as a data scientist in a captive data science team, like let's say for Airtel, or let's say for Reliance, or let's say for any services company that we have outside today. For example, Swiggy, you're a data scientist at Swiggy. You're trying to understand the various ways and means people make orders and things like that. So there are different data science problems that you have for Swiggy. What you are expected to understand as a data scientist in that team is you should understand the domain very well, right? You should understand your customers very well. As a data scientist in Airtel, you're supposed to understand how Airtel works. In general, how this telecom industry in India is. In India, telecom industry, zero loyalty. Nobody cares. Are we sentimental about which provider we take up? Do you feel bad to quit Airtel and join Jio? Nobody is, right? Nobody is really sentimental about this. So understanding a customer sentiment, understanding customer behavior, understanding the business in and out is what you are supposed to do. So if you're a data scientist in SBI, you should know that SBI customers are people who do not understand, who don't even know if they have an account, all the way until people like Nirav Modi and Vijay Mallya, who don't know how much money they have in their account. So you have different kinds of people. So your strength as a data scientist in such companies is the domain understanding, domain knowledge. You should be really strong with or rather, you should be able to build your knowledge about how your customers are and things like that. For example, let's say you are a data scientist at Pepsi, right, or PepsiCo, or let's say you're a data scientist at Coca-Cola. So you should be able to understand how does these fun foods or beverages companies actually work. You should be able to understand, okay, what kind of people consume Pepsi the most. What is the primary differentiating factor between PepsiCo and Coke? Not in the product, but in generally in terms of sales. Which countries do prefer Pepsi versus Coke and things like that. So you should be able to get a holistic picture of these beverages, food and beverages industry. So that's what you're expected to learn from a captive or in-house data science team. The third and fourth is, especially the third one, is where you've got to be technically strong. Not only data science skills, you should also have good coding skills. Uh, Learning R or Python is not going to be enough. You will also have to learn some other programming languages, like for example a C# or a Java or any of those, or basically a .NET or Java, where you're building more. You're building products you just don't understand. So you're expected to not only be a data scientist, but a data scientist come a product developer, a software developer. It has to be a combination of the two. So if you want to get into product development teams, you need to understand both sides of the coin very well. Okay. um, that's the kind of variety that you're expected to have from one to another. I'm going to set aside the fourth. I don't think it's worth talking about the fourth at this particular point, because we are primarily targeting any of the top three at this particular point, right? Um, Within these three that I have just mentioned, there is a nice differentiating factor in terms of, um, of course, pay-wise, things are different as well. Different organizations pay differently, and it's also based on what kind of skill set you have and what kind of background you come from. But I think each of these companies also have a different role, meaning a designation. There are different kinds of designations, and I'll talk about those designations as I go along. Data scientist is one of the most common designations: senior data scientist, junior data scientist, associate data scientist, principal data scientist, and so on. That's the most common uh, uh, designation that is generally given. A data science manager, or vice president data science, and things like that. Um, but there are certain roles such as business analyst, data analyst, data engineer, data platform engineer, and things like that, big data engineer, which sound like they have got to do a lot with data science, but honestly they probably have little to do with data science. We will also talk about those roles in some time, and I will talk about it in the last few slides, where I talk about what kind of questions do you need to ask and what kind of aspects do you need to be careful about. In general, when I talk about data science roles, we call it as a data scientist. That's the name of the designation as well that you would generally be given. Um, so so those are the kinds of roles that are available outside, or the types of roles that are available outside for you out today. uh, you have the flexibility to pick any one of these. Whatever interests you, pick up one, one of those works. Like, for example, currently at Microsoft, I am in a technology consulting company. Microsoft Services is that. Microsoft also has a product division, so I could choose to move from the first pointer over there to the third pointer. Yeah, I could move into a product development company, and I could a product development division of Microsoft, and say that, okay, I'd want to work on, let's say, in the PowerPoint team, or I'd want to work in the Outlook team, O365 team, or let's say I can decide and say I'd want to work in Microsoft Teams team, where we are building these productivity tools and so on. Or I could decide and say I'd want to work on um, I'd want to work on the Azure cloud team, and so on and so forth. So there are different I can make that shift whenever I want. So certain organizations have both kinds of roles, a combination of roles. So you have to understand what role you're applying for even before you actually get in, and what kind of work that you will be doing before you get in. So yeah, so that's, I'm going to pause there for a minute. If you have any questions, you can ask. Before I move on to the next section, I'll talk a little. The next section is essentially where I'll talk about how the interviews are, what are the kind of interviews and so on. I'll talk about that in a few minutes. I'll pause there. If you have any questions, you can post. Um, Kiran has a question. What is the difference between data scientist, data analyst, and data engineer? Look, I'm gonna try and answer that question in a few minutes. I will answer that question, Kiran. It's not just those three. There's other uh, um, there are other roles as well, like business analyst and so on. I'll try to explain them when I'll try to explain that. Don't worry about it. Yeah. What is your experience on data side? Um, Okay. Is this session useful for people who are new in this field? Yeah, it's absolutely useful for people who are new in this field, because it's worth you understanding what kind of roles are there, and what kind of how would the field, how would the interview generally look like, and how do you need to prepare yourself to move into the field of data science. That is useful. Please explain the role of strategy consulting. Yeah. So you see, the thing about strategy consulting is that, um, yeah, let's say you are okay. So the kind of work that strategy consulting teams do, as opposed to technology consulting companies are, they come in to solve a particular operational or a technical problem that you have within your organization. Like, for example, take the example of the fact that, let's say, you have within your organization there is a particular process a ticketing system. You have a ticketing system and you'd like to make sense out of the data that is being generated out of the ticketing system. Or let's say you are an automobile manufacturing company and you'd want to make sure that the experience that is being provided to your users is very good. So that's when you call for a technology consulting company and say that, look, I have this technical problem. I have data getting generated here, and I have my customers. I'd want to make sense out of the data. That's when you call in a technology consultant. So you know what problem you want to solve. It's a technical problem. It's a technology problem. That's what technical consulting companies do. Technology consulting companies do. Um, while strategy consulting companies are slightly different. So take the example of let's say companies which are slightly getting derailed, right? um, Companies which are struggling to make sure that their business runs properly. So in such cases, um, that's where the strategy consulting companies come in, and they tell you how to revamp your business, how to relook at your business. So while technical consultants talk to middle management and your CIOs of the organization, or let's say your IT managers and things like that, strategy consultants talk to the CEOs of the organizations or the CXOs of the organization. So it's more top down. They don't provide technology solutions. They simply tell you how to run your business. They will give you ways and means to improve your business. Where do you need to spend your money? Should you spend it on marketing, or should you spend it on finance and things like that? They will be able to give you a more outlook into the business and into the industry. That's the role of strategy consultants. Now, as a data scientist, what is your role? In that, as a data scientist, when you're a part of a technical consulting company or technology consulting company, you know what problem you're solving. There is making use of data science and artificial intelligence. You have to solve a technology solution, meaning um, you have to build a platform where month on month you will be able to predict which customers are likely to quit. Or take the example of the diamond company that I just mentioned about, where we are simply predicting when is a machine component likely to fail, right? So that's a technology solution. There is no business setup over there. You don't need anyone. Problem is already defined. You're just using technology to solve problem over there, right? Um, um, so as a data scientist, your problem is very simple. But in the case of a strategy consulting company, while of course the MBAs are going to help them understand their business well, what they're also going to do is they're just going to throw some data at a data scientist, and they're going to expect them to just get some information out of it, like perform segmentation on their customer data, just to understand, perform segmentation on some market data that is available, and try and understand what kind of roles are there, what kind of customers are there, and what is the market like, and what is the opportunity like, and things like that. So while a data scientist in a technology company heads the discussion, the data scientist in a strategy consulting company is more or less like slightly back office. They help them solve the problem, right? So that's the primary difference between the two. Yeah, hope that answers your question. Um, see, role of strategy consulting. Can I attend an interview after completion of data science in R? You can, and I'll talk about that and talk about the necessary skill set in a few minutes. I'll talk about that. I think it's worth talking about it. So the question is, can I attend an interview after completion of data science in R? The answer is yes and no both. Let me tell you why. So reason why I say this is because if you want to be a data scientist, right? In general, there are a few aspects that you have to look at. Sorry. Uh, like for example, there are a few skill sets that are mandatory for you to be a data scientist, mandatory or critical to be a data scientist, right? So I'm going to classify them as need to have and good to have, or rather must have and good to have. The first skill set, of course, is that you should be good with a statistical analysis tool, right? The statistical analysis tool is either Python or R, one of these, right? One of these, between these two, between Python and R, either Python or R. You should be able to you should be able to use any of these tools and perform a kind of analysis, right? That's the first thing. The second is, of course, about while this is about a statistical analysis tool, you should have the ability to slice and dice your data, right? You should be able to extract, transform. You don't have to extract data, but you should at least be able to query data and do some joins and things like that. You should be able to merge data sets, merge two tables, and do some joins and things like that. So SQL is important, right? You have to learn SQL. In general, learning SQL comes in very, very handy. And I'm sure if you want to be a data scientist, data scientist interviewers or recruiters generally look for, your resume should have this and this for sure. Additionally, the modern day, what people are also looking for is people are looking for deep learning skills. Deep learning, not only the concepts of deep learning, but also the ability to work with them. Like for example, they're looking for TensorFlow or Keras, tools like that, right? TensorFlow and Keras kind of tools. These are the kind of skills that are more or less mandatory, if I may say. In addition to these, um, good to have skills are, understanding about big data. All right, if you understand the concepts of big data, then that is very good. I mean, if you understand how big data works, how the big data ecosystem is, and how Hadoop works and things like that, that is pretty good, right? That helps. It's good to have. I mean, it's not mandatory to have, it's good to have. um, Experience with working on, let's say, tools like Spark. I'm just going to mention this here. Tools like Spark and so on. When I say big data, Spark or Hive and things like that, it's quite useful then. Good to have skills. Git. Most people these days undermine the importance of learning Git. It's a small tool, you can learn it on the job, but yeah, it's kind of important that you know Git. These are productivity tools, collaboration tools. It's important that you know that. The other tools, of course, is people often mention this, any visualization tool. If you know a visualization tool, that is useful, like for example a Tableau or a Power BI and things like that. See, this is not mandatory, right? This is not mandatory. You see a lot of job descriptions where people mention Tableau, Power BI, ClickView, this and that and nonsense. See, this is not mandatory. This particular thing is mandatory for people who are into business intelligence, BI and reporting. This is for them. This is not for us. This is not for a data scientist. For a data scientist, you would essentially be looking at a tool like a Python or R, SQL, and a deep learning tools like, let's say, a TensorFlow and Keras and things like that. Okay, so that's the spectrum of skill set that is generally asked for a data scientist. In general, if you want to be a data scientist, you should be able to tick off the boxes on the left side. Of course, this is not the only thing, meaning uh, when I say you should know tool like R or Python, that doesn't mean you just learn R. You should learn R with machine learning and data science and statistics and things like that. You should know those as well. So statistics, you should learn stats, you should learn machine learning, you should learn what the various classification, supervised, unsupervised learning algorithms, and so on. In addition to that, you need to learn any one of the tools, SQL, deep learning with TensorFlow and Keras. What we are seeing increasingly is people are asking for Python more than R. I mean, there was a time, until this particular time, a lot of people are working on R, but increasingly people are starting to learn Python and move towards Python slightly more frequently. These days, a lot of production systems are built around Python than on R, much more increasingly. So yeah, that's essentially the spectrum of skill set that you will have to build to be a data scientist. So now answer yourself: is it good enough? If you do a data science course in R, can you attend an interview? You can definitely attend an interview, but the chances of nailing that interview would be higher if you can make sure you at least tick the boxes off that you see on the left hand side. Okay. Yeah. So having business knowledge or domain knowledge is very important, especially for this particular role. For the captive or in-house data science role, having that domain knowledge is super critical. Or rather, if you have that edge, if you have some domain knowledge, then that is an add-on that really helps in adding to your data science skills, right? The other thing is, for freshers, of course, people do understand that they might not have knowledge, they might not have a lot of business or domain knowledge, which is okay. That's okay. We're not talking about So for freshers, it's okay. Freshers and 4 years, 3, 4 years experienced folks, you might not have a lot of experience in a particular industry, which is okay. That's totally fine. Um, the ones on the top, you might not have a lot of experience with a specific industry. You might be working with various industries. So you should have the ability to understand the problem very quickly. That is what you're expected to have, and as a data science consultant. Okay. Um, when it comes to business models, what types of roles can a finance background candidates expect in data science? Is there any scope? Yeah, absolutely. Yes. See, for example, if you have a finance background, if you come from a finance background, you can work in data science teams for financial services companies. It's like, for example, in Hyderabad, you have Broadridge or you have DE Shaw. These are all financial services companies, and Synchrony Financial. And there are these companies are financial services companies, and you could look for a data science role within those organizations. So your finance background really comes in handy, plus your data science skills is an add-on, and the combination of that would work really very well. See, data science today is more or less omnipresent. You name an industry and there is definite implementations of data science in that particular industry. uh, so it's all about finding that organization that gives you, or finding an opening that gives you a nice combination of the two. So there is definitely scope in financial industry as well. In fact, finance industry is one of the most um, is one of the larger consumers of data science, so that you will have a lot of opportunities in that particular field as well. Yeah. I'll take one last question before I move on. How to get complete domain knowledge before we start working as we need to? Yeah, see, I answered that question. It's not possible for you to get the complete knowledge about a domain without actually working in that particular domain. So if you are new to that domain, it's okay. You will learn the domain as you go along, but you should have the ability to um, at least consume that domain knowledge and have an intuition around that particular domain well, right? So you should have that particular knowledge around how how that particular industry works. So for example, if I ask you how does the telecom industry work, as a consumer, at least you should be able to dig deep into what that particular industry is and things like that. I mean, you don't have to be an expert about telecom industry. You should at least be able to talk as a consumer, how does that industry work like. So that's the kind of thing. Hope that answers your question. How is Excel related to the role of data science? Excel is a preliminary skill. Excel, forget about data science. Excel is needed if you want an IT. Excel is needed irrespective of a data science role. You need to have Excel skills, yeah, all throughout. So Excel skills is definitely needed any which ways. Yeah. Mukesh, you're spamming. So I've seen your question. So please, yeah, I understand you want me to answer that question. So just give me a second. I'm looking at the others. Which statistics topics are important for data science? Statistics in general is quite useful. So for example, starting with basic statistics to your inferential statistics, performing hypothesis testing, all the way until ANOVA. Your statistics concepts are quite useful, are generally useful. How often do we use them on a daily basis? It depends on the kind of work that you're doing. Like, for example, if you are in a product team where you are evaluating if a particular person has liked the product or not, so then you'll essentially be doing some kind of hypothesis testing. The null hypothesis is that the person did not like the product. The alternate hypothesis is the person likes the product. So how will you break this hypothesis? You will have to perform a statistical test for it. So yes, statistics is quite useful for the field of data science. It is quite helpful. So Mukesh, to your question, any scope who have background experience in HR? Yes, I mean you do. Any experience is useful experience in the field of data science. So for example, there are a lot of companies who are specifically building around who are solving problems in the HR world. So doing analysis about employee attrition and things like that. So there are specific companies who are into, let's say, payroll and things like that. Compensation analytics is one of the other industries which is very, very rapidly increasing. Do we have a scope for that in Indian companies? Probably not, because Indian HR teams are not all that tech savvy yet. They're getting tech savvy by the day, because majority of the work is still very manual in a lot of HR teams. But in general, it will grow. The importance of data science in HR teams will definitely grow by the day. Right? We're looking at it in the future. I'm working as a business analyst. How can I see? In general, what's happening is In general, the field of data science is how do I put it? Is on the move. Right, the field of data science is rapidly changing, and the field of and the spectrum is very quickly changing. What that means is the concepts of data science will remain. It's See, there is a reason why we call this data science and not a data technology. This is not a technology, this is science. The reason why we call this science is because there are certain machine learning, and these are concepts. They are ways of solving a specific problem, right? It's a way of analyzing data. It's an approach towards analyzing data and extracting patterns out of data. So the field will stay, the tools will change. So it was let's say SPSS and SAS a while ago, until very recently. R had a very high demand. Now Python is growing into demand, and slowly what will happen is Python might fade off, something else will come. So the tools will keep changing. At this particular point, at this particular point, what we're seeing is Python is growing in demand. Uh, I know most of us over here in this particular session have done an R course, but R course is the preliminary course. So that's one of the reasons why we see people either learning R or Python. People who have based their learning on R are eventually moving into Python. But let's understand this: irrespective of the tool, the concepts remain the same. Decision tree as an algorithm will remain the same irrespective of R or Python. So learning a tool should not really bog you down, to be honest. You should be able to learn a tool like R or Python irrespective. I mean, it's all a matter of practice, but the concepts will remain the same. Python or R or Python will go, something else will come, some Python will come, something else will come. Then the tools will keep changing by the day. As of now, R is on slight decline, and people are picking up Python more frequently these days, and that's the industry like at this moment. So yeah, that's the reality. Okay. Difference between Last question, guys. I've been saying this 3 times now. So last question before I move on. Last Difference between data science and actuarial analytics. So the concepts of actuarial is think of data science as a generic concept that can be applied to any industry. Actuarial analytics and actuarial analysis is specifically for the financial sector. Right, you're doing actuarial analysis for the financial this thing. So yeah, I mean, think of actuarial as a specific science that is applied within a particular industry, while data science is an overall field that can be applied to any industry. An enhancement on top of the actuarial analysis can be a data science analysis in the financial industry. Right, think of it that way. So if you raise your actuarial analysis a few notches up, and then you want to use slightly more intelligent algorithms and intelligent ways of solving problems, then that's where data science and actuarial will maybe shake hands with each other. So okay, so let's move on. I do see a few questions, like for example, what type of roles are good for bioprocess engineers, biopharma. See, biopharma, again, you have to go for captive data science teams, meaning let's say you apply for your pharmaceutical companies, and you will have to be a part of their data science teams and solve problems internally. You cannot be a consultant. You'll have to be a part of their team, or let's say you are a part of their product development teams, and then you're helping them do analysis on top of doing analysis on clinical trials and things like that. So there is a lot of demand for that, especially in the pharma sector. Biotechnology as a field is growing, but biopharma and pharma in general has a lot of demand. So that's a particular field where things are definitely growing. So Shank, hope that you'll have to apply for these companies and work internally. So for example, Dr. Reddy's has a data science team, or let's say any of your pharmaceutical companies, GSK has their own data science teams. So all these companies have their own internal data science teams. It's good for you to apply and work for them. Cool. Okay. So moving on from these questions, and yeah, there's one more valid question. What is the difference between data science architect versus a data scientist role? Nandan, I am going to answer that question in a few minutes. When I get to the last few slides, I'll explain that. Anything to do with designations, guys, I'll answer those questions. And don't worry about that. So interview stages. We'll talk about the interview stages for a minute. What are the different kinds of interview stages? What are the different interview stages that are generally available? As far as interview stages are concerned, right, there are generally three major sections of interviews, three major types of interviews. Let me put it that way. Three major phases of your interviews. Let's put it that way. The first is, these days, what is happening very frequently is, for data science or any kind of role that people are applying for in general data science also, is there is a hands-on session on platforms like, let's say, Codility or Hacker Earth, or there are different platforms that are available. So what happens there is, the preliminary, and what they give you is, they give you two kinds of tests. One is an on-site test, and the other is takeaway assignment, meaning on-site test essentially is it sounds like dine in and takeaway, but yeah. So the thing is, on-site tests are essentially your 2 hours 2 hours, 2.5 hours, 3 hours kind of tests that they conduct right then and there. They give you a machine, they give you a problem, and they ask you to solve a data science problem. What kind of problems do they give you? They give you a data set, they give you a particular problem statement asking you to, let's say, build a classification algorithm for a given data set, right? The problem statement could be perform exploratory analysis on this particular data, build a classification algorithm, and tell me the metrics and tell me what are the next steps to improve a given model. Right? It could be a nice end-to-end case study, and they will give you access to internet. At times, most people who are not sadists generally give you access to internet. I know of a couple of interviews where people kind of do this. They sit right in front of your eyes and ask you to write code. But honestly, that happens very free. I mean, very less, because most of the people who write code actually Google code and write code. So let's be honest, nobody is that sadistic these days, at least. There are a few of people, of course, but yeah, it is what it is. So yes, so that's the first kind. The second kind is you could be given an assignment, and you would be asked to and you would be given some time, like let's say a couple of days or a week, and then you're asked to go back and solve the problem and then come back and present it to them. And based on that particular presentation of yours, at times it's a presentation, at times they might just ask you to share the script, or a notebook or whatever, and then based on that particular thing, they will evaluate how good or how bad or how well have you done or how bad have you done, and based on your performance in the hands-on round, they will take it forward from there. Okay. Now the things that you have to understand about hands-on rounds is that try to be as elaborate as possible in the steps that you're performing. It's okay if you try to attempt everything, try to do everything. In most cases, whenever the time duration is smaller, they do not look for complete solutions, or they do not want you to solve everything. They're probably looking at the approach of solving a particular problem. So if you're trying to solve a classification problem, there are a lot of missing values within the data set. So write good comments saying, currently performing mean imputation. This could also be performed via whatever. Other kinds of imputation techniques can also be done. Like, for example, you could use a k-nearest neighbor imputation, or let's say any kind of other imputation techniques. You could be advising them what kind of approaches you could possibly take to solve that problem. So write good comments, be as elaborate as you can. This is your one opportunity to show off your skills. So that's the first thing. So a hands-on round is more or less like a credibility setting round. It establishes your credibility, and based on the kind of code that you write, it becomes very obvious beyond a certain point the kind of skill that you have and the kind of experience you have, the functions that you use and things like that. It becomes very apparent. It shows, right? Okay, if the analysis is nice and detailed, it kind of gives us an idea that, okay, looks like the person has done some kind of work previously. So it's more or less like we're testing the waters. Even before I spend some time on an interview with you, why don't you actually write some code and showcase how well, give your best shot at this kind of analysis. I was given two assignments. Both the assignments were in my previous interviews. I was given two assignments. One was a take-home assignment. I was given a week, and I was asked to go ahead and solve the problem, and then come back and showcase the results. That was the first thing. That was the first kind of analysis. The second was. And the second kind of work that was given to me was also a take-home analysis. The first one, where I was given a data set, I was asked to solve a classification problem. It was a pretty straightforward thing. In the second one, I was asked to write the code for naive-Bayes algorithm, naive-Bayes classifier, ground up in Python. Right? I was expected to write them ground up. I was not allowed to use any out-of-the-box algorithms. I was expected to code naive-Bayes algorithm, the naive-Bayes classifier ground up using my Python skills. That was the other kind of problem that was given to me. So different people question. I give you assignments in different fashions. That's essentially what your hands-on round is essentially all about. Okay. Once your hands-on round is completed, and once people are happy about the kind of work that you've done, then the next round of technical interviews are conducted. Now, even before a certain hands-on round, certain companies do also conduct technical rounds, technical telephonic interviews, where they ask you simple questions about what is data science, and very high level questions about what data science is, just to see if you know really what you're talking about and not things like that. just to see the fitment, more or less. So the technical rounds are going to be nice and detailed. The technical rounds that I'm talking about is where you would be asked questions on asked questions by the team members, meaning the team that you're joining. They would interview you. The senior member in the team would interview you. The team managers would interview you. The product owners or product sponsors would interview you, depending upon the kind of company you're joining. If you're joining a consulting company, then the data science managers and the vertical leads would, or delivery heads would interview you. If you are joining, let's say, a product company, then the client or the product owners themselves, the product sponsors themselves could interview you. Now, the intent of interviews on each of these in each of these interviews could be slightly different. For example, while your team members are slightly going to look for your technical skills, how strong are you technically, the team managers and your principals, partners, and the vertical leads, they are looking for your ability to communicate well. The kind of skills that I just mentioned about. I was asked questions about, can you explain a data science decision tree algorithm to a naive person who doesn't understand what data science is? So things like that. So that's what the vertical leads or delivery heads intended to ask you. Third, and even within this, right? Even within the even within the product owners are essentially in product companies. They are essentially looking for do you have the ability to own a product all by yourself? Are you an individual contributor? If you're Are you a team player or not? Do you have enough data science skills to, let's say, build a product all by yourself? Do you have the enough depth in terms of your skill set, or do you have enough breadth in terms of your skill set or not, and things like that? That's what they look for. Interviews, if you have taken a hands-on round, none of the other interviews would be based on tools, right? Nobody would ask you any questions about what function should you use in R to build a decision tree algorithm. Nobody asks you questions around that. Questions can be around the questions that they ask can be, and I'm going to talk more detail about the questions can be around the kind of work that you've done, or let's say far more deeper technical questions about what is a decision tree algorithm, why should you use a decision tree algorithm, how is a decision tree algorithm different from a random forest algorithm, and how is a random forest algorithm different from bagging, and what is bagging and boosting. Questions like these could be asked at you. Okay, so that's what your technical questions could be. For people who are slightly more experienced, the kind of questions that are generally asked by senior team members or team managers are architecting skills. Like, for example, there is large volume of data coming in and you have to build a predictive model. How do you architect this solution? Meaning, what kind of tool stack will you use to store your data? Will you build your solution in R or in Python, or will you build it on a big data platform? And how will you build your training pipelines? How will you build your prediction pipelines and things like that? Those kind of questions would be asked for senior folks. For people who are, how will you operationalize a predictive model, and how will you monitor a predictive model, and things like that? So slightly more high level questions are asked, slightly more deeper technical questions around how would you orchestrate the complete model building process and retraining process. Such questions are generally asked for senior people. Okay. So yeah, that's as far as your various interview stages are concerned. In general, what I have seen is expect at least around on an average of 4 to 5 rounds, right, irrespective of the kind of role that you're interviewing for. Very recently, I applied for one of the companies. I was interviewed for 8 rounds. At Microsoft, I was interviewed for 3, 4 rounds. In one of my previous organizations, everything just happened in one room right at that particular moment. Meaning, in a span of 3 hours, all the 3 interviews were conducted one after the other. People came in and then did these interviews together. So it depends from company to company. Again, their process and their filtering process and things like that. Okay, so that's the kind of interviews that we're looking at, interview stages that we're looking at. So I'm going to hold here before I move on into the kind of questions. I'll go and take a couple of questions before I move on. Okay. Can we refer external sources while doing those assignments? Yeah, absolutely, yes. Yeah, you can mention resources. You can mention you can give references. That's totally fine. You can refer to any kind of external resources. You could use that code as well. That's totally fine. I mean, again, they will be mentioned. There are certain honor codes and things like that which are mentioned. Certain platforms don't allow you to do that. Certain platforms allow you to do it, but most people are okay. Most data scientists, when they conduct these hands-on rounds, they're okay. They don't mind you referring to any external sources. What is the difference between big data and data science? Okay, big data and data science, right? Data science is basically the art of analyzing data. Let's look at it this way. Let's take the example of a airline industry. Let's take a small example of an airline industry, right? The thing about the airline industry is think of an aeroplane and the amount of data that is generated from an airplane. An airplane generates a ton of data on each of its flights. Right? There's a large volume of data that it generates. Each aeroplane, each engine has close to around a few hundreds of sensors that generate so much information almost at a second basis. And with twin engines, a Boeing 737, for example, has twin engines, and per hour it could generate a few GBs of data. So if you think of the number of flights that are available outside today, and if you think of these engine manufacturers like, let's say, Pratt and Whitney or Rolls-Royce, they are looking at a few petabytes of data almost on a yearly basis, few millions of TBs of data that is generally generated almost on a yearly basis. So first things first, how do I store this data, right? How do I store such large volumes of data? That is what big data is all about. Big data is about the art of storing high volume data, high velocity data, and different and variety of data. Yeah, the three V's of big data. How do you store and handle such large volumes of data is all that your big data is about. Simply speaking, see, because when such data is flowing in at such large volumes and at such large space, then how do you store it? Who will help you store such large volumes of data? So that's where big data comes in, right? Storage and orchestration of the storage data pipelines, right? Building Hadoop platforms and things like that. That is what storing this data storage is all about. Did we talk about data science here? Absolutely no. This is nothing. This is basically step zero of data science. Right? What a data scientist would do is he would use the data that is stored here and then build your data science models and generate patterns out of the data. So then you would basically build your data science solutions on top of this, right? You data science, so when I say solutions, predictive models, engine component failure prediction, things like that. So basically using this data, you build a data science problem. Will you use all of the data? Will you use only a small part of the data? Depends on the kind of problem you're solving, right? So that's the primary difference between the big data and data science. Big data is the art of storing and processing large volumes of data. Data science is the art of, or is the science of extracting patterns from these large volumes of data. That's the difference between the two. You and I are data scientists. We specialize in the art of in the science of data extraction, pattern extraction and predictive modeling and things like that, while a data engineer or a data platform engineer is good at this. Data platform engineer's responsibility is to extract data, transform the data, store the data, and if possible even visualize data, such large volumes of data. That is what a data platform engineer does, or data engineer does. Okay, that's the thing. So hope that answers your question. Is the hands-on round is required for experienced people also? Absolutely yes. Currently in our team we have a few people who probably not that good, and we feeling very bad. So generally I've just recently interviewed for one of the companies and I had to take a hands-on round as well. So yes, hands-on round is becoming more and more hands-on round is becoming more and more important by the day. So yes, could hands-on round be an option? Probably not. I mean, as I said, it's becoming important by the day. So if I'm from a maintenance background, having 8 years, can we this tool help me for profile change? Satinder, let's park these questions for a later time. Can a non-technical person be a data scientist? Absolutely yes. I was a non-technical guy. I was from teaching. My first 2 years were into teaching. I'm a mechanical engineer myself, so I did become a data scientist. So yes, I think what you require is you should of course learn some programming. You will have to learn programming. You'll have to learn tools. You'll have to learn data science concepts. You can definitely become a data scientist. Absolutely yes. In fact, diversity is one of the most important things that people appreciate in the field of data science. So yeah, I mean, and what position will suit? Any position is fine. You have to learn the skills to be the data scientist. What are the ways to represent our work on the hands-on round? Yeah, I mean, so the simple way to do it is you will be given a data set. You will be asked to build a classification problem, or you will be asked to build a regression model. So you will build a linear regression model or a logistic regression model. You're essentially asked to write the complete code there. So you'll have to code. That's the best way to represent your work. Present it via, you'll have to build your charts. You'll have to look at code. You'll have to give your code and things like that. So all of that is sort of important. So yeah, the way you represent your work is via your code itself. That's it. Yeah, I mean, a few people go to the extent of creating PowerPoint presentations and things like that. The task would mention that for you. So certain people would tell you, build a predictive model and present it via a PowerPoint presentation, or build a predictive model and directly present it. We don't need a PowerPoint presentation, just share the code with us. So different people will ask for different outcomes from your assignment. For freshers, written test is compulsory. Absolutely yes. Freshers, the one thing that people expect from freshers is it's not a written test concept. There's no written test here. This is a hands-on round. When I say hands-on round, that means you're expected to write code. So Meenakshi, so I hope you understand the difference between a written test and a hands-on round. We're talking about hands-on round, meaning a coding round, a coding challenge will be given to you, and you're expected to solve problems. Okay. So the one thing that people expect from freshers is coding skills, right? Because they will not have any domain knowledge. B, they are not going to have any kind of they're not going to have domain knowledge. B, they do not have any expertise in terms of, or any experience in terms of previous work that they've done. So the one thing that they will have is coding skills. So coding and data science skills. So the obvious thing that people will ask a fresher is to write code and showcase if he or she knows how to write code or not. So definitely coding skills is important, and you will be evaluated on that. You will be evaluated on your R or Python skills. Can I use Python like VBA for automation of report? Python can be used for numerous reasons, but automating reports and things like that, Python is capable of doing much more than just that. If you want to automate the report generation, if you would want to create cubes and dashboards and things like that, I think there are a lot of other tools that are better at doing that. Python is a general purpose programming language. It is a regular programming language, Python, right? So it can be used to build websites. It can be used to do a lot of things. Python as a programming language is capable of doing a lot of things. Websites, games, mobile apps, a lot of things can be done via Python. Building web crawlers, right? We are using it specifically for data science purposes, right? And data science is different from VBA scripting. Data science is slightly different from doing your report generations and things like that. This is slightly beyond that. Maybe Python is capable of doing something like our VBA. I don't know about it, but I don't know if Python is capable of it has the ability of doing that or not. I'm not particularly sure, Ishwar, if it can be replaced for your VBA. It's a programming language. I don't know if it is capable of doing VBA. What are the ways to? Okay, is domain knowledge for a data scientist important? See, I answered this question already. So, for a data scientist, domain knowledge is good to have. If you already have some knowledge about a particular domain and you want to continue in that domain, great, wonderful. So, if you come from a pharma background, your pharma background is useful. So whenever you're solving a pharma related problem, it will always come in handy. So if you have a specific background, if you want to continue in that background, great. You can look for a data science role within pharma companies then in that case. Or if you come from a telecom background, you're working in a telecom industry, you want to continue in the telecom domain, great. Become a data scientist in the telecom domain. So if you have some background, it is always useful. What domain knowledge tells you is domain knowledge will give you the ability to identify what kind of problems to solve. So if you don't know what problems to solve, then what good are we? I mean, you've learned all the tools, but you don't know where to use it and when to use it. What's the whole point of learning those tools, and what is the whole point of learning data science in that case? Yeah. So that's what is the best part about this thing. Yeah. I'm going to take a last question before I move on. Yes. So Vaibhav, good question. Very good question. How to crack the interviews by only having training completed without having real-time experience? And I will talk about it. Yes, I will talk about it in the next slide. I will talk about what kind of questions are asked and how do you prepare yourself for the interviews. I will talk about that in the next few minutes. Yes, don't worry about it. Cool. So the next few slides are about what kind of questions are you generally asked by an interviewer. See, the thing about data science interviews is that data scientists want some kind of work. For data science interviewers want you to do some kind of work before you actually attend the interview, right? You cannot simply sit in front of an interviewer and say, look, I have done a course and I'm sitting in front of you for an interview. It doesn't fit well. It doesn't sound right as well, right? It's unfair for us to do something like that as well, because just by learning a course doesn't make you a doesn't make you. It's not just about data science, it's about any field, right? Just by doing a course, and as I told you, this is not a technology in itself. If it were a tool, then that's a different story. You can train yourself and then go and work somewhere. This is not just a tool. This is not just, you're not joining as an R programmer. You're joining as a data scientist who uses R to solve data science problems, right? Which means that you need to do your due diligence before you actually go and sit in front of the interview as well. As a data scientist, as an interviewee, you have a responsibility at your end to put up some work on your profile for two reasons. One, it establishes credibility. Two, it helps the interviewer ask you some questions. If you simply tell the interviewer that I have done data science training and you hire me now, what does he question you on? Right? He'll ask you questions on algorithms, he'll ask you questions on what statistics are. But will it give him a good idea about who you are as a data scientist, or do you even have enough knowledge about a data scientist? Absolutely no. I'll be totally upset if I see an interviewee who simply claims that he or she has simply done a course and is sitting in front of me to take an interview. So how do I dodge this then? So the questions that are generally asked as a data scientist are on, I can categorize them into these three categories. The first is based on the work that you've previously done. That means, let's say you've done a project, you've done some project. Now the project doesn't necessarily have to be project on work. Project can also be the a classroom project that you've done, a mini project or a major project, minor project that you've done within your classroom. During your training sessions, you must have done some kind of project, some kind of capstone projects, at least that. Kaggle problems, Kaggle, or let's say crowd analytics, or let's say analytics with their problems that they have, that you have hackathons or problems that are generally competitions that are generally hosted. You must have participated in at least one of them. Putting them up really adds a lot of credibility. The third is, think of in your, let's say if you're an experienced person, if you have enough experience under your belt, what you could do is in your current organization, before you're interviewing and before you attend an interview, think of in your current organizations if there could be if you look back in your past after learning the data science concepts, you definitely should be able to think of scenarios where you could have possibly applied data science. Like for example, if you are let's example, if you're in the billing system of a particular company, you're doing some kind of you're building a billing application in an industry, you're a software developer, in the billing industry, then you should definitely be able to look at billing data and do some kind of analysis on top of billing data. So, or let's assume that you are an entrepreneur, and then if you're an entrepreneur, of course there would be some accounts, there will be some information about sales, some data that you would have stored. I'm sure you could do some kind of analysis using that kind of data. What it helps is it establishes some kind of a discussion point between the interview and the interviewer. It is really important for you to put up some kind of work on your profile before you attend an interview. So what data scientists do, and because the field of data science is so large and so vast, it would be unfair for a data scientist, and all of us, see, for example, as a data scientist, majority of my recent work has been in the field of natural language processing, meaning on text data. If somebody suddenly asks me questions about image, and suddenly asks me questions about financial sector, that would be unfair on me because I've never worked in the financial domain myself. And if somebody is asking me questions about financial sector, I will not be able to answer because I don't know about that particular domain. I don't know the kind of problems that are solved in that domain. And people understand this, and data scientists know this. And as interviewers, people know that it's not possible for everybody to have worked in every industry. So what they do is they give the interviewee an option to showcase his or her skills. So these previous projects of yours will come in very very handy, because they will act as the pivot point around which the discussion will be based on, right? So for example, as an interviewer, what we generally do is we look at the kind of problems you have solved or you've put up on your profile, and then questions are asked based on that particular problem. Okay, why did you solve this particular problem, and what kind of approaches did you take to solve a problem, what kind of solutions did you apply, what kind of pre-processing steps did you perform, and so on and so forth, right? That's the reason why doing any kind of project is really really important. Just by doing a course, that is just half of the battle won. The remaining battle is to make sure that you put up some projects on the profile. Now you can put all sorts of technologies on your profile, but trust me, if you haven't put any kind of projects on your profile, at least one or two projects on your profile, it becomes very very difficult to substantiate that you know data science. So yeah, that's how people look at data science solutions. So how can you put up work? You can look at any kind of capstone projects that you've done within your course. You can put up any kind of Kaggle problems that you have solved. I hope everybody know what Kaggle is. Kaggle is a website that is used for solving data science, that is used to participate in data science competitions. So you could use Kaggle website and participate in one or two competitions and then put up that right as a project that you have done. Everybody knows Kaggle projects, so you can nicely claim that I have participated in particular competition and I have built a so and so particular model for that particular competition and things like that. The third is identify scenarios where you could solve, where you could apply data science in your current role, in your current role or in your previous work that you have done until this particular point. Identify ways and means where you can apply data science, even in the slightest of the slightest ways, right? Because if you get to apply that, then that's a very good application of data science while you're learning data science, right? So that will add a lot of credibility to your profile. The second type of questions are pure technical questions, digging deep into data science, into data science questions. Like, for example, what is a decision tree algorithm? What is the difference between root mean squared error and mean squared error? What is ANOVA? Questions around various data science concepts. And that's what your technical questions are going to be about. The third are case study or scenario based questions, meaning this is a very, very popular way of asking questions as well. So what data scientists do while interviewing people is they throw a particular problem at the candidate. So they throw a particular scenario and they ask the candidate to give a data science solution to that particular problem, right? So they give us particular scenario, they describe a particular problem statement, and then ask you what kind of technique should you use to solve that particular problem. Okay, so these are the three major categories of questions that can come towards you. One is about the work that you've previously done. Second is pure technical questions. Third is case study based questions. So let's talk about one after the other. Let's talk about the first category. Previously done work, based on the work that you've done previously. I call these the tricks of the trade. This is inside information, how data scientists generally conduct data science interviews. So when you talk about the work that you've done previously, meaning the projects that you have done previously, you have to talk about a few aspects. So let's say the problem that you have solved previously is you have solved a classification problem that can predict the churn of a given customer in a telecom company, or let's say it's not telecom company, some company, right? Let's say you'd predict the churn of a given customer for a bank, or let's say for an insurance provider. Your insurance, a lot of people have medical insurance, or let's say a vehicle. Let's take vehicle insurance for example. Not many people. If most people renew it, a few people do not renew their insurances. So predicting insurance renewal is a very, very interesting problem, a very big problem. So let's say you solve that as one of your classroom problems. One of the capstone projects that you did was to predict the renewal of a particular insurance policy. So what you do is, let's say so what you will have to talk about is a few things. The first is the business problem itself. So when you're explaining this to the interviewer, you will have to talk about the business problem. So what is the business problem? The business problem is that, or the problem statement essentially is that you're working for an insurance provider, and what you're trying to do here is we're trying to predict if a customer is likely to renew his or her insurance policy, renew policy in the next, let's say, will renew his or her policy or not. So renew policy, yes or no. So hence this is a nice classification problem that we are trying to solve. Why is it important to solve this particular problem? The reason why this is important is, the interviewer might ask you, why is it important to solve this problem? Then you would go back and say, the reason why it is important to solve this particular problem is that when if the insurance company gets to know that a particular person is not likely to renew his or her, if I predicted that a person is not likely to renew his or her policy, then what I could do is I could intervene, right? I could reach out to that particular customer, give him a phone call or send him a message or give him an offer and make him renew that particular policy, right? Why does the insurance company wants to do it? The reason why insurance company wants to do it is the insurance company does not want to lose a customer, because if a person does not renew his or her policy, then that's a problem. So I would want to predict his or her renewal even before it actually happens, so that I could intervene all those customers who are likely to not renew. So that, and once I do that, I will be rest assured that okay, I will be able to reach out to that particular customer, intervene, and try and reverse the possible outcome, and make the customer actually renew his or her policy by doing whatever. It could be by giving them an offer, it could be by calling them up continuously and following up with them and things like that. Okay, that's the business problem. So next question would be, okay, if this was the business problem, then what is the data that you have taken? You know, let's talk about the data. What data was available and how did you build this particular problem? So that's when you talk about, okay, um, renewal of an insurance policy is dependent on multiple factors. One is, and the most important thing is, the demography of that particular person, because older people are likely to be slightly more meticulous than the younger ones. The younger ones tend to forget a lot, right? So demography is important. um, Age and things like that. So demography comes age, location, income, their salary and income details, uh, right, their family size, right, and information like that. Along with this, type of insurance, right, type of insurance, the cost of insurance, um, competitor cost, or a competing policy cost, right? Because the competing policy in the market could come in for slightly more cheaper. So the cost of the competing policy, benefits provided by that particular policy, and so on and so forth. Did the person claim for that particular automobile insurance or not? Claim, yes or no? Claim bonus, no claim bonus, is it applicable or not? So you take all the possible factors. So you say that we have taken all of this data into account, and based on the basis of that, we went ahead and we tried to perform this particular prediction, right? Okay, then the next question could be, then what kind of insights have you seen from the data, right? What are the primary insights from that, from your data set? So the insights that we have seen from the data is that the renewal rate in general is around 80%. That means 80% of our population. If 80% renewal rate is a very, very high renewal rate for an insurance company, let's take that number for example, meaning 80% of the people renew their policies. Only the remaining 20% do not renew the policies. So identifying which customers are not likely to renew the policies is what we're interested in. That's the first thing. Second insight that we've seen is people who have claimed their who have performed a claim are likely to have tend to have slightly higher or tend to have a slightly higher renewal rate than the people who did not claim, because people who have claimed means that they're following their policy very closely. People who have claimed means that they have gone through the experience. So people who have claimed seem to be renewing more. People who have not claimed the policy till date do not seem to be renewing. The third is the benefits of that particular policy. People who have larger policies tend to renew more than people who have smaller policies, meaning people who have covered for a larger third party policy team seem to be renewing more than people who have not who have signed up for just the um, for just the owner policy, things like that. So you give all the possible insights. From where will you get these insights? The place that you will get these insights is by doing your exploratory data analysis. So if you have done your EDA on your data set, then you will be able to answer data understanding based questions. Okay, the next question that you will be asked is, okay, then, or the next step that you should ideally take, if the question is not asked, then that's okay. You might want to take this to pre-processing, right? What kind of pre-processing did you have to do? The kind of pre-processing that you had to do was, there were certain missing values within the data set. Hence, missing value imputation was to be performed. At that particular moment, you could be asked a few questions like, um, missing value imputation was performed. So what kind of imputation techniques did you use? We performed, let's say, use answer by saying we performed mean imputation. Okay, why should you only perform mean imputation? Can you not perform median imputation? Are these the only two approaches, or do you have other approaches? That's at that point you can go ahead and explain that we would between mean and median imputation, we would prefer mean imputation, but if the distribution is skewed, then that's when we will pick median imputation. For categorical variables, we will fill it with mode. While this is one approach of filling missing values, you could also use other techniques such as k-nearest neighbor imputation or linear regression based imputation techniques to fill missing values. So one of the categorical variables had a lot of levels in them, so we merged categorical variables together, right? And let's say there were in the age column there were certain values which were which seemed to be incorrect values. Like for example, there were certain customers whose age was around 95 and 98 and 100 and things like that. So it's unlikely that a person would of that age would be taking an automobile insurance because he or she would not be driving in the first place itself. um, so we kind of eliminated such data from our from such records from our data set, um, and things like that. So that's the kind of pre-processing that we did. You can explain that. So the question is, how do you identify outliers? What is an outlier? So that's when you answer saying an outlier is a data point which is plus or minus 3 standard deviations from the mean. So the point that I'm trying to drive here is every step that you mention, you will be thrown a question at you. There will be a question that will come your way. Meaning, if you say that you've done pre-processing, then the question would be what kind of pre-processing that you do. We removed outliers. So what is an outlier? How do you identify an outlier? The next question could be if you've done missing value imputation, how do you perform missing value imputation? If you've done scaling, what is the difference between normalization and standardization? When should you perform normalization? When should you perform standardization? Right? And such questions like these, simple questions and things like that. Right? The next question is, did you perform correlation analysis? What is the difference between correlation and covariance? Small questions, simple questions, but such questions could be asked. Right? So you've mentioned the business problem, you've mentioned the data that you have, you mentioned the pre-processing steps. Then the next step is modeling. Right? Then you talk about what kind of models did you build. I built a classification algorithm. Okay, if you've built a classification model, then what kind of classification model did you build? Logistic regression. Why did you only try logistic regression? Why did you not try random forest? So that's when you'll have to say there are many algorithms that we tried. We see that logistic regression has performed the best, and blah blah blah, and so on and so forth. At that moment, you could be asked about how do you explain the coefficients of a logistic regression model. What do you mean by odds ratio in a logistic regression model, and so on and so forth. Other questions will be asked as far as your modeling part is concerned. So at every point, you will be asked a question. The most important question that you will definitely be asked is the last part. After you build your model, what do? You evaluate your model. Right? How well has your model performed? How do you know if your model has performed well or not? The way that you will know if your model has performed well or not is by confusion matrix. Because this is a classification algorithm, you would be doing a confusion matrix. So that's where you will ask, there'll be a lot of questions thrown at you. There'll be questions around what is the difference between precision and recall, why precision, why recall, what is F1 score, what is accuracy, um, right? What is AUC, what is area under the curve, so on and so forth. A lot of questions will be asked around model evaluation. See, confusion matrix is a very good question. Confusion matrix is a very good question to evaluate if you've understood data science or not. That's like our think of it like our Brahmastra, right? All interviewers ask that question. What is confusion matrix? More or less, I definitely ask a question about around confusion matrix in almost all my interviews. I might not ask what is confusion matrix. I might ask, what metric were you measuring? Were you measuring recall or precision? Or why were you measuring recall? Why were you measuring precision? What is the difference between recall and precision? Right? And things like that. So your level of understanding around confusion matrix can reveal a lot about how much have you understood about this particular problem. Okay, so that is what I mean by preparing for your interview or talking about the previous project. So when you prepare for a particular project for an interview, and when you put up one project on your profile, make sure you understand that particular project very well. And and actually solve the problem by yourself, because there will be so many questions on your head, and try and answer as many questions as you can by yourself. I mean, if you don't know some, it's okay. I mean, there's nothing that you can do about it. In the interview, there's nothing you can do about it. But at least the point that I'm trying to drive here is, do some work and put that work up on your profile, because that is a good way of that is a good way of making people ask you questions. If they don't ask you a question, then there's no way I can understand if you are a good data scientist or not. So that is that is what you will have to do, right? Put as much, make sure you don't have to mention all of this on your profile. You just have to mention that you solved so and so particular problem statement. um, and in during the interview, this will come in very handy. You need to know about that project very, very well, in depth. You have to have in-depth understanding. You have to have in-depth understanding about the project. I'm sorry, can you hear me? Vaibhav says he's unable to hear. Okay, good, thanks. um, okay, so that's the kind of questions that you would generally be asked as far as your the first section is concerned, meaning the questions based on previous experience is concerned. So this and this will be tied down together, right? Meaning the technical questions and your previous experience based questions could be tied together, meaning both can be volleying each other based on the work that you've done. You would be asked the technical question, and as well as the question based on why did you solve it only in this particular fashion. um, could have you tried other classification algorithms? What is the difference? So suddenly you could be asked, what is the difference between random forest and, let's say, gradient boosting machines? Things like that. Questions like this could be asked. Okay, that's as far as your technical questions is concerned. The last part is important, right? The case study based questions. Right? What does a case study based question look like? So let's take a small example. A case study based question is quite an interesting way of asking questions. So here's how a case study based questions could look like. So in a case study based question, what you are generally given is, you're given a real world problem or a near real world problem. That means an actual problem that they're probably trying to solve, and they would ask you to solve it for you during the interview process. That means they would ask you to give them a possible solution to solve this particular problem. um, let me give you one of the case studies that was given to me in one of my previous interviews. Okay. um, so the question was such that, let's say there is a let's say you're working for Facebook. Let's assume that you're working for Facebook, and inside Facebook you are the team lead of a data science team, right? There is a data science team of 20 people, right? And you're the lead of this particular data science team, lead or manager, let's assume. There is a vacancy for 2 people within your team. Okay? There is a vacancy for 2 people within your team. You need to hire 2 people. So, but because your team is a because you are a data science team, and because you're Facebook, for obvious reasons, what is going to happen? There will be a lot of demand for this particular role. That means you have received almost, let's say, 10,000 applications for this particular role. You have received 10,000 applications for this particular role. Interviewing all the 10,000 applications is next to impossible. There is no way somebody can do this. Okay. What you are expected to do, what you are thinking of, is you want to fill these 2 roles in such a way that the people that you would want to hire are similar to the people who are already there within your team, right? The 2 new people that you'd want to hire should be similar to the 20 people who are there within your team already. Okay. When I say similar, they have to be similar in all possible ways. That means they have to be similar culturally. They have to be similar skill set wise. They have to be similar experience wise, age wise, and a lot of factors wise. They have to be very, very similar, or they have to kind of fit well within the team, right? So if you suddenly the team is, let's say, 20-year-old, the average age of the team, let's say, is 28 years, but you suddenly hired someone who's 60 years old within the team, is that a good fit? Probably not a good fit. So the question is, you would want to identify out of these 10,000 people who are the potential candidates that you should be interviewing. That means you cannot interview all the 10,000 people. You can only interview a subset of 10,000. That means you can interview 10, 15 people, or maybe 20 people at the max, but you cannot hire all, you cannot interview all the 10,000 people. So you are trying to identify out of these 10,000 applications that have come through, which of these 10,000 applications are similar to the 20 people that are there within your team. Okay, simple question. Let's assume that you have some data over here. You have data about your existing team members, right? You have all kinds of information about your existing team members. That means you have information about their skill set, you have information about their age, you have information about their location, right? You have information about their previous experience, and so on and so forth. You have all possible information about their skill set, tools that they know, languages that they know, and so on and so forth. So you've captured all that information in a big table for your 20 people. Similarly, the same information, let's say, is also available for each of the 10,000 candidates here. The same exact information is also available here. Somehow you managed to correct the same information here as well. Right? Now, given this situation, devise an algorithm, devise a data science solution that could narrow down this 10,000 people to, let's say, maybe 10 people, or let's say 20 people. Narrow down this 10,000 people to 20 people that I would physically interview. Okay, that's the problem. How will you solve this problem? Right? I'll repeat the question. The question is that, let's say you're a data science team manager in Facebook. There are 20 people within your team. There is a vacancy for 2 people. You have information about all possible information about your team members, current team members, right? Skill set, age, location, and their previous company experience, and so on and so forth. So you have all of that information with you. Large table. Let's say 30 such characteristics have been identified. The size of the columns is, now we have 30 columns, or 30 such characteristics have been identified. Similarly, we have also 30 characteristics are identified, 30 or 40 characteristics are identified. Out of the 10,000 people, because you cannot interview all the 10,000, you are expected to identify 20 people who are similar to the existing 20 people over here. 20 people or 10 people, how many ever. Let's take this as 10 for simplicity's sake. You have to identify 10 people out of the 10,000 people who could potentially be interviewed for. Okay, so that's the problem statement. Think about it. I'm going to give you a few minutes. Think about it. And after that, I'll talk about what is the possible solution for this. So think about it. I'll hold on for a few minutes here. Think of how you could solve this particular problem. Can I please repeat the problem once more? Okay, third time is the let's do it the third time again. I'll repeat the problem again for all of you um, who are a little confused about the problem statement. You are a data science uh, team manager in Facebook, right? There are currently, you have 20 people in your team. You have all the information about the current 20 people. You'd want to hire 2 more people, but out of the 2 people, I mean, you cannot interview all the 10,000 applications that have come in for you. So you would want to identify potential records which are similar to that of your existing records, right? Potential profiles that are similar to that of your existing profiles. How do you identify that? That's the question. Okay, UBCF. By using k-means clustering, we can solve by doing segmentation, build a model. Okay. Clean 10,000 candidates that do not meet qualifying criterion. How do you do it, Ajay? How do you know who do not meet a qualifying criterion? There is no qualifying criterion here. The qualifying criterion is that they have to be similar to my existing people of 20 here. How would you do it? I don't have one criteria. I have 20 criteria here. Is it 20 criteria? Is it 20 people that I have here? Based on the characteristics, we can eliminate some people such as age, culture, experience, etc. See, I have 30 features, guys. Let's say you don't know what they are. You have 30 such features. You don't know what age is. You don't know what each of this each of it is. Meenakshi, it is not audible. Oh, am I? I hope I'm audible. I will go with logistic regression. Either select it or reject it. Okay. Can you hear me, guys? Okay. Good. Nice. Thank you. Clustering is an option if you don't know details of each criteria. Okay. Perform 16 personality test or questionnaire. Okay. That's an interesting way as well. Okay. You do a questionnaire based approach. Based on 30 characteristics, gives scoring to candidates. Okay. That is also an interesting way. Okay. Nice. So none of these answers is incorrect. Okay, all these answers are absolutely correct. So let's just remember that this is a data science interview that you're attending. So questionnaires or let's say scoring profiles is okay. I mean, is not bad, but we're looking at slightly more intelligent ways of solving this particular problem. Right? You could use scoring. There's nothing wrong with it. Um, you could basically give some scores to each of these, some heuristic model to score each candidate. You can do that. But then we're looking at slightly more smarter ways of solving this problem. Okay. So from the previous solutions here, you could use recommender systems, some user-based collaborative filtering approaches, some kind of recommender systems to solve this problem. You could also solve this via clustering. You could also solve this as a classification problem. There are numerous ways of solving this particular problem. Okay, let's explore two such approaches. I'm not going to talk about all the approaches. I'll talk about two approaches, and then we will see if these two approaches work out or not. Firstly, is this a classification problem is this a supervised problem or an unsupervised learning problem? Is this a supervised learning problem, or an unsupervised learning problem? Anyone? Unsupervised. Okay. Supervised. Okay. Two answers, two different answers. Okay. Many of them say supervised. Supervised. Okay. Unsupervised. Supervised. Okay. So looks like we're all battling it out in the chat window then. Okay. So half of you all say it is supervised, the other half says it's unsupervised. Oh, now majority of them say unsupervised. Okay, cool. So let's first try and answer that question. So this is exactly where all of us will trip. Right? Most of us will trip and fall right at this question. The question is it an unsupervised learning problem or a supervised learning problem? Remember, this is how your interviews are going to look like. So this can be both a supervised as well as an unsupervised learning problem. If I make the assumption, right, I'll make one assumption here. The assumption is that I have some historical data about, right? So I have some historical data about my current team, right? My current team, there are 20 people. Okay. So if I have information about historically, if I have information about which candidates were interviewed. So this is the information of all the candidates that were interviewed. Sorry. Let's say this is the information about all the candidates that were interviewed. Let's say to hire these 20 people. To hire the 20 people, let's say I have interviewed 5,000 people. I don't know, I'm just saying. 5,000 applications is what I get. Right? And if I assume that I have that all the 5,000 applications, and then I have a final column which says yes or no, or a hire or no hire. Hire or no hire, H or N, and I've captured this information. For 20 people, I'll have H's. For the remaining, I'll have no's, no hires. hire, 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 no hire, no hire, and so on and so forth. Okay. So the point that I'm trying to drive here is, if I have this information, if I have this historical information about the kind of candidates that I have interviewed previously and the ones that I have rejected and I have accepted, or that I've hired and rejected, based on this, I can build a classification problem, some classification model. I can build a logistic regression classifier or whatever, and use that model and generate predictions on this data set. Use the model and generate predictions on this data set. That becomes a supervised learning problem then. Okay. If I assume that this data is available with me, if I make an assumption that that data is available with me, I can build a classification algorithm, and then I can solve it as a supervised learning problem. Assuming that this data is not available with me, let's say this data is not available with me. Let's say this data is not available with me. All that I have is just the information about my current 20 people, and I have 10,000 applications with me. Then I can solve it as an unsupervised learning problem. And then I can solve an unsupervised learning problem. How do you solve an unsupervised learning problem? The way you would solve an unsupervised learning problem is, you can cluster your data. You can cluster these 10,000 applications. You can generate some smaller number of clusters. Right? You can generate out of the 10,000 people, you can generate, let's say, 20 clusters or 30 clusters out of the 10,000 records that you have. Out of these 20 clusters, you will have the centroid for each of these clusters. Find the distance of the centroid to each of the 20, to the centroid of the 20 people that you have on the left hand side. Right? You compute the centroid of these 20 people. This is also a cluster if you think of it. These 20 people is also a cluster. Right? Compute the centroid here. Compute the centroids for each of the clusters that you've done on the right hand side. Compute the distance from each cluster to each of these clusters over here. Whichever are the closest, take that particular cluster and then interview those people. Whichever are the farthest, kick them out and tell that they are not close to my current group, hence they will be disqualified. Right? Does that make sense? So two approaches, one supervised and the other is unsupervised learning approach. The supervised learning approach is where I assume that I have a data set like this. I can nicely perform a classification model. If I do not have this historical data about who was hired and who was rejected in my current team, then I will have to solve it as an unsupervised learning problem. So I can cluster my data and my applications into different smaller number of clusters, and the basis of that, I can identify which clusters are closer to my current cluster and far away from my current cluster, and basis that I can identify which cluster is the cluster that I'll have to use to perform interviews. Okay. Now these are not the only two solutions. There could be other solutions as well to the same problem. Like somebody has mentioned over here, you could use recommender systems to solve this problem, and so on and so forth as well. The approaches do not matter here. I think the point that I'm trying to drive here is, this is how your scenario based questions really looks like. The problem could be very open ended. The problem would look like a real world problem, and you're expected to make a few assumptions and actually solve the problem by yourself, or give a potential solution to that particular problem. Okay. If the solution and then you might be asked a few questions around this, and things like that, so the conversation will be routed in that particular direction. That is how your scenario based questions will typically look like. Okay. So that is the type of questions that you can expect. You can expect technical questions, you can expect scenario based questions, you can expect questions based on the current work or the previous work that you have done in the field of data science. So Vaibhav, to your question, previously you've asked, how do I crack the interview with just the training? I'm afraid you should not be doing that. I mean, it's unfair on us as well to just go to a it's unfair on us to just go um, an interview without actually preparing ourselves. Correct. So we have to do our bit due diligence by doing some kind of project, some kind of work before we and put it up on the profile so that it will give them enough questions to answer. Okay, so with that, I'm going to stay there. I'm going to hold there for a few minutes before I move on to the next section, and I'm going to take a few questions. Okay. Question. Sheetal has a question. The project which we have done during the training, can we include those? Absolutely, yes. Yeah. Any project is a project. You can mention it as a capstone project. You can mention it as a project in the course, or a major project, or a minor project, and then yes, absolutely, yes. You can have that as a part of your. Um, you can definitely have that as a part of your profile. Yeah, Sheetal, absolutely, yes. Yeah. Do I have any other questions? Okay. Good. I assume all of us have understood this well. So let's move on to the next section then. The next section is the kind of question that you should ask the interviewer. What question should you ask the interviewer? Um, will we get any assistance from Intellipaat on preparing resume as well? I am not particularly sure on that, Vaibhav. I think that you'll have to reach out to the admin folks for that. Yeah, I might not be able to answer that question. Okay. Um, okay. So the questions for the interviewer. What kind of questions should you ask the interviewer? In general, there are a good number of questions that you'll have to ask. Or if I were interviewing, I would ask these questions, right? I would ask the team that I'm interviewing at least these questions. The questions like, is this team a new team or an existing team? That means, is this team an experienced team or is it a new team? The reason I ask that is because if it is a new team, um, at times what may happen is that when you are a new team, that means your data science team is still being set up. That means the work on data science is yet to come, or the data science work is still not properly identified. Hence, the work that you might receive may not be of the highest quality at times. But on the other hand, if it is a well-established team, if there are already few people in the team who are already solving data science problems, then that could then that is a good thing for you. It's quite likely that you have you already have a team that is working, and then that's basically a good thing, because you know that the quality of work that they're doing, or let's say you're at least guaranteed of doing some data science work. That's the first thing. The second reason why it is important to know that is because and the reason why you would want to know that is because many a times in a lot of these organizations, a lot of the large organizations, um, to hire a data science manager, data science teams are generally set up by managers. Somebody gets hired from internally or from outside. Majorly internally, people from internal other teams, they move in to become data science managers. um, if the data science manager is not very is not very conversant with data science, or if he's not very um, comfortable with data science, if he's not knowledgeable on data science, then that could make your life completely horrible. The reason I say that is because if your data science manager, if the manager that you have is if you are having to spend extra time in just explaining what data science is to your manager or your data science manager itself, then the whole purpose is lost. So you'd want to make sure that your manager knows data science. I'm not saying that you should interview your manager. All that I'm saying is make sure that you're getting into a team um, that knows data science. So many a time they call it a data science team, but they would be doing is probably data entry and some kind of dashboarding and things like that. So you'd want to be doubly sure about that. So yeah, that's the first thing. The second is availability of data. Now, a lot of companies might come and tell you that they're solving a very very cool problem, and the problem that they're solving is on NLP and this and that, and they could probably be boasting about the quality of the work that they're doing and things like that. But in most cases, what you need to really ask for and check for is, do they actually have the data to solve the problem? Now, you cannot directly ask them, do you have the data or not? But you have to, in your conversations, you would want to probe in that direction to know if data is available to solve certain problems or not. The reason why that is important is data is like oxygen for us, right? Without data, you and I will not be able to solve any data science work, will not be able to do any kind of data science work. So knowing if data is available or not is really, really important, because if the data is not available, then I'm afraid all the work that you and I would be do, we'll not even have any work to do. Uh, so, so that's the other thing that you have to know. The third is check if you're going to get some discussions with the client or not. Especially in consulting divisions, you don't want to sit at the back burner. At least work with teams that have direct conversations with the clients. Especially in consulting divisions, if you are some back office somewhere who doesn't know, um, uh, if you are some kind of a back office somewhere, you don't even know if uh, if you don't even know who the client is, then more often than not what happens is somebody talks to the customer, and somebody comes and that guy comes and tells you how to solve the problem. And there's a lot of loss of transmission over there. Transmission losses are often there when somebody talks to the customer and then he comes and relays it to you. And for all you know, if the person who's talking to the customer doesn't understand data science, then we are and then we are in absolute soup in that case. So make sure that your team or the company that you're working for, or you if you at least get you or the team that you're working for has direct conversations with the client. And that's really, really important. um, the reason again I mentioned that is because um, if you're new in the organization, or if you're a fresher, or if you're joining very recently as a junior data scientist and things like that, then you might not get the opportunity to talk to a client directly. But that's okay. If you're at least team members are getting to talk to the client, then at least you know for a fact that uh, then you know for a fact that you will be able to uh, use that information and build models and build data science solutions well. So that's critical. Make sure that your work aligns with your skills. uh, Again, as I said, data science is a very, very vast field. There are so many different ways you can solve data science problems. There are different kinds of data science problems. People work on satellite imagery, people work on Facebook comments, people work on sensor data. There's a lot of data and a lot of lot of work that people generally do. Certain people work on chat logs, certain people work on application logs, database logs, and things like that, right? So you have to make sure that the work that you're interviewing for aligns with the skills that you have. So your skills may be in regular machine learning, and let's say you're hired for computer vision, you might not like it. I mean, there could be a mismatch. The field is very vast. Remember that. Be aware of similar roles, like what I mentioned. There are different kinds of roles. There is data analyst, a business analyst, data engineer, data platform engineer, big data engineer, big data architect, and so on and so forth. There are a lot of roles which sound like data science, but they don't do data science, right? What they essentially do here with these roles is that these people are like, take the example of data analyst or business analyst. The word data analyst is a very loosely used term. A lot of people who claim that they do data analysis are people who probably either do some kind of data entry work, or who does some kind of data merging and things like that, right? So you'll have to be careful about things like that. You'll have to be careful about those terms. Business analyst, again, the terminology business analyst is a very loosely used term. You'll have business analysts right from call centers all the way until large strategy consulting companies as well. The term business analyst is a very loosely used term. It is used for a lot of different places for a lot of different reasons. The general people, there are certain people with MBAs who get hired as business analysts, sales guys who get hired as business analysts, and so on and so forth. So you have to be very careful. These days, data science work is not tagged as data analyst or business analyst or any of those. A data scientist is called as a data scientist. Most organizations have understood that, and they call it data science. They don't call it business analyst or data analyst or any of these terms anymore. So if you want to do data science work, then look for data science roles. Uh, what kind of roles do you ideally want to look for? The ones I've mentioned down beneath: data scientist, AI specialist, or data science specialist, ML specialist, and things like that. ML is machine learning. So Chetan has asked this question: what is the difference between data science and machine learning? Um, so both are the same. Machine learning is a subset of data science. Data science uses a lot of different techniques. Machine learning is a subset of data science where you're using machine learning driven algorithms instead of statistical algorithms. So data science uses both. So these are common terminologies that are often used interchangeably: data scientist, AI specialist, senior data scientist, data science specialist, ML specialist, data science consultant, right? Those are the terminologies which are often interchangeably used. So be aware about that. Make sure that you are interviewing for the right role, and don't get swayed by these fancy terminologies and fancy jargons. Okay. So yeah, those are the four important elements that I wanted to mention about your interview. Okay. So starting from so quickly to round up, starting from types of data science roles, the different kinds of data science roles: data science consulting service, consulting or services, in-house data science teams, product teams, and research teams. Research teams are more or less out of our reach at this particular point, um, because of the kind of depth that is required. What we are looking for is the first three, more or less. And each of them, they slightly vary in the kind of skills that are required to become a data scientist in that particular team. um, Again, three major types of interviews. You'll have a hands-on round, you'll have technical rounds, and then you could have a discussion with, let's say, a delivery head, a vertical lead, partner, principal, a senior manager, or a director, and things like that. So the hands-on session is expected to test your coding skills. The technical rounds are expected to test your technical skills in terms of data science, while your last round is expected to test your fitment in terms of your approach towards data science, and are you actually fit to talk to customers, or are you actually fit to build a product all by yourself, and things like that. In general, expect uh, at least around 4 to 5 rounds of interviews in our data science, and a data science interview, at least 4 to 5 rounds. Types of questions: the different kinds of questions on work that you've done previously, pure play technical questions, and last but not the least is case study based questions. And we spoke about those in far more detail, the kind of things that you have to talk about here. Last but not the least, the questions that you need to check with the interviewer on these things. Don't get carried away by these terminologies over here. There are different names that are there, but these days most data science work is called as a data scientist. So yeah, that's essentially it. So I'm going to stop here. I'll take a few questions. That's all that I had to cover as far as the interview guidelines are concerned. If you have any questions, I'm more than happy to answer. I see that a few people are already asking questions. If you have a few questions, you can answer. I'm happy to answer. If there's nothing else, then yeah, you could drop off, guys. Thank you so much, and all the best. So I'm going to move towards questions now. Yes. So how to probe indirectly or directly whether data is available or not? Yeah, I mean, talk to the customer, talk to your interviewer, and ask them what kind of data they're using to solve the problem. Just get more information about it. It's only about having that candid discussion with the person. Discuss, ask the person, and then you'll be able to understand, and just ask them questions: is this particular data available or not, and things like that. So you have to, I mean, of course, these are communication skills, Vaibhav. So the more you ask, the better you get at it. Can we still have a different job profile with respect to data science field? Meaning, can we still have a role of a business analyst in data science field? I answered that question already. These days you don't. um, these days you don't actually. Most of the data science roles are called as data scientists these days. Earlier it used to be that where people were called business analysts, data analysts, and things like that. Not anymore. A data scientist is called as a data scientist these days. Data scientist, data and applied scientist, AI scientist, AI specialist, and so on and so forth. Okay. What is the average payout for a data scientist and scope? What do you mean by scope? The scope is very good. data science as a field is growing very high. I'm afraid I might not be able to answer your the payout question because it depends from company to company and your previous profile, Gangadhar. So, but in general, if you're moving from another role, you could expect a good hike, right? The field is on the move, on the rise, so definitely there's a good scope there. For product development, we required to know some programming on top of data science, so this category is out of scope for freshers. You should be good at coding skills, Varun. I'm not saying it is out of scope for data science for newbies. I'm not saying that, but yeah, you are expected to have some additional coding skills as well, right? If you're a fresher and if you want to move into a product team, you can do it, but you'll have to spend some additional time in just picking up one more programming language and things like that. Or at least Python. You need to learn Python at least, right? R alone is not good enough for sure. You should have Python skills at least, and if possible, other skills also. It could be useful. Okay. What kind of roles are available for people in program management and data science space? Good question. So program management, um, there are a lot of program manager data science roles as well. Uh, Especially on the product development side, you will have not only product development, even on the program management, on consulting side, services side, also you have program management data science. Um, Primarily their responsibility is, I mean, program managers are also slightly hands-on data scientists, at least within my organization that's the case. um, they do understand data science. They should be able to converse well with the individual contributor data scientists and make sure that the product development is happening properly. They should have knowledge about data science themselves. So there are definite roles in program management as well, Ramnath. So, and it's especially on the product side that we are seeing more and more such roles, meaning making sure that the product development is in proper is going on in proper direction and things like that. Yeah. With a background as a business analyst, which career path do you think I should pursue with a background as a I mean, see, the background as a business analyst, you're talking about, I mean, again, the term business analyst, I'm not particularly sure what you do as a business analyst. Assuming that you are someone who looks at charts and tries to make sense of how the sales were, or let's say how the product, how the business is doing, and so on. I think moving into the field of data science, the first few could be very useful, meaning moving into the services. See, out of these, right, out of the roles that are available here, moving into any of the first two is relatively easy. I think if you were to move, I think the second one is quite useful because you are somebody who's a data scientist who's already looking at data, who's already trying to understand information about data and things like that. So moving into an in-house data science team is a quite useful thing that you could possibly do. So Stephen, hope that answers your question. Um, in general, right, one of the suggestions that I would like to give to most of you is that if you want to continue in the field of, if you want to make a move into the field of data science, the best way to do it is try to make a move within your organization, for especially for experienced people. Try to make a move within your own current organization. Uh, because that way what it does is it kind of helps um, what it essentially does is it kind of makes it easy for you to transition into the field of data science. So that's my suggestion. So yeah, that's a general thing. How much experience shall I tell as I am doing DS architect course from Intellipaat? I have 5 years of experience in data warehousing. See, Satish, um, you're coming from a data warehousing background, which means moving into the field of data science is a logical transition for you. You already understand how to look at data, how to build cubes, how to do reporting, or let's say how to build data pipelines and things like that. So understanding you already have a knowledge around data science. You're moving into the field of data science. You already have knowledge about data warehousing, and you're moving into the field of data science. It's a logical transition, first things first. Secondly, given that you're already dealing with data, you should definitely be able to put one or two projects within your current organization that one or two data science projects that you could possibly solve in your current organization. So don't think of the years of experience and things like that. Think of the number of projects wise. How many projects, one or two different projects. Identify at least two projects that you could possibly do within your current organization, and if possible, actually solve them and then put them up on your profile, right, Satish? So that's how I would look at it, rather than um, strictly talking about how many years of experience should you put up and like that. I'm not a big proponent of that. Okay, if you really want to if you want to really make a case for yourself as a data scientist, do projects. Number of years of experience doesn't matter, because that's very easy to uh, that myth is very easy to break. So at least make sure that you have so what you're trying to show is you were doing data warehousing, you have solved a few data science problems, then you've done a course in data science, and then you're moving into the field of data science. That's the story that you would like to ideally claim. Okay, so yes. Okay, I'm from PharmD, PhD background, have 10 plus years of teaching experience. I want to work in the field of data science. Your comments, please. Absolutely, yes, Raja. I think it's a good time to move into the field of pharma, field of data science with the pharma background. A lot of pharmaceutical companies are actually have data science teams in house. Um, and the reason I say that is because a lot of pharmaceutical companies work on drug. They do a lot of especially in the drug discovery process, a lot of tests are conducted, a lot of statistical analysis is performed. So there's a huge scope, and given that you're already a PhD student, you should understand the importance of statistics and in doing any kind of research work. So definitely, I personally believe that there's a lot of scope for data scientists. Not just me. Pharma industry is definitely a big sector, a big chunk for data science work. You have to go and work for a pharmaceutical company, be an internal guy, and then solve data science problems from the inside. Even inside the pharma company, there are different kinds of problems you could solve. You could solve problems during the drug discovery. It depends on the team that you're associated with again. So you could be solving drug discovery based problems. You could be solving problems, data science problems based on sales. That means which product is most frequently getting sold and which is not. Or you could be solving natural language processing based problems where you are trying to extract and mine content from large journals, and then building tools that would help research scientists understand data much easier. So you could be doing any of those. So honestly speaking, huge scope for data scientists in the pharmaceutical domain. Um, look out for data science roles for with all these pharma companies, Indian pharma companies, as well as external pharma companies, international pharma companies. So Novartis, for example, right, has data science roles. In fact, Novartis has been having data science roles forever now. They've had a large number of data scientists that they've been hiring. Um, so Bayer has the same is the case with GSK, so on and so forth. So yeah, so it's a very good case for yourself. I think you have a good experience already. I think you should definitely make this move into the industry. I will try and share the PowerPoint presentation. Definitely, no, not a problem. Role of AI knowledge in data scientist job. Data scientist is also supposed to work with AI. AI is more or less an advanced concept for a data scientist. So if you know artificial intelligence, if you're working on data science problems if you have knowledge about advanced data science concepts like deep learning and artificial intelligence, then that is definitely a plus. That is definitely a plus, Jasmine. Um, so it basically opens up another category of problems for you. So knowing AI techniques is quite useful, definitely useful. And AI techniques is basically a logical transition from machine learning into slightly more complex algorithms. So yeah, AI knowledge is critical, especially if you want to crack these big companies. If you want to get into the big companies, AI knowledge comes in very handy. But there are smaller companies where you don't really require AI. Majority of the work they see. I'm telling you, the irony is, as we speak today, There are a lot of companies outside who want you to have everything under the roof, who want you to have a skill as you should be able to deal with data, you should be able to build PowerPoint presentations, you should be able to build data science models, you should know R, you should know Python, you should know deep learning, you should know SQL, you should know Spark, you should know everything. So unfortunately, that's the state we are in. So it's about time people are slightly trying to demarcate these roles slowly. People are trying to understand that you cannot have one guy knowing everything. So over a period of time, what you will see is you will see more and more specializations, more and more buckets of problems, buckets of roles that will slowly come through. So yeah, I mean, currently, is it required? I mean, if you want to crack big companies, then yes, it is useful to have. If you, it is something that is that'll help you solve more complex problems. Okay. Uh, as you're having real-time experience in data, what are the different roles? Okay, yeah. Can we land a job in the product development team through data science master architect course? As this includes Python as well. Yeah, I mean, learning Python is important. Yeah, definitely. If you want to nail the, if you want to get into the product development teams for sure, just R is not going to be enough. Learning Python is critical. So yes, that would give you a good, that would stand you in good stead, Varun. Yeah. So you'll have to learn Python. You'll have to learn SQL is important, right? So the two in together could come in handy for you. Yeah. I'm from MEC background, and I'm assuming MEC stands for mechanical. Uh, I don't know if, and 8 years of sales experience. For which domain am I suitable? So Gangadhar, again, the manufacturing vertical. Okay, good. So with the manufacturing vertical, manufacturing experience, again, see, it depends again. So it depends on, do you want to work within, so in general, right, manufacturing companies, do they have data science teams within them? Probably not. I mean, within the manufacturing teams, do we have data science teams? Not all manufacturing companies have a data science team within them. They're also slowly ramping up. They're also turning digital. They're also ramping up quite quickly. So, for example, the diamond manufacturing firm, the diamond mining firm that I have, there is a data science opening there. There is an automobile manufacturing company. They have data science teams, that monitor inventory, that monitor that solve problems on the inventory side, and so on and so forth. So yes, there is definitely a lot of scope on the um, there's definitely a lot of scope on the manufacturing side as well. But I think I don't want you to tie yourself down to a particular domain. Keep your options open. In general, this is a suggestion to everyone. Don't try to tie yourself down to your particular domain. Your domain expertise is always good, is always will come in handy. But that doesn't mean you only look for job roles in that particular domain. Stay a little open. Keep your options open. You never know, you might actually land a job in other domains as well. So keep your options open. That is what I would suggest. Okay, we having, as you're having real-time data experience, what are the different roles we have in ideal team working in the data science project? So yeah, good question. So in general, in a data science team, so in a project, right, you would have um, a combination of different people. It depends again on the project, of course, but I can tell you in general the kind of roles that are available, right? So the roles that are generally available are that are generally a part of a data science project are such, right? First, you will have one or two data scientists, depending upon the size of the problem. You will be having a data engineering team or a data platform team. Um, Data platform team. What these guys do is their responsibility is to gather data, And this doesn't necessarily have to be only one person. This could be four or five, three to four people, again depending on the size of the project. On an average, we're talking about a mid-sized project will have around 3 to 4 different data platform folks. Their responsibility is to load data, is to build sheets, build tables, data migration activities, and things like that. That's what they are supposed to do. You may also have an application developer who is responsible for, let's say there's some UI that is required. The application developer is supposed to build the UI for you. The fourth is you may have so the fourth is you may have somebody who's for UI UX kind of a guy. The fifth is somebody from somebody who's responsible for infrastructure, infrastructure provisioning and things like that. So making sure that the CI/CD pipelines, DevOps, and everything is properly set up. So you'll have someone from the infra side, and then of course to oversee all the work that is doing, you will have some project manager, some PJM who will take care of the project management and everything. That's the general structure. At times, what you may also have is you may have one role in between a data scientist and a data platform called as a ML engineer, right? And the role of this particular ML engineer is that this person is responsible for taking the models that the data scientists build and deploying them and moving them into production and deployments and things like that. So an ML engineer may not be extremely tech savvy, the data science, meaning extremely data science savvy. He might know data science, but what he also knows is, let's say, how to interact with various data sources. He knows how to. He should definitely know Python. He knows how to scale up models. He or she is good at building large scale data science solutions and so on. So that's the kind of team structure that you would generally look at, right? Um, so I hope that answers your question. I'm working as in a different domain, not related to data science. Can I show experience based on learning experience, or also included my previous work, which I think is not essential for data science profile? See, I mean, if there is if your previous role has nothing to do with data science, if your previous role is hard for you to show the transition into data science, that's okay. Make sure your projects talk about it, right? Put up projects. It'll take time. That's okay. Do it the right way. Put up projects. The projects will definitely help. Trust me. Without some projects and without actual hands-on work, even if you just go and tell them that I worked in the data science for 1 year and but you have to make claim that you've done some project. So it doesn't matter how many years you claim. If you haven't done any project, then that is almost useless. Um, Learning experience is okay if the learning experience is tagged with some projects that you've done by yourself. That is very that becomes very indispensable. That becomes very useful then. Okay, Ravi Shankar, hope that answers your question. So suggestion is, you can put 1 year, half year, 6 months, 8 months. That's okay, but all of that has to be tagged with some kind of projects that you do. Okay. For most of the data science positions required for BTech computer science, MCA, PhD, how would it work out for others? See, I'm just a BTech mechanical engineer. I don't even have computer science. And majority of my friends are bachelors, and they're all people who are into the field of data science at a very early age, who are into triple E civil engineering and so on and so forth. So that's all nonsense. Don't worry about that, Vamshi. So I mean, it's if they're looking for a PhD, then that is probably for a slightly more senior role, or if it could probably be for a slightly more, it could probably be for a slightly more complex role. But trust me, apply for it. It's okay. There's nothing to lose, because I can very happily and comfortably say that 60% of the data scientists, 60 to 65% of the data scientists that I work with today within India and outside India do not have a master's degree. So trust me on that. So it's not mandatory for you to have a master's or a PhD to be a data scientist. Um, okay. Okay. Oh wow, there are a few more questions. I'm from arts background, political science, now ML and AI and Intellipaat. How do I relate it with the old? Good question. Okay, so that'll be interesting. I think what you can do is, I know political science, tying down political sciences to machine learning and artificial intelligence could be slightly difficult. Um, but I think you might have to do some kind of work that bridges the two. Like for example, doing some kind of analysis around an analysis around how states have evolved over a period of time. Publishing one or two articles on LinkedIn, doing some basic analysis. Go to data.gov. You'll have a lot of data around how India has been doing over a few years. In terms of GDP, as well as you have a lot of other information that is available on data.gov as well. Take that data and then try to do some kind of analysis on top of it. Um, I'm not particularly sure what you would do. I'm sorry, I might not be able to give you a straight out point blank answer of saying do go ahead and do this. But I think what you definitely will be able to do is I mean, you should be able to kind of put some analysis together that can tie down AI and political and sciences. Uh, right. Okay. So yeah, especially again, if you want to look at it from uh, yeah, I'm actually thinking about it. Uh, what else you can do with political sciences? As I see, there are some interesting articles that are published in this particular industry as well, where they're tying down artificial intelligence with political sciences, especially around uh, you know power, especially around who is in power and who is not in power. I see there are a few papers that are published. I think you could uh, just do some research around how you can tie down these two fields together. But net put some work together with these two, taking these two into account. So read one or two papers that are published with these two, and I think that'll come in very handy. Um, so I'm sorry, I'm unable to probably give you a concrete answer on that, but yeah. I'm an MSc statistics. I have teaching experience, but the gap is there. Is it okay? It's absolutely fine, Meenakshi. It's totally fine. Don't worry about the gap. I think you should definitely be able to cover it up with. Uh, I think you should definitely be able to cover it up with any of your personal challenges. So I think that's okay. Don't worry too much about the gap. Um, yeah, but MSc statistics, that is definitely a nice thing to have, right? If you are an MSc statistics, people, I mean, it makes a very good case for you to move into the field of data science. So that's like a nice thumbs up for you to move into the field of data science. Okay. Uh, Maintenance background. I'm maintenance background, and I have 8 years of experience. Will this help you for profile change? See, maintenance engineering, and I have a couple of friends who are in the field of maintenance engineering. Can you tie down maintenance engineering with AI? Absolutely yes. So we're doing predictive maintenance, and I mean, you must have heard of something called as preemptive maintenance. If you know of preemptive maintenance, then there is also a concept called as predictive maintenance. The concept of predictive maintenance is essentially trying to predict the failure of a given component even before it actually fails. Um, these these kind of tools are already a part of predictive maintenance. Is already a part of tools like let's say your SAP. Um, and your SAP systems, if you're using any of the SAP systems within your organization, then there's already these tools that are available. So you could basically try and do some kind of similar analysis and try and put that together as one of your projects within your profile. That way, it'll show a logical transition. Maintenance engineer, you're doing predictive maintenance within your organization. You did a course in the field of data science, and then you're trying to move in. So try to bridge your experience with your data science with some work that can nicely tie down your experience and your data science skills. So find that work. There's a lot of predictive maintenance. Because you're in the maintenance industry, I'm sure you have access to data. So try to get access to that data, try to take that data and try to do some analysis on top of it. If possible, right? One of the things that you guys do in general, and that's a suggestion, is you guys should be able to and go to the extent of publishing some, some Medium posts, um, and publish some articles on LinkedIn on whatever field you come from. Like for example, the political sciences thing is something that is very, very interesting. I've never done that before. I've never heard of that before. But if you can actually put that up together, uh, and put an analysis together on that, that'll be amazing, right? Same is the case with predictive maintenance as well. Whatever you're doing, uh, try to have an overlap between the two. Try to have an intersection between your previous experience and data science. Try to create that overlap, and one of the ways of doing it is by identifying a project that can uh, try to create that overlap. Yeah. um, okay, just a second. The last few questions before I wind up. SQL knowledge should be for data science. Who good the data SQL knowledge should be for data science. I'm assuming your question is how good. It's not who good. How good the SQL knowledge should be for data science. Uh, you don't have to be a master of it. You should be able to do a few things. Like for example, you should be able to write. You should be able to write select queries. You should be able to do group bys. You should be able to write do joins, case statements, where clauses, and things like that. Level 200, if I may say. Intermediate. You don't have to be big. Into beginner to intermediate is what you would essentially need to be. You don't have to be an expert on it. Okay, intermediate level should be fine. You can take any of the courses that are there to learn SQL. Yeah. So. When we mention about big data in our resume, can we expect Spark programming questions? Absolutely, yes. Trust me, you will. Or just knowledge about concepts will do. So both ways. So knowledge about concepts in general about big data, nobody will ask you in the data science interview. Can you tell me what is big data and how do you solve big data? For a data scientist in general, the questions around big data will be about how do you solve a data science problem on big data. Right? Let's say there's 100 GB of data. How do you build a predictive model on such large volumes of data? Right? How will you prepare your data and how will you solve this particular data? Right? So the questions are generally going to be not about explain what Hadoop is. Nobody's going to ask you a question about what is Hadoop and why would you use Hadoop and things like that. While knowing concepts is good for you, but I think concepts around how do you tie down data science and predict and big data together is critical. So that is where tools like Spark and others come into picture. So you maybe ask questions around Spark and PySpark and things like that. Yeah. So I'm having a 50 years of a business strategy experience, business model, marketing, and turnaround companies to profits in various domains where data analysis was used for BI. Look forward for what kind of role. Did a lot of consumer research for various industries, product geographies, and companies for defining the services. So, what kind of role should we look for? Absolutely. I mean, it looks like interesting work that you've done, Nandan. I think what you could look for is my my question to you is. Are you planning to move into the field of data science or are you trying to leverage data science for doing better at your work? If you're planning to move into the field of data science, I think instead of moving into the field of data science, you should expand into the field of data science. What that means is make use of the work that you've already done, and I'm sure there are numerous places where you could have used data science. For example, you're saying you've done consumer research on markets, on industries and products and various geographies and so on. That's a classic segmentation. That's a few of them is where you could do segmentation, customer segmentation, product segmentation. You could do analysis around you could do prospective customer analysis and so on and so forth. So all of these are traditional problems. you probably made use of BI and data analysis to solve them in a more traditional fashion. I'm definitely sure you should be able to use data science concepts, like for example your data mining concepts, like your clustering and so on, to perform the same problem in a slightly more data driven fashion. So what you should ideally be looking at is your skills in data science and let's say your business analysis. I'm sure will come together, and you could work in you instead of actually moving towards, I mean, you could definitely hire yourself as a data science consultant, move as a data science consultant in any of the services companies, or you could work for these strategy consulting companies as a strategy consultant, right? um, so yeah, I think these two are, well, consulting essentially is what you should be focused on. I think that's where your strength is, um, and that's where I think you should base it as well. You have similar roles, right? Just like how you're doing that kind of analysis. And I'm sure your company also has data scientists who are doing slightly more advanced analysis. Um, so every company more or less has advanced analytics teams, and yeah, the idea is for you to try and move into any of those teams, move into those advanced analytics teams, make use of your data science skills, and then see if you want to continue in that field, or you want to switch into the field of data science completely, right? Or meaning you'd want to work on slightly more advanced concepts, slightly more advanced AI concepts. Uh, so yeah, use your past to use your past experience to your advantage, and see if you can convert any of your previous work into data science work, right? When I say convert, I mean at least on paper you should be able to convert. If you haven't really had if you don't really have the opportunity to convert it in reality, at least I'm sure you should be able to think it through as a data science solution then, and frame it as a data science problem.
So, have you ever wondered which book to read next? Well, I often have, and to me, book recommendations are a fascinating issue. And that is exactly what we're going to do today. So, our dataset for the case study comprises of these four files: ratings.csv, books.csv, booktags.csv, and tags.csv. So, as the name suggests, ratings.csv contains all users' ratings of the books. So, there are a total of 980,000 ratings for 10,000 books from 53,424 users. So, the books.csv contains more information on the books, such as the author's name, publication year, book ID, and so on. Then we have the booktags.csv file. So, this file comprises of all tag IDs users have assigned to the books and the corresponding tag counts. So the tag IDs basically denote the categories into which the books fall into, and the counts denote the number of books belonging to each category. And we have the tags.csv file. So this file contains all the tag names corresponding to the tag IDs. That is, it gives out the labels corresponding to different tag IDs. So these are the tasks which you'd have to perform in this project. So in the first phase, we do a bit of data cleaning. So we'll start off by removing the duplicate ratings. That is, there are cases where a user has rated the same book more than one time. So we'll go ahead and remove all these instances. After which we'll go ahead and remove those users who have rated fewer than 3 books. Right guys, so we are into our studio now. So let us go ahead and load all of the packages required for our case study. So these are all of the packages required. Alright, now after which I'll load the 4 files from our dataset. So these are the 4 files. So we have books.csv, ratings.csv, booktags.csv, and tags.csv. And I'm storing this in objects books, ratings, book tags, and tags. So we have loaded these 4 files. Now let us have a glance at these 4 files. So I'll be using the view function to have a glance at our 4 files. Right, so these are our datasets, guys. So we have the ratings dataset, which comprise of these 3 columns: book ID, user ID, and the rating. Then we have the books dataset, and these are the columns. So it has ID, book ID, work ID, ISBN, the author's name. Then we have the original publication year, original title, language code, and so on. After which we have the book tags. And here the columns are Goodreads book ID, tag ID, and the count. And then we have the tags dataset. Here we have the tag ID and the corresponding tag name for that tag ID. Right. So as part of our first phase, we had to do a bit of data cleaning. And the first task of our first phase was to remove all of the duplicate ratings. And to do that, we'd have to find out how many times has one single user rated one particular book. And this would be the command for that. So here what I'm doing is I am grouping this ratings data set by user ID and book ID. After which I am using the mutate function and I'll add a new column to this, and that new column would be given by the n function from the deployer. So this basically would give us the number of times a single user has rated one particular book. And I'm giving the name of the new column to be capital N, and I'm storing the result back to ratings. So let me have a glance at ratings now. View of ratings. So we see that a new column has been added. So this is the user number. So the user number 314 has rated the book number 1 only once. Similarly, if we take this case over here, the user number 2900 has rated the book number 1 only once. So let me go down and see if there are some changes over here in the count of n. Right, so let's have a glance at these two cases over here. So the user number 4206 has rated the book number 8945 two times over here, right? So these are the duplicate ratings which I'm talking about. So these records need to be removed, right? Right, so now let me also use the table function to find out the distribution of these duplicate ratings. So I'll use table function and I will give in ratings $n over here, which would give me the count of the different ratings given by one particular user to one particular book, right? So this value over here tells us that there have been 5 instances where one particular user has rated the same book 5 times. This tells us that there are 28 instances where the same user has rated the same book 4 times. This tells us that there have been 156 instances where the same user has rated the same book 3 times. And this tells us that there are 4,298 instances where the same user has rated the same book 2 times. And this is all of those cases which are not duplicate. That is, the user has rated that particular book only 1 time. Right. So now what I'll do is from this ratings data set, I will filter out all of those duplicate records and I will store them in a new object. So I will put in the name of the dataset, which would be ratings over here, and I will use the filter function to select all of those records where n is greater than 1. That is, which have duplicate ratings, and I will store it in a new object. So we have successfully created this new object. Now let me have a glance at this view of duplicate ratings. Right, so there are 4,487 entries in total which have duplicate ratings. Or in other words, there have been 4,487 instances where the same user has rated the same book more than 1 time. Right, now we'll go ahead and remove all of these duplicate ratings. Now this is a very simple command to do that. So from the ratings object, all you have to do is filter out only those records where the value of n equals to 1. So this basically means that we are filtering out those records where one particular user has rated one particular book only once, and I am storing this result back to the ratings dataset. Right, so we have done the changes. Now let me have a glance at it. View of ratings. Right, so these are all of the records where there are no duplicate ratings. So our second task was to remove all of those users who have rated fewer than 3 books. So for this, we'd have to start off by grouping the users with respect to user ID first and find out the number of ratings given by each user. So I will select this command over here and I'll paste it over here. So I have given ratings over here and I'm grouping this ratings with respect to user ID. After which I am using the mutate function. And over here again I am adding a new column, and that new column would be ratings given, and I will get that ratings given column with the help of this n function from the deployer package. So this n function from the deployer package would basically give me the number of ratings given by each user. Right, so I will store this back into the ratings dataset. Now let me have a glance at it. View of ratings. So this is the user ID. So the user number 314 has given 181 ratings in total. The user ID 439 has given 173 ratings in total. Similarly, the user ID 9246 has given 190 ratings in total. So now we'll go ahead and remove all of those user IDs who have given less than 3 ratings. So this is the command for that. I have again given ratings over here, and I am filtering out only those records where the ratings given by each user is greater than 2. That is, each user has at least rated 3 books or more, and I am storing the result back to ratings. So view of ratings. So this is our final data set. So we see that there are 960,595 entries in total. So we are done with the first phase. In the second phase, we'll do some data exploration. So we'll start off by extracting a sample set of 2% records from the entire data set. Then we will make a bar plot for the distribution of ratings. That is, we want to analyze the count of different ratings. After which we'll make a plot to understand how many times each book has been rated. Then we'll make a plot for the percentage distribution of different genres. Going ahead, we'll find the top 10 books with highest ratings. And finally, we'll find out the 10 most popular books. Right, so we are back to our studio again, and it's time for phase 2 now. So the first task in our phase 2 was to select a sample from the entire data set. So I'll go ahead and set a seed so that if I ever want to run these commands again, I can get the same results. So I'll set the seed value to be 1. And I'll set a user fraction of 0.02. That is, from the entire user base, I need only 2% of the sample users. So I am assigning this value of 0.02 to a new vector and naming that new vector to be user fraction. Now after which I will find out all of the unique user IDs. So I am using the unique function over here, and I will give in the user ID column from the ratings dataset. So this will give me all of the unique user IDs, and I am storing the result in the users object. Now after this, let me have a glance at the number of the unique user IDs. So length of users. So we see that there are 45,016 unique user IDs in total. So we need 2% of these unique user IDs. So 2% of this would be 0.02 into 45016. So this would give us 900 users. So from 45,016 users in total, we would need 900 users. Right. So we'll do a random sampling of 900 users from the entire user base. So this is the command for that. So I am using the sample function, and this is the list of all of the users. And from all of the users, I only need 900 of the users. So earlier we had multiplied the user fraction into the length of the users, which gave a value of 900 point something. So we are basically rounding that off, and I will store that result in sample users. So now let me have a glance at the length of sample users over here. Length of sample users. So you see that there are 900 sample users in total. Now let me also have a glance at the number of ratings. So initially the number of ratings which we have is 9,60,595. So now what I'll do is, from this ratings data set, I will be filtering out only those user IDs which are present in the sample users object. That is, I would need only the sample users from all of the users, and I will store the result back to ratings. Right, now let me have a glance at the number of ratings. So n row of ratings. So now we see that the number of ratings has reduced to 18,832. So initially we had more than 9 lakh ratings. So now after filtering the data set, we have just 18,832 ratings. Alright. So our second task was to make a distribution of these ratings. So let me go ahead and do that. So guys, this is the command for that. So again, I am using the ratings data set, and on top of this, I am building the ggplot. So here, I am mapping the rating column onto the x-axis. So this column over here, so we have different ratings, 1, 2, 3, 4 and 5. So I am mapping this column onto the x-axis. So the fill color would also be determined by the rating column. And after that, since we'd have to make a bar plot, I am using the geom_bar function. And the color which I give to the boundary of the bar plot would be gray 20. And the color which would be coming to all of these bars would be from this palette over here. So the palette is YLGNBU. So this stands for yellow, green and blue. So we'll be giving this inside the scale fill brewer function. Right. And I am also setting the guides to be false. Let me hit enter. So this is what you get. Let me zoom this now. So this is quite an interesting plot, isn't it? So let's have a glance at this bar over here. So this basically tells us that there are more than 6,000 cases where a rating of 4-star was given. Now similarly, we see that there are more than 5,000 cases where a rating of 5-star was given. And this bar over here, so this tells us that around 4,700 times a rating of 3-star was given. So the count of these two bars is quite low. So there have been very less cases where a rating of 1-star was given. So maybe not even 500 times a rating of 1-star was given. So this is for the rating of 2 stars. So around 1,000 times rating of 2 stars would have been given. So guys, this is the distribution of the ratings. Now after which we had to find the number of ratings per each book. So let's also do that. So here again, I start off by giving the ratings data set, and I would have to group this with respect to book ID because I'd want to find the number of ratings per each book. So that is why I am grouping it with respect to book ID. Now after grouping it, I will use the summarize function. So basically inside this summarize function, I will basically get the count of number of ratings for each book. So here I am again using the n function. So this n function would give me the number of ratings per each book, and I'm also naming the result to be number of ratings per book. After which I'll again use the pipe operator and add a layer of the ggplot on top of it, and I am assigning the number of ratings per book onto the x-axis. The fill color is orange, the boundary color is gray 20, and the x-axis values would range from 0 to 40. Right guys, so this is the plot. Let me zoom this now. So from this graph, we can basically infer that there is not even one case where a book was rated more than 10 times. So let's have a glance at this bar over here. So this tells us that there are more than 2,500 instances where a single book was rated only by one user. So this is for those instances where a single book was rated by 2 users, or in other words, a single book was rated 2 times. This is for those instances which tells us that a single book was rated by 3 users, or in other words, a single book was rated 3 times. And the count for this is around 1,500 times. Right, so this plot was for the number of ratings per each book. Then we had to get the percentage distribution of the different genres. So what we'll do is we'll start off by making a new object and giving it the name genres. So this genres object would basically have a list of different genres in it. So I have basically listed down a bunch of different genres over here, and I am storing all of these into the genres object. So the different genres are art, biography, science, thriller, travel, humor and comedy, and so on. So after building the genres object, what we'll do is from this tags data set, I will be extracting only those tag names which are present in the genres. Or in other words, I am extracting only those genres which are listed down over here. So this is the command for that. So what I'm basically doing over here is I am finding out if the listed genres are present in the tag names or not. and if they are present, I am extracting only those joiners and I am storing them in available joiners. So let me hit enter and let me actually see what are the available joiners. Right, so these are all of the available joiners in the tags dataset. So there are 27 genres in total, and these are Christian, business, poetry, philosophy, science, and so on. Now similarly, I will extract all of the corresponding tag IDs with respect to the tag names. So let me find out which are the available tags. So over here, I am basically extracting all of those tag IDs if the tag name is present in one of the available genres, right? So if the tag name is present in one of the available genres, only those tag IDs I'm extracting. And similarly, if the tag name is not present in the available genre, then I won't be extracting those tag IDs. And I am storing the result in available tags. So next we have to make a plot for the percentage of each genre. So let's go ahead and do that. So before we do that, let's actually get a count of the different genres available. So this would be the command for that. Let me print it over here. So what I'm basically doing over here is from the book tags dataset, I am extracting only those tag IDs which are present in available tags. And then again, I am grouping it with respect to the tag ID. After which I'll use the summarize function and get the number of counts of each of these tag IDs. Or in other words, I'll get the count of the different genres. So let me hit enter and let me see what do we get. So this is the tag ID 2938. And for this corresponding genre, the count is 436. That is, there are 436 books belonging to this genre. Similarly, this is the tag ID 4605 and the count is 1109. So this means that there are 1109 books present for this particular genre over here. And let's take this over here. So the tag ID is 7778 and the count is 469. So this means that there are 469 books present with respect to this genre. Now let me go ahead and also find the percentage. So let me select all of this code over here. Right. So now we had run the command till here. Now, so we basically got the count of each genre. Now, after getting the count of each genre, I am ungrouping it again. After that, I will use the mutate function and find the total count. That is the total count of all of the genres combined. And I am also creating a new column percentage. So this percentage over here, I am dividing n upon sum of n. That is, this would give me the percentage of each of the genre. And after getting the percentage of each of the genre, I will arrange the dataset in descending order. And after arranging the dataset in descending order, I will also left join the tags dataset to the book tags dataset. And the joining would be done by the tag ID column over here. So let me store this in a new object. So let's say book info. Now let me have a glance at it. View of book info. Right. So guys, this is the tag ID. This is the count of the tag ID. That is the number of times this genre is present. And this column gives us the total count of all of the genres. This gives us the percentage of the genre. And this is the tag name, which is fantasy. So we've got our data set ready. Now we'll go ahead and make a plot on top of this. So now let me go ahead and make a plot. So the object name was actually book info. So let me change this to book info over here. And on top of this book info object, I am adding a ggplot layer. So here I'll be mapping the percentage column onto the y-axis and the tag name column onto the x-axis. And the fill would be determined by the percentage column. And since we'd want to make a bar plot, we'll be using the geom bar function. And the stat which I've used is identity. And I'll also use the quad flip function over here because I'd want these bars to be stacked horizontally and not vertically. And the color to these bars would be determined by this palette over here. So this is YLORD. So this would be for yellow, orange, and red. And the label which I've given for the y-axis is percentage, and the label which I've given for the x-axis is genre. Let me hit enter. Right guys, so this is the plot. So here I have mapped genre onto the y-axis, percentage onto the x-axis. So we see that fantasy is the most prevalent data set, or in other words, most of the books belong to the fantasy genre, and the least percentage is of the cookbooks. So this was the distribution of the percentage of different genres. So next we'll go ahead and find the top 10 books with highest rating. So this would be the command for that. So if you have to find out the top 10 books with highest rating, all we have to do is arrange this average rating column in descending order, and that is what we are doing over here. So here I have given the name of the object, which is books, and I am arranging this data set in inverse order of average rating, after which I am selecting just the top 10 records, and the columns which I'd be selecting are title, ratings count, and average rating. So let me store it in top 10. Let me have a glance at top 10 now. Right guys, so these are the top 10 highest rated books. So the Complete Calvin and Hobbes is the book with the highest rating. So it has the highest average rating of 4.82. And then we have Words of Radiance. So it has a rating of 4.77. Third in place is the Harry Potter box set, which has 4.77 rating. Fourth is ESV Study Bible, which has a rating of 4.76. Fifth in the list is Mark of the Lion Trilogy, which has an average rating of 4.76. Alright guys, so we have successfully found out the top 10 books with highest ratings. Next we'll go ahead and also find the top 10 most popular books. So this would be the command for that. So to find out the top 10 most popular books, we'd have to arrange this ratings count column in descending order. That is, whichever book has the most number of ratings, it would automatically mean that it is the most popular book. Right, so this is the command for that. Let me run it over here. So here what we are doing is, on the books data set, I am arranging it in inverse order of the ratings count column. And then I will be extracting the top 10 records, and I'll be selecting the title column, the ratings count column, and the average count column. So let me store this in top popular. Let me have a glance at top popular. Right, so these are the top 10 most popular books. So the most popular book in the list is The Hunger Games, which has the highest ratings count. Then the second most popular book is Harry Potter. Third most popular book is Twilight. And the fourth most popular book is To Kill a Mockingbird. In the third phase, we'll finally do some recommending. So we'll start off by building the user-based collaborative filtering model. And then we'll recommend 6 new books for 2 different readers. Right guys, so it's finally time to recommend some books. So before we go ahead and do that, we'd actually have to restructure our data a bit. So our data actually needs to be in the form of a matrix where all the rows should correspond to the users and all the columns should correspond to the books. So the dimension names would then nothing be but the user IDs and the book IDs. So the user IDs would represent all of the rows and the book IDs would represent all of the columns. So let me go ahead and extract all of the dimension names first. So here with this command, what I'm doing is I am extracting all of the unique user IDs and I'm also extracting all of the unique book IDs and I'm storing them in this object dimension names. So this is our first task. So we have basically got all of our dimension names. Now we'll go ahead and convert the format of our data frame from long format to wide format. So with this command, what we are doing is we are actually selecting the book ID, the user ID and the rating columns from this data frame over here. And I'll be splitting this book ID column. That is, this value of book ID 1 would become one column. This value of book ID 2 would become the second column. This value of book ID 3 would become the third column and so on. And these rating values over here, they would become the values for the corresponding book IDs. So this is how we can use the spread function to spread out our data frame from long format to wide format. And we'll also remove the user ID column because it doesn't serve a purpose, and I will store it in a new object and name that object to be rating mat. So let me hit enter. Right, so we have created our rating matrix. So we have created the rating mat object. Now let me have a glance at the class of this. So class of rating mat. So we see that this is still in the form of a data frame, but we can build our user-based collaborative filtering model only on top of the real rating matrix. So first we'd have to go ahead and convert this data frame into a matrix. So let me do that. So here with the help of as.matrix function, I am converting the class of rating mat from a data frame to a matrix, and I am storing the result back to rating mat. Right. So now let me have a glance at the class. So class of rating mat, and we see that now it is a matrix. So let me have a glance at the first 5 rows and the first 5 columns of it. So these are the first 5 rows and these are the first 5 columns. So we see that this user ID column has not been removed. So let us go ahead and manually remove these. So what I'm doing is I am manually removing this first column and I am storing it back into rating mat. Now let me have a glance at first 5 rows and first 5 columns. Right. So these are the first 5 rows and these are the first 5 columns. So these rows basically correspond to all of the user IDs and these columns basically correspond to all of the book IDs. So these NA values which you see over here, so this basically means that the first user has not rated the first book, the first user has not rated the second book, similarly the fourth user has not rated the third book, and so on. Right, so we have our rating matrix ready. Now let me also assign the dimension names to the dimension names of this rating mat object. So here I am assigning all of the dimension names which I've extracted to the dim names of the rating mat. Right. So now let me have a glance at the dim names of rating mat. So dim names of rating mat. So these are all of the dimension names for the rows. So this is the name for row number 1, this is the name for row number 2, and this is the name for row number 3. So this basically signifies that all of the rows are represented by the user IDs. Similarly, if I go down, then we have all of the book IDs. So all of the columns are represented by the book IDs over here. Now let me use the dim function to find out the number of rows and columns in the matrix. So we see that there are 900 rows and 8,431 columns. Or in other words, there are 900 users and 8,431 books. So we have got our metrics ready, but we can't just build a user-based collaborative filtering model on top of the metrics. So we have something known as a real rating matrix. And the recommender lab basically works only on this type of object. So I will store this rating mat into a new object and name that object's name to be rating mat 0. Let me again have a glance at the number of dimensions of this. Dim of rating mat 0. So we have the same number of rows and columns. So again here, the number of rows are 900 and the number of columns are 8431. Now after this, what we'll do is, wherever we have NA values, we will replace those NA values with 0. So in rating mat 0, wherever we find NA values, I am replacing those NA values with 0. So now let me again have a glance at the first 5 rows and the first 5 columns of this. So it'd be rating mat 0, 1 to 5 and 1 to 5. So we see that all of the NA values have been replaced with zeros. So now we can go ahead and convert this matrix into a sparse matrix. So I'll be using the as function and I am converting this rating mat 0 object into a sparse matrix, and I will store this in a new object and name that object to be sparse ratings. Now let me again have a glance at the first 5 rows and first 5 columns of this. So sparse ratings 1 to 5 and 1 to 5. So this is how a sparse matrix looks like. So basically, with the help of a sparse matrix, we end up saving a lot of space. Now it's the last part of the transforming. So we will go ahead and convert this sparse matrix into a real rating matrix. So for this, we would need the new function. And with the help of new function, I am converting this sparse ratings object into a real rating matrix. So this over here takes in two parameters. So the first parameter is basically what we are trying to convert this into. And then we give in the data which we are trying to convert. And I'll store this result in real ratings object. Let me print real ratings now and let's see what do we get. Real rating. So this is what we get. So it is a rating matrix where there are 900 rows and 8431 columns, and it is of class real rating matrix with 18,832 ratings. Right. So we finally have our real rating matrix ready. So now we can go ahead and build a model on it. So what we'll do is we'll go ahead and split the data set into train and test sets. So it'll be a 80-20 split. So I'll be using the sample function to create this 80-20 split over here. So I am using the sample function and I will generate true or false values over here. And this sampling would be with replacement and the probability is 80-20. That is, I would want to divide the data set into two parts where the first part would comprise of 80% of all of the observations and the second part would comprise of 20% of the rest of the observations. And I will store the split criteria in a new object and name that object to be split book. So now in real ratings, wherever the value of split book is equal to true, I will select all of those records and store those records in rec train. Similarly, from the real ratings matrix, wherever the value of split book is assigned to be false, I am extracting all of those observations and storing those observations in rec test. So we have our training and testing sets ready. Now we can finally go ahead and build our first model. So we'll be using the recommender function, and this over here takes in two parameters. First is the training set on which we'd want to build the model, and next is the method or the type of the recommender model which we'd want to build. And since we'd want to build a user-based collaborative filtering model, we'll given the type to be UBCF. So if we wanted an item-based collaborating filtering model, then the method would be IBCF. But in our case, since we want user-based collaborative filtering model, so the method would be UBCF, and I will store the result in an object which would be rec model UBCF. Right, so I have successfully built the model. Now I'll give a value for the number of books to be recommended. So I am assigning the value 6 to a vector, and the name of that vector is nRecommended UBCF. So this basically lets us know that we'd have to recommend 6 books in total. Right, so the model building process is done. So let me go ahead and predict the values. So I'd have to use the predict function for this. So over here, this takes in 3 parameters. First is the model which you built. Next is the dataset on which we'd want to predict the values. And third is the number of values to be recommended. Right. So first we'll given the model which you built, which is rec model UBCF. And then we'd want to predict on top of the test set. So the test set is rec test. And the number of books to be recommended is 6, which is stored in nRecommended UBCF. And I will store this result in rec predicted UBCF. Right, so the prediction is also done. Now let me go ahead and find out the item numbers which have been predicted. So now that we have predicted the values, let's go ahead and recommend some books to user number 1. So here we will use this object rec predicted UBCF. So this is the object which we've just built using the predict function. And I'd want to find out the item numbers which have been recommended to user number 1. So this command over here, rec predicted UBCF @items1. So this will give me the column numbers which have been recommended to user number 1. So let me have a glance at user 1 book numbers. So this basically means that user 1 has been recommended to read these books which are present at columns 2177, column number 6343, column number 423, column number 1908, column number 2274, and column number 2514. Now we just have the column numbers. So let's actually find out the labels for these column numbers. Right, so from rec predicted UBCF, we have the item labels, and inside the item labels, I will give in the book numbers which have been recommended. Right, so these are the item labels. So the book ID, which is under column number 2177 is 2636. The book ID, which is under column number 6343 is 7482. Similarly, the book ID, which is under column number 2274 is 2750. So we have successfully got the book IDs. So now that we have the book IDs ready, let's actually use these book IDs to extract the name of the book and the name of the author. Right, so what I'll do is I will extract the title of the book and the author's name, where the book ID is 549. So the name of the book is Cordry and the author's name is Don Freeman. Similarly, let me extract the title and the author's name, where the book ID is 2750. So here we see that the book recommended is Mrs. Pigglewiggle, and the authors are Betty McDonald and Alexandra Boyger. Similarly, let me extract the titles for the book ID 3029. Let's see what do we get. 3029. So the book recommended is Rage of Angels, and the author is Sidney Sheldon. Right, so these are the 6 books which have been recommended, and this is how we can extract the name of the book and the author of the book. Now similarly, let's also go ahead and recommend 6 books for the user number 5. So this is what I'd have to do. I will be using the rec predicted UBCF object, and I'll be using the @tag and extracting the items for user number 5. And I'll store this result in user 5 book numbers. So now that we have the item numbers, let's actually extract the column numbers for each of these items. So for this, the command would be rec predicted UBCF @item labels, and inside this I will give in the book numbers. Right, so these are the book IDs which have been predicted. Right, so similarly, let's extract the title and authors for some of these book IDs. So we are extracting the title and the author's name, where the book ID is 4624. So the recommended book, so the name of the recommended book is The Girl Who Circumnavigated Fairyland in a Ship of Her Own Making, and the author is Catherine M. Valentine and Anna Wan. Similarly, let's extract the name of the book and the author's name, where the book ID is 6867. So here the book is Malgudi Days, and it's been written by R.K. Narayan and Jhumpalari. Now let me extract the title and the author's name for the book ID, which is 7326. So the book's name is Doctors, and it has been written by Eric Segal. Right guys, so we have successfully implemented the user-based collaborative filtering model, and we have recommended 6 books to 2 different users. Alright, so now let's have a look at the quiz. So which of these libraries is used to implement collaborative filtering models in R? And these are your options. Is it Recommender, or Recommender Lab, or UBCF Lab, or Collab Lab? So what do you think is the answer? So what do you think is correct? Put down in the chat box and we'll reply.
So a fraud by definition is an act of deception that is used illegally to deprive a person or an organization or entity of money, property, or legal rights. So if we talk about financial frauds, which are the most common type of frauds, so a typical organization loses around 5% of their yearly revenues to fraudulent cases. And according to an RTI report, there were around 2,480 cases of frauds in 18 public sector banks, which involved around 32,000 crores. And according to an RBI report, in 2017 and 18, a total of 911 credit card fraud cases were there, which amounts to around 65 crore rupees, which were illegally transferred from different bank accounts. So now let's discuss some of the types of frauds that we can encounter in our daily lives. So the most common types of frauds nowadays are online frauds, where a person's account may be hacked and all his money can be transferred to different accounts illegally. And the most common types of frauds nowadays are the credit card frauds, where stolen credit cards and credit card numbers are used to make illegal transactions. And then we have threats and theft of inventory when someone breaks into a bank or an ATM. And then we have other types of frauds where someone can steal your idea or your professional work. So now that we know what are frauds and what are the different types of frauds and how they can affect different organizations and how important it is to detect the frauds and save ourselves from heavy losses. So now we'll discuss some of the rule-based approaches or traditional approaches that are used for detecting frauds. So in the rule-based approaches, the algorithms are actually written by fraud analysts, and these are based on strict rules. So if there are any changes that have to be made for detecting a new type of fraud, so they are all done manually. So either by making those changes in the already existing algorithms or by creating new algorithms. So in this approach, whenever there's an increase in the number of customers and the data, the human effort also increases. So in conclusion, we can say that the rule-based approaches are time consuming and they are costly. So now let's discuss some of the drawbacks of the rule-based approaches. So one drawback of the rule-based approach is that it is more likely to have false positives. So this is a type of error condition where the output of a transaction, it depends upon the rules and the guidelines that we have made for the training algorithm. So if you have a fixed rule and a fixed threshold, and if a transaction is rejected where it should not be rejected, so it will generate a condition of high rates of false positives. So these false positive conditions actually result in losing a lot of genuine customers. So our rule-based approaches cannot recognize hidden patterns since all of the rules are mentioned by the fraud analyst, and it cannot also predict new types of frauds because it always abides the rules that are mentioned by the fraud analysts, and that leads us to a situation where it cannot respond to new situations which is not trained on or it is not explicitly programmed on. So now that brings us to our next topic, that is how we can use data science to solve these problems and use data science for fraud detection. So the modern alternative is to leverage the vast amounts of big data that is collected from different online transactions and model it in such a way that allows us to flag or predict fraud in the future transactions. So for these, different data science techniques such as machine learning and deep neural networks are the obvious solutions. So here I'm going to show you an example of how machine learning techniques can be used to identify fraud in financial transactions. So machine learning is a broad field. It has a large collection of algorithms and techniques that are used in classification, regression, clustering, or anomaly detection. So two main classes are supervised and unsupervised learning. So in supervised learning, it is used to predict either the values of a response variable, which is also called regression, or the labels of a set of predefined categories, which is also called classification tasks. So in supervised learning, the algorithms learn how to predict unknown samples based on the data of samples with known response variables and labels. So in fraud detection, we are technically dealing with the classification task. So for each sample, that is a transaction, the predefined labels tells us whether it is a fraud transaction or not. So however, there are two main problems while using supervised learning for fraud detection. So the first problem is data labeling. So in many cases, fraud is actually difficult to identify, and some cases will be obvious, some cases will be easy to recognize with rule-based techniques, and they usually won't require complex models. So where it becomes interesting are the subtle cases. So they're hard to recognize as we don't usually know what to look for. So here we use the power of machine learning, but because fraud is something that is hard to detect, so our training data sets that is collected from the past transactions are probably not classified correctly in many of these cases. So this means that the predefined labels will be wrong and some of the transactions will be wrongly labeled. So in this case, our supervised machine learning algorithms won't be able to learn how to find these type of transactions or these type of frauds in the future transactions. And the next problem that we face is the unbalanced data. So an important characteristics of fraud data is that it is highly unbalanced. So this means that one class is much frequent than the other. So in a fraud detection example, less than 1% of the transaction will be fraudulent. So in most of the cases, you'll find that less than 1% of all the transactions are fraud transactions, and most of the supervised machine learning algorithms, they are actually very sensitive to unbalanced data. So we have to use different techniques to balance the data before we actually use the supervised machine learning algorithms to predict the fraud cases in the future. So the next class of problems that we can solve is using the unsupervised learning. So it does not require or predefined labels or response variables. So it is used to identify clusters or outliers or anomalies in the datasets. So in our fraud dataset, we don't trust the predicted labels to be 100% correct So hence there will be a lot of incorrect labels as well, but we can assume that the fraudulent transactions will be sufficiently different from the vast majority of regular transactions, so that our supervised learning algorithms will flag them as anomalies or outliers. So in supervised learning, we can use the dimensionality reduction, which is also called a type of dimensionality reduction is called principal component analysis. So in preparation for our machine learning analysis, dimensionality reduction techniques are very powerful tools, and they are used to identify hidden patterns in the data. And whenever we have high dimensions in the data, so it is better to use PCA so that we can reduce the number of features for machine learning while preserving the most important patterns of the data. And similar approaches can be used, such as clustering algorithms, and like k-means clustering can also be used to find the patterns in the data using number of clusters. So in this video we are going to use the supervised machine learning model on our data set so that we can predict future fraud transactions.
Just a quick info guys, if you want to become a certified data scientist, then Intellipaat provides just the right course for you. You can check the link in the description box below. Now let's continue with the session.
So now let's discuss some of the challenges that we'll face while building a machine learning model on our credit card dataset. So various challenges arise when building models for fraud detection. So the first challenge is the unbalanced data. So there are plenty of legitimate cases, but only a very few fraudulent cases. So for example, in a credit card transaction, typically less than 0.5% of the transactions are fraudulent. So it might cause an analytical technique to experience difficulties in creating an accurate model. And depending on the exact application, operational efficiency may be a key requirement. So the fraud detection system might only have a limited amount of time available to reach a decision. So in a credit card fraud detection setting, the decision time to let a transaction pass or not is typically less than 8 seconds. And also incorrect flagging. So when flagging a particular transaction, if the transaction is flagged as fraudulent for a good customer, so you risk losing this customer due to the harassment caused by flagging the transaction as fraudulent. So now let's discuss some of the techniques that we can use to solve the first type of challenge, that is unbalanced data. So here you will find that most of the cases in a data set, most of the transactions will be legitimate transactions and very less transactions will be fraudulent transactions. So if you train your classifier model on this, so your classifier will tend to favor the majority class, that is your legitimate transactions, so which results in large classification error over the fraud cases, since it has not learned much because of the less data available to it. So the classifiers actually learn better when it is trained on a balanced distribution rather than an unbalanced data. So now we'll discuss sampling methods to solve this unbalanced data problem. So we always perform the sampling methods on the training set, not on the test set. So we'll always divide our data set into two sets, that is our training and test sets. So we'll build our model on the training set, and before building the model we'll balance the training set so that our model learns on the training set, and then we'll use the original test set, which is the unbalanced test set, to predict whether a transaction is fraudulent or legitimate. So the first technique is called the random oversampling technique. So in this technique we oversample the minority class, which is our fraud cases. So we copy the cases that are already present in our fraudulent cases. So we'll just copy the same cases multiple times till we reach a particular threshold or the value of the cases that we want in our dataset. And the other technique that we can use is the random undersampling. So in this technique we undersample the majority class, which is our legitimate cases. So we remove some of the cases that are present in our dataset which are from the legitimate transactions. So we'll remove some of those cases, and then we'll downgrade some of those cases till we have a dataset that has an equal distribution or an almost equal distribution of both the fraudulent and the legitimate cases. Or we can do both, so either we can up sample or we can down sample. So now let's discuss some of the techniques that we can use to solve the first type of challenge, that is our unbalanced data. So you'll find that most of the data sets have most of the transactions as legitimate and very few transactions as fraudulent. So if you train your classifier model on this particular data set, so our classifier will tend to favor the majority class, that is the legitimate cases, so which results in the large classification error over the fraud cases, since it has not learned much from the fraudulent data because the data that was available to it was very few. So now let's discuss some of the techniques that we can use to solve the first type of challenge, that is our unbalanced data. So you'll find that in most of the data sets or legitimate cases, they are outnumbered
Just a quick info guys, if you want to become a certified data scientist, then Intellipaat provides just the right course for you. You can check the link in the description box below. Now let's continue with the session.
So now let's discuss some of the techniques that we can use to solve the first type of challenge, that is our unbalanced data. So you'll find that in most of the data sets, most of the transactions are legitimate transactions and there are very few transactions which are fraud transactions. So if you perform a classification model on top of this data set, your classifier will tend to favor the majority class, that is all legitimate cases. So which means that it will show a huge classification error over the fraud cases. So classifiers actually learn better from a balanced distribution. So if you train or model on a balanced distribution, it is more likely that we have a less classification error for our fraud cases and it will be easily available to us. So now let's discuss some of the techniques that we can use to solve the first type of challenge, that is our unbalanced data. So you'll find that in most of the data sets, most of the transactions are actually legitimate transactions and very less transactions are fraud transactions. So if you create your machine learning model on this type of data set, your classifier will tend to favor the majority class, which is your legitimate transactions, and which will result in large classification error over the fraud cases. So our classifiers or our machine learning models, they learn better from a balanced distribution where the balance of the two classes, that is legitimate and fraud, can be equal. So now let's discuss some of the methods that we can use to solve the first type of challenge, that is our unbalanced dataset. So you'll find that most of the datasets, they have large number of legitimate cases and very few fraudulent cases, since in credit card transactions less than 0.5% of the transactions are fraudulent. So our classifier or our machine learning model will tend to favor the majority class, that is our legitimate cases. So which means that it will show a large classification error over the fraud cases. Will not be able to identify which case is fraud or not. So our classifiers actually learn better from a balanced distribution instead of an unbalanced data. So now let us discuss different sampling methods used to balance an unbalanced dataset. So the first technique is called the random oversampling. So in random oversampling, we increase the number of fraud transactions in the dataset by creating duplicates of the already present fraud cases. And the next technique is called the random undersampling. So in random undersampling, we decrease the number of legitimate cases to get a balanced distribution. And also we can perform both random oversampling and random undersampling by increasing the number of fraud cases and decreasing the number of legitimate cases. So now this is how our dataset will look like after performing both the oversampling and the undersampling. But the problem with oversampling is that it is done by creating duplicates of the fraud cases that are already present in our dataset. So that means that we will be training our model using a lot of duplicate values which won't explain the variance in the data. And the problem with undersampling is that we end up throwing away a lot of useful data and information which is not preferred in general. So that brings us to our next sampling technique, which is called the synthetic minority oversampling technique, aka SMOT. So in this technique, we oversample the fraud cases by creating synthetic fraud cases. So if you look at the scatter plot at the right hand side, the green dots here represent the legitimate cases and the red dots here represent the fraud cases. So in SMOT, we find the k nearest neighbor of a fraud case, let's say x here, and let's take the value of k as 3, so we'll find the 3 nearest neighbors of x. And after choosing the nearest neighbors, we'll randomly choose one of the x's nearest neighbors, let's say y here, and then we add a synthetic sample using the following method. So we'll take the x and the y coordinate of both the points and find the x and the y coordinate of a synthetic point, which is given as follows. So the synthetic point will lie on the line that joins both x and y, and here the number 0.3, it is a random number between 0 and 1. So we can use different numbers between 0 and 1 so that we get different synthetic samples that are present on the line that joins x and y. And we can also repeat this step multiple times for each neighbor of x, which is a fraudulent case, to get a desired value of the fraud cases in our dataset, and hence we'll get a balanced dataset after all.
Just a quick info guys, if you want to become a certified data scientist, then Intellipaat provides just the right course for you. You can check the link in the description box below. Now let's continue with the session.
So now let's go to RStudio to implement credit card fraud detection model using SMOT. So now let's build a fraud detection model in R. So first of all, we will import the dataset that we are going to work on. So I've stored my dataset in this particular folder. So once I load this dataset using the read.csv function, and I'll store the dataset in credit_card data frame. So if I run this line, your dataset will be imported, and after importing the dataset, we'll look at how our dataset looks like. So after your dataset is imported, you can click on the dataset name in the variable explorer, And once you click on the name, you will find that our dataset contains 284807 entries, that is rows, and around 31 columns. So this dataset is about different transactions made by different credit card users. And the first column here you can see is the time. So this is the time stamp. And then we have columns from V1 to V28. So these columns are actually the reduced versions using the dimensionality reduction. So the actual dataset contains the actual columns which the dataset does not contain. So these are actually the reduced versions using the PCA, so that the confidentiality of the users is maintained. So these are different features that are extracted from the actual features using the dimensionality reduction. So after the 28th column or the 29th column, we have the amount column that represents the amount of transaction that was done using this particular credit card. And then the last column here you can see is the class column, which contains two values, that is 0 or 1. So 0 here represents that the transaction was a legitimate transaction, and 1 represents that the transaction was a fraud transaction. So after that, let's look at the structure of the dataset and see what are the different types of variables that we have in our dataset. So if you use the structure function and write the name of your dataset, that is credit card, so you'll see we have around 31 variables, that is columns, and most of the variables are numerical columns. And the last column here you can see is class, which is also an integer column, but in actual it is not an integer column, it is a categorical column. It has two categories, that is 0 and 1, and 0 here represents the legitimate transactions and 1 represents the fraud transactions. So first of all, we will convert our class column to a factor column, two levels, that is 0 and 1, so that we can work with our dataset later on. So we'll convert this to a factor column using the factor function, and I'll pass the name of the variable, that is credit card $class, and then we have two levels, that is 0 and 1, 0 for legitimate cases and 1 for fraud cases. So we'll again store it in the same variable, that is credit card $class. So once you run this function, if you now look at the structure of the dataset, so you'll see now our class column is a factor column with two factors, that is 0 and 1. 0 here represents the legitimate transactions and 1 represents the fraud transactions. So now let's look at the summary of the dataset to display the summary statistics of different columns. So here you can see the last column is a class column. So here around 284315 entries are legitimate cases, that is 0, and only 492 entries are your fraud cases, that is 1. And then we have most of the columns are integer columns with mean of 0, and the first column is our timestamp. So now before moving ahead, now let's check whether there are any missing values in our dataset or not. So we'll use the is.na function to check whether there are any missing values in our dataset or not, and then the sum function will count the number of missing values if there are any. So once we run this function, we'll see that we don't have any missing values in the dataset, so it is okay for us to continue and work with our dataset. So now we have to use the class column. So first of all, let's see how many fraudulent and legitimate transactions are actually there in our dataset. So we'll get the distribution of fraud and legitimate cases or legitimate transaction in the dataset. We'll use the table function, and inside the table function we'll write the variable that we want the distribution for. So our variables or the transactions are stored in class variable in our credit card dataset. So we'll use the table function to get the distribution of different transactions. So here, after running this command, here you can clearly see that 0 represents the legitimate transactions, and most of the transactions in this dataset are legitimate transactions. So there are around 284315 legitimate transactions and only 492 fraud transactions. And if you want to get the percentage of the transactions, you can use the prop table function, and then inside the prop table function you can write the table function, which will get you the distributions, and the prop table function will get you the percentages of the distribution. So here you can see that 99% of the more than 99.82% of the transactions in this dataset are legitimate transactions, and only 0.001% transactions are fraud transactions. So clearly we can see this is an imbalanced dataset. So now let's also plot a pie chart to get the distributions of our legitimate and fraud cases in our dataset. So we'll firstly set the labels of our pie chart. So the labels are legit and fraud. So we'll create a vector that contains two strings, that is legit and fraud, and we'll store that in labels. And after that we'll paste or we'll concatenate the percentages of your fraudulent cases and legitimate cases with the respective labels. So if you pass two vectors in the paste function, so first we'll use the paste function to concatenate two strings. So first vector that we have passed is the labels, which contains two values, legit and fraud, and then we'll pass the round function. So this function will actually calculate the percentages of the distributions. So we'll calculate the percentages of the prop table that we have just seen above, which will display this particular result, and we'll multiply it by 100 to get the percentage, and then we'll round this percentage to 2 digits. So we'll only get 2 digits after the point. So we'll use the round function, which will contain our percentages up to 2 digits of decimal, and then we'll have the labels, which contains your two strings, that is legit and fraud, and we'll paste it together and we'll store the result in labels. So if you run this command and I look at the labels right now, so now your labels actually look like this. We have a 99.83%. so here we have rounded the values up to 2 decimals using the round function here, and the fraud cases are 0.1% and legit cases are 99.83%. So clearly we can see there is an imbalance in our data set. So let's plot a pie chart first of all to get the distribution or display the distributions of our legitimate and fraud cases. So we use the default pie function from the default R package, and we want a pie chart for the different distributions or the different categories of the class variable in our credit card data set, and we'll use the table function to get the different distributions of the categories, and our labels will be equal to these labels, and then the color of the labels will be according to the orange and the red. So the orange will represent the number of legitimate cases and the red represents the number of fraud cases. And then this is the title of our pie plot. So our title will be pie chart of credit card transactions. So let's run this command to get a pie plot. So this is our pie chart for our credit card transactions, and here you can see most of the color is orange. It means we have around 99.83% of the legitimate transactions and only 0.17% are fraud transactions. So now if you make a model on this particular data, so you will get most of the accuracy. So we'll first of all make a model that is no model. So even if you don't have any particular machine learning model, and if you predict that every single transaction in this data set is a legitimate transaction, so you can see what kind of accuracy we'll get. So first of all, we'll predict that all the transactions in this data set are legitimate transactions. So we'll store our predictions in predictions variable, and we'll repeat integer 0 equal to the number of rows that are present in our credit card dataset. So in our credit card dataset we have around 284807 rows. So we'll create a vector that will contain zeros 284807 times. So after creating a vector, we'll convert this vector to a factor variable with two levels, that is 0 and 1. Here 0 represents the legitimate transactions and 1 represents the fraud transactions. So we are predicting without using any model that all the transactions are legitimate transactions. So once you run this command, we'll factor out or we'll convert this particular vector to a factor with two levels, that is our legitimate transactions and fraud transactions 0 and 1. So after that, we'll use the confusion matrix to get the accuracy for these particular predictions, or that we have done without using any particular model. So we'll use the caret package. So if you have not installed this package, you can use the install.packages command and write the name of your package to install it. And then after installing the package, you can load the package using the library function. And once you run this command, your package will be loaded, and then you can use the confusion matrix function from the caret package to get the confusion matrix and the accuracy. And if you want to know more about this particular function, you can press F1 here, so it will take you to the documentation on the right hand side, and then you can know more about this particular function. So in this function, we'll firstly pass our predictions that we have stored in predictions variable as data, and then we have our reference variable, which will contains the actual classes that we have predicted. So we have predicted the classes of the credit card dataset. We will pass our reference variable or the actual classes that we have predicted. So once we run this command, we'll get the confusion matrix for this particular model that we have built without using any machine learning model. So here you can clearly see that we have correctly classified all the samples that were all the transactions that were legitimate transactions, but we have not classified any of the transactions that was a fraudulent transaction. So still we get an accuracy of 99.83% because we have flagged every transaction as a legitimate transaction, and we have not flagged all the fraud transactions as fraud transactions. So this will be your true positives and this will be your true negatives, which are the correctly classified values. So our true positives are total and our true negatives are 0. It means we have wrongly classified all the samples that were fraudulent transactions. Here your 0 represents legitimate transactions and 1 represents your fraud transactions. So out of all the fraud transactions, we have flagged all the transactions as legitimate transactions, which are false positives. So here you can clearly see that if you only check the accuracy of the model that we built, so we'll be wrong most of the times because here accuracy does not represent anything. Here our goal is to maximize the number of cases or maximize the true negative so that we can classify most of the fraud transactions as fraud transactions. So now let's move ahead and build a model. So before moving ahead, we will take a small subset of our data set so that it is computationally more faster, and later on, once you have built a model on the smaller subset that you can make, then you can make the model on the whole data set, which will take some time. So we'll take a smaller version of the data set so that we can compute it faster. So we'll use the dplyr package to get a small fraction of our whole dataset, that is credit card. So I'll load the dplyr package first of all. So after loading the dplyr package, I'll use the sample fraction function, sample frac function, to get the fraction of our dataset, which will be random fraction. So it will contain both zeros and ones, and I'll pass my credit card dataset using the forward pipe operator, which will pass my credit card dataset to the sample frac function, which will extract 0.1%, that is 10% of the samples or 10% of the rows that are present in our dataset. So right now our dataset contains 284807. So after extracting 10% of the rows, it will be 28,480 rows, and we'll store the result in our credit card data frame again. And we have used the set seed function. So if we run this particular code again, so we will get the same sample again. And if you don't use the set seed function and you run this code again and again, so your sample will be different every time. So we'll run these two lines together and we'll get a sample that will be 10% of all the rows that are present in our actual data set. So now let's look at the data set. That is a fraction, that is a subset of our original data set. So we have around 28,481 rows and all the columns. So this is a 10% of data set, and then we'll make a model on this particular data, and after building a model later on, we can build the model on whole data set. So now let's see what is the distribution of classes that we have in this particular data. So right now we have around 28,437 transactions as legitimate transactions and only 44 transactions as illegitimate or fraud transactions. And now let's plot a scatter plot between the two columns, that is v1 and v2. So we'll plot a scatter plot between the columns v1 and v2, and we'll see what is the distribution of classes between these two variables. So we'll use the ggplot2 function to plot a scatter plot. So firstly I'll load the ggplot2 library, and after loading the ggplot2 library, I'll use the ggplot function to plot a scatter plot. So ggplot function is based on grammar of graphics, so it has different layers that we stack upon each other to build a final plot. So our first layer is our data layer, where we pass our data frame. So our data frame is our credit card data frame that we have just extracted from the whole data frame. And then we have our second layer as the statics layer. So in the statics layer, we have our variables that we want to plot on our scatter plot. So on the x-axis we have our variable v1, and on the y-axis we have our variable v2, and we want the color of the points of the scatter plot according to the different categories of the classes. So we'll have two categories in the classes, that is 0 and 1. So we'll have two different colors for each particular category. And then to plot a scatter plot, we'll add the third layer using the plus sign here. So our third layer is our geom layer. So in the geometry layer, we'll pass our function that we want to plot scatter plot for. So here if we want to plot a scatter plot, we'll pass geom underscore point. So it will plot a scatter plot for us. And then if you want to change the background of your plot, so we can use the theme function. So theme bw, that is black and white. So it will make the background of your plot as black and white. And then you can also change the color of the points. So to here, this will get you the basic plot that we want. So if you zoom in on this plot, you can see that this particular color represents our legitimate cases, and our blue color here represents our fraud cases. So if you want to change the background of this particular plot, so you can use the theme function, which will change the background to black and white. And if you want to change the color of these points to different colors, so we can use the scale color manual function, and inside of that function we can declare our values. So our values of the colors are dodger, blue 2 and red. So now this color represents the 0, that is legitimate cases, and red represents the fraud cases. So now let's run the whole command and we'll get the final plot, black and white background and these colors as the color of the points. So if you zoom in on this particular plot, you will find that now this particular color, dodger blue 2, represents our legitimate cases, and our red color represents our fraud cases. So here also clearly you can see that we have a comparatively huge number of legitimate cases and only a few fraud cases. So if you train your model on this particular data, our model will not be able to learn a lot because the number of fraud cases are very less. So we have to use different techniques to balance the dataset before we actually make or build a model on this particular data. So before balancing the dataset, we'll first of all create training and test sets. So we only use balancing on the training set to train the model, and we don't use balancing on the test set because that will be the original test set that will predict values for. So first of all, we'll create training and test sets, and then we'll balance the training set and train our model, and then evaluate the performance of the model using the test set. So now let's build our training and test sets for the fraud detection model. So we'll be using the CA2's library. So if you have not installed this library, you can use the install.packages and the name of the library to install it. And after installing this library, you can use the library function to load the library, and after loading the library, we can use the sample.split function to split our dataset into two sets, that is training and test sets. So in the sample.split function, if you want to know more about this function, you can press F1 here. So it will take you to the documentation on the right hand side. So now if you want to split your dataset into training and test sets, so here we'll pass our column that we want to split according to. So since we are going to predict whether a transaction is a fake transaction or a legitimate transaction, so that column is a class column that represents zeros and ones. So we'll use the class column to split our dataset into training and test sets. So I'll pass the column, my class column, from the credit card dataset, and now I'll mention the split ratio, which will represent how many rows I want in the training set and how many rows I want in the test set. So if you write split a ratio equals 0.8, so 80% of the rows that are present in your dataset will be in the train set, and 20% of the rows that are present in your dataset will be in the test set. So if you run this particular line, and we'll store the result in data sample. So once you run this line, and if you look at the data sample now, so it will contain true and false values. So here the true values will be 0.8. So 80% of the values here will be true, and 20% of the values here will be false. And these number of values will be equal to the number of rows that we have in our dataset. So now we'll use this particular object to split our dataset into two sets using the subset function. So we'll use the subset function on our credit card dataset, and we'll check wherever the sample value is true. We'll store all those rows in train data. So after running this line, our 80% of the rows from the credit card dataset will be in the train data, and wherever the data sample value is false, we'll store all those rows in the test data. So 20% of the rows in the credit card dataset will be in the test data. So now let's run all these lines together. So now we have successfully created our train data and test data. So now let's click on the train data in the variable explorer to see how many rows are there. So we have around 22,785 rows in our training data. That is 80% of the rows of the whole data set. And then if you look at the test data, so we have around 5,696 rows in the test data and all the columns. So we'll train our model on the train data after balancing this data, and then we'll test the performance of the model using confusion matrix on the test data. So now if you want to check the dimensions of your training and test data, you can use the dim function. So it will display the dimensions. So our training data contains 22,785 rows, and our test data contains 5,696 rows, and all the columns, that is 31 columns. So now before making a model, we have to balance our data set first. So we'll use different techniques. So the first technique that we're going to use is called the random oversampling, which means that we will increase the number of fraud cases in our data set. So we'll oversample the minority class. So right now, if you look at the distribution of the class variable, you can see around 22,750 transactions are legitimate transactions, and only 35 transactions are fraud transactions. So now if you want to increase the number of fraud transactions, so we'll use this particular method. So first of all, we'll write how many, we'll store our number of rows in our dataset or number of legitimate transactions in our dataset in nlegit variable, and then we'll store the number of fraction or the amount of fraction that we want for our fraud cases. So if we want our fraud cases to be 50% of the whole dataset using the random oversampling, so we'll write 0.50 and we'll store the result in new fraction legit. So now this fraction will be 50%. So in our final data set, after performing the random oversampling, the 50% of the rows will be your legitimate transactions and 50% of the rows will be fraud transactions. Now if you want to calculate how many rows should be there in our data set to accumulate both of the legitimate and fraud transactions as 50%, so we'll divide the number of legitimate cases by the fraction, and it will tell us how many rows we want in our data set to balance our legitimate and fraud transactions as 50-50%. So after dividing the number of legitimate cases by the fraction, we'll get the number of rows that we want in our data set. So if you run this function, we have stored the number of rows in new and total. So if you click on new and total, so you'll find that we need around 45,500 rows in our data set, and out of these rows, 50% of the rows or 50% of the cases will be fraud cases and 50% of the cases will be legitimate cases. So now to perform random oversampling, we'll use a package called rows. So if you have not installed this package, you can install the package using install.packages function, and then write the name of the package that we want to install. And after you have installed the package, you can use the library function to load the package so that you can use the functions that are included in this package. So in this package, you're going to use the o1.sample function, which will help us to perform random oversampling. So if you want to know more about this function, you can press F1 here. So it will take you to the documentation of this function. So in this documentation, you can see the first argument that we want is our formula argument. So in the formula argument, we have to mention our variables that we want to oversample. So here our class variable is the variable that we want to oversample, and then we have used the dot, which means the rest of the variables are independent variables, and this tilde sign is used to separate our independent and dependent variables. So our class is our variable that we want to oversample, or that we will predict later on, and we'll use all of the variables in our dataset except the class variable, which we can mention using the dot symbol here. And after the second argument is our data argument, so it will require the data that we want to oversample. So our data comes from trained data that we have just created above our training set. And the third argument here you can see is our method argument. So if you go to the documentation, you can see that we have three methods, that is over, under, and both. So firstly, we'll perform the oversampling of the minority samples. So we'll use method equals over, and then we have our n argument, which will be the number of rows in the new dataset after the oversampling is performed. So that is equal to the number of new and total, which is 45,500 rows. And then we will also use the seed function, so that if we run this code again, so we will be getting the same sample again, or the same number of oversampled rows again and again. So let's run this function now to get our oversampling result. So after running this function, if you just click at the variable that has been created, so here you can see we have different attributes of this variable, that is oversampling result. So our data is actually stored in the data attribute. So if you want to reach the data attribute, you can use the oversampling data and then the data attribute, and we'll store the data set in oversample credit. So if you store the result in oversample credit, and now if you look at the distribution of the classes that we have after random oversampling, so you will find that we have 22,750 legitimate cases and 22,750 fraud cases. So now the distribution of our fraudulent and legitimate cases are equal using the random oversampling. So before moving ahead, let's plot this distribution using the same V1 and V2 columns of our oversampling result. So now if you click at the oversampling credit, so this is our oversampling credit, we have 45,500 rows. So let's plot a scatter plot between V1 and V2 and see what is the distribution of classes between these two variables. So we'll use the ggplot function to plot a scatter plot again. So here now our data comes from oversample credit here, and then we have the variables v1 on the x-axis and v2 on the y-axis, and the color of the points will be according to the categories of the class column, that is 0 and 1. And then we'll use the geom function. So if you want to plot a geom, so if you want to plot a scatter plot, we'll use the geom point function, and then the theme of our plot will be black and white using the theme function, and the color of the points will be dodger blue and red. So if you want to change the color, you can use this scale color manual function. So once you run this command, you will get a scatter plot between v1 and v2 that represents your oversampled data set that we have just created using the rows package. So now if you zoom in here, you will find that we have the blue color or the dodger blue color as class 0, which is the legitimate cases, and the red will be our fraud cases. So here you can see still our points do not represent a lot of points compared to the blue points. So the reason is that in our random oversampling, we create duplicate points. So most of these points are overlapping on each other, because we in random oversampling will just create duplicate points that are already present in our dataset. So if you want to know whether there are points overlapping on each other or not, so we'll add some jitter to these points. So once we add some jitter to these points, so you'll see that there will be a lot of points in this on top of each other, because we have just created duplicate points using the random oversampling. So to add jitter to the points, we'll use the position argument of the geom point function. So if you set your position argument to position jitter, and inside the position jitter function, we can mention our width of the jitter that we want. So if you write 0.1 here, so now if you run this function, you'll find that there will be a lot of points that are overplotted or stacked upon each other, because we have just created duplicate points using the random oversampling. So now here you can see the points. When you add some jitter, you will find there are a lot of points that are stacked up on top of each other, because we have just performed the duplicate values. We have just increased the number of duplicate values using the random oversampling. So now let's perform our random undersampling. So in random oversampling, we just train our model on duplicate values, which is not a good condition. So we'll see what is random undersampling. So in random undersampling, we'll reduce the number of legitimate cases. We'll keep the legitimate cases equal to the number of fraud cases. So let's first of all see the distribution of our credit card dataset. So we have this distribution. We have around 22,750 legitimate cases and only 35 fraud cases in our training set. So now if you want to set the number of legitimate cases equal to the number of fraud cases, so we'll use this method. So first of all, we'll store the number of fraud cases in n fraud, and then we'll calculate we'll store the fraction that we want for our fraud cases or our legitimate cases. So we want the number of fraud cases equal to 50% of the whole data. So we'll store that in n frac fraud, and then we want to calculate the number of rows that will be in our data set so that our fraud cases and legitimate cases are equal in number. So we'll divide the number of fraud cases by the fraction that we want our fraud cases to be in, that is 0.5. So once we divide it, we'll get the total number of rows that we need in our data set to satisfy this fraction. And once you run this particular command, so if you look at your new total, so now our data set will contain 70 rows, and out of the 70 rows, 35 rows will be number of legitimate cases and 35 rows will be number of fraud cases. So now let's use the o1.sample to create that particular data. So we'll use the same o1.sample, and now instead of mentioning the method as over, we'll write method as under, and then all of the arguments are same. So you just have to change the method, and once you run this particular function or particular command, so now your undersampling result will be calculated. And now if you want to get to the data set that is stored in undersampling result, so we'll get the dataset attribute or the data attribute of the undersampling result, and we'll store that in undersampled credit. So once you run this line, you will have your data set that is undersampled credit. And if you look at your data set right now, so we have around 70 rows, and out of these 70 rows, 35 rows will have legitimate cases and 35 rows are fraud cases. So now let's plot scatter plot between same v1 and v2 to see how our distribution of the points look like and the distribution of the classes look like between these two variables v1 and v2. So if you plot it now, so you'll see that now we have equal number of legitimate cases and fraud cases. So in random oversampling, we decrease the number of legitimate cases to a certain ratio so that we have more, or we have an equal distribution of legitimate and fraud cases. But the problem here is that we end up losing a lot of data which is not preferred in a general case. So now we'll perform both the random oversampling and undersampling to see how our data actually looks like. So now we'll perform both random oversampling and undersampling. So now the number of rows that we want in our dataset will be equal to the number of rows that are present in our training set. So our new dataset will also contain the same number of rows, that is 22785. And now we want our fractions of the legitimate and fraud cases equally in our dataset. So out of the 22,785 rows, 50% of the rows will be fraud cases and 50% of the rows will be legitimate cases. So we're not going to increase or decrease anything. We're just going to resample our dataset in such a way that 50% of the rows will be fraud cases and 50% of the rows will be legitimate cases, using both random oversampling for increasing the number of fraud cases and random undersampling to decreasing the number of legitimate cases. So after storing our fraction in the fraction of fraud new variable, we'll use the same o1.sample. So now we have used the method as both. So here if you want to perform both random oversampling and undersampling, you can use the method as both. And then the n argument here is the number of rows that we want in our new dataset, and then the p is your probability of fraction. So if the method is both here, so the probability will be default by 0.5. So 50% of the rows will be your legitimate cases and 50% of the rows will be fraud cases. And then we have used the seed function so that we get the same sample again and again if you run this code again. So now if you run this code and if you get to the dataset using the data attribute of the sampling result, you will store that dataset in sampled credit. Now let's look at the dataset. So we have around 2785 rows, and out of the 22,785 rows, you can see around 11,430 rows are legitimate cases and 11,355 rows are fraud cases. So if you want to get the percentages of these rows, so you'll get around 50% of the data are legitimate cases or legitimate transactions, and 49.8% are fraud transactions. So now let's plot a scatter plot between v1 and v2 to see how our class distribution looks like. So I've already added some jitter so that we can see the overlapping of the points, because we have performed random oversampling and undersampling both. So we have reduced some number of legitimate cases and we have increased some number of fraud cases. So now they are in equal ratio. but the number of fraud cases are overlapping on each other because they are duplicates of each other, and the number of legitimate cases are scattered on whole of the plot. So now let's move ahead and use the third method that we use, which is called the SMOT, which is the synthetic minority oversampling technique, which will add the synthetic samples in our dataset without actually creating duplicates of the fraud cases. So to implement SMOT, we use this library called SMOT family. So if you have not installed this library, you can use the install.packages and the name of the library to install it first, and then after installing you can use the library function to load the library to use the functions that are contained in this library. So after loading the library, if you look at the class distribution, we have the same class distribution, that is 22,750 are legitimate cases in our trained data and 35 are the fraud cases in our trained data. So now we want to increase the number of legitimate cases, or we want to add synthetic samples of the fraud cases so that we have a balanced data set that we can use to train our model. So we'll start by first of all setting the number of fraud and legitimate cases and the desired percentage of the legitimate cases that we want in our dataset. So our legitimate cases are represented by N0 here. So we have around 22,750 legitimate cases, and N1 are the fraud cases. So we have around 35 fraud transactions, and then R0 represents the ratio that we want in our dataset after the SMOT. So we want 60% of our rows should be legitimate cases and 40% of the rows will be fraud cases. So we'll add synthetic samples in such a way that after adding the synthetic samples, our data set has 60% of the legitimate cases and 40% of the fraud cases. So now to get the number of times that we have to perform SMOT to get the desired number of ratio of the legitimate and fraud cases, so we'll use this SMOT function first of all from the SMOT family. And if you want to know more about this function, you can press F1 here, and you can see we have different arguments, that is X, which is our data that we want to apply SMOT on. Then we have our target value, so the vector of the target class attribute corresponding to our dataset X. So our X will be our independent variables, and our target will be our dependent variable that we are going to predict later on, and K is the number of nearest neighbors we want during the sampling. And then we have our dupe size, so it will be the number of times we run our SMOT, or number of times we want to run our SMOT to add different synthetic samples. So if you want to get the number of the dupe size, which will actually tell us how many times we have to run SMOT in order to get the desired percentage of all legitimate and fraud cases, so we'll use this formula. So this formula will help us to get the number of times we have to run SMOT in order to get a percentage of synthetic cases such that our final data frame contains 60% of the legitimate cases and 40% of the fraud cases. So using this formula, which contains both R0, N0 and N1, once you run this here, and before running this we have to run these three together, and after that if you run this, so if you now look at the number of times, so we'll get we have to run 432 times. So after running 432 times on the SMOT, we'll get to a value of your variables in such a way, or value of the points in such a way that 60% of the points will be flagged as legitimate transaction and 40% will be fraud transaction. So we'll use the SMOT function first of all, and our X will be our training data. So if you look at your trained data right now, so our trained data first column is our time column. So we are not going to use this particular column because we are only going to use these features V1 and V2 up to V28. So we'll be removing this particular feature from our data, and then we'll also remove the last column, which is our target column, which is our class column, which is 31st column. So we'll remove these two columns, and our training data will be from amount till V1. So after declaring our training data, that is our X, now we'll declare the target. So our target is our class variable that we are going to predict either 0 or 1, and the number of neighbors that we want is 5, and then the dupe size is equal to the number of times here. So once we run this particular code, so we'll get our output as SMOT output, and if you look at the SMOT output, so it will have different attributes, and our data is stored in our data attribute here. So we'll get the data set, which is data frame from this particular attribute. So we'll use this attribute data and we'll store the data set which we have created using the SMOT method. So once we run this particular line, and if you now click at the credit SMOT, so we'll get the data set that has around 37,905 entries and around 30 columns. So we have removed the first column, and our last column is our class column. So in the class column, around 60% of the class values will be 0, that is legitimate cases, and 40% of the class values will be 1, which is fraud cases. So now let's change the name of this variable to class with an uppercase C, so that we are according to all of the data types that we have in our, or all of the data frames that we have used till now. So we'll change the first of all the name of our last column, that is our 30th column, to class with an uppercase C using the call names function. So after changing the name of the class, so if you want to now get the percentage of the number of legitimate and fraud cases in our dataset, so we can use the prop table function, and then we'll pass a table function which will get the distribution of the categories present in the class variable. So now you can clearly see that we have around 60% of the legitimate cases and 40% of the fraud cases represented by 1. So now let's plot a scatter plot between V1 and V2 and compare the original dataset with the dataset that we have created using this mode. So this will be our original dataset where our data comes from the training data, that is without SMOT, and the rest of the code is same as above. So this will be our original scatter plot between V1 and V2 for the training data. So now let's plot a scatter plot for the V1 and V2 in the credits mode data after we have used the credit, or after we have used this mode method on our training data. So you have just have to change your credits mode, the data that you are passing to ggplot function. So once you run this function, you will see that we have added a lot of synthetic points, around 40% of the synthetic points using this mode method. So now if you look at this particular data, you can see the blue points represent class 0, which is the number of fraud legitimate cases, and the red points represent number of fraud cases. And you can see we have not only added points, but we have added synthetic points and not the duplicate points. So these are all the synthetic points that our mode algorithm has added using this mode method. And now after creating this particular data, we'll train our model on this data, and then we'll evaluate the performance of the model on the original test data. So now after making the data set 60 and 40 ratio, so the 60% of the cases now are legitimate cases and 40% of the cases are fraud cases. So now let's build a decision tree on top of this data so that we can predict whether a transaction is fraudulent or legitimate. So we'll be using the rpart package to build classification and regression trees. And we'll use the rpart.plot package to plot the regression trees or the classification trees. So if you have not installed these two packages, you can install using the install.packages command and install the packages for rpart.plot. So once you have installed these packages, you can load it using the library function. And once you load these packages, now we'll use the rpart function to make our classification and regression tree. So if you press F1 here, you will get to the description of this particular, or the documentation of this particular function. So the first argument here is a formula argument where we have to mention the independent and dependent variables. So now we are predicting the class variable. So our class is our independent or the dependent variable which we are going to predict, and we'll use all of the variables except the class variable as independent variables. So these, if you want to write all the variables, you can use a dot instead of writing every single name, and then we use tilde sign to separate our independent and dependent variables. And then we'll pass our data that we want to train our model on. So now our data that we'll train our model on is a credits mode data, which is our balance data. So once we run this, we'll create a tree which will predict the class of any particular sample based on all of the variables. So we'll store the tree in cart model variable. So after building a decision tree on this particular data, so now let's plot the decision tree using the rpart.plot function. So we just have to pass our model that we have built, that is our cart model, and then we have used extra equals 0. So once we plot this model, we'll get a decision tree. So if you don't want any extra information on the leaves, we write extra equals 0, and type equals 5 will change the display of this plots, the shapes that we have used in this plot, and tweak equals 1.2, it enlarges the text to 120%. So the text will be enlarged by 120%. So this is our decision tree that our model has built. So it will use only one column in our data set, that is V14, and it will use this column to classify different samples. So the particular column's V14th value is greater than minus 2.6, so that sample will be classified, or that transaction will be classified as a legitimate transaction, and if it is less than minus 2.6, so that transaction will be classified as a fraud transaction. So now after building the decision tree, let's now predict values on top of the test set to see how many samples are correctly and incorrectly classified. So we'll use the predict function to predict the values on top of the test set. So we'll use the first method, that the first argument that our predict function takes is our model that we have built, that is our card model. And if you want to know more about this function, you can press F1 here, so it will take you to this particular documentation. So we'll use the card model, that is our machine learning ML model that we have declared above, and then the data that it wants to predict on is our test data, and then we want to predict classes, so it will predict whether a class is 0, that is legitimate case, or class 1, that is fraud transaction. So it will predict on top of the test data, and then we'll compare the predictions with the actual values of the test data that we already have with us, so that we can see what is the distribution of the correctly and incorrectly classified values. So we'll store all the predictions in predicted val variable. So once we have predicted val variable, if you look at how our predicted value variable looks like, so here you can see the first value is 4. If you go to your test data, so here you can also see the first row of the test data is the fourth row of our whole data set. And if you want to see what our model has predicted, so for this particular row, the class value is 0, and our model has also predicted 0. And for this the second row, the class value is 0, and our model has also predicted 0. So if you want to know how many predictions are correct and incorrect according to our model and the actual values, so we'll build a confusion matrix to see how many predictions are correct and incorrect. So let's build a confusion matrix using the caret package. So I'll load the caret package, and then I'll use the confusion matrix function where I'll pass the predicted values first and then our actual values that are present in our class variable in our test data. So once you run this, you will get the confusion matrix for this particular model. So you can see here our true positives are 5625 and our true negatives are 7. So out of 9 samples that we have in our test data, 7 samples or the 7 fraudulent cases were correctly classified by our model that we have built using the credits mode data. That is, after using this mode method, the data that we have built, if we build our model on top of that, so we'll get out of 9 cases that are present in our test data, out of 9 cases, 7 cases which are fraud cases are actually classified. So we'll be able to detect 7 cases out of 9 cases that are present in our test data. And here accuracy is insignificant, but still if you want to see the accuracy, our accuracy is around 98.98%. So now if you use the model, if you build the same model without using more data or on the original trained data, and let's see what is the classification rate or how many samples are incorrectly and correctly classified. So this is our decision tree without using the more data. So now our data is actually the trained data, and I've excluded the first column of my data, that is our time column. So we were only using the variables v1 to v28 and then the amount column, not the time column, and the rest of the code is same. So this is our formula which contain dependent variable, that is class, and independent variables, the rest of the variables that are present in our data set. So we'll use this particular function rpart to create a classification and regression tree, and we'll store the modeling card model, and after that we'll plot the card model. So this is our model looks like. This is a decision tree that our model will use to classify different samples based on the legitimate cases and the fraud cases. So now let's predict on top of the test set and see what is the classification or the misclassification rate. So we'll use the same predict method, and then we'll call the card. In the predict function, we'll mention the first argument as our model, that is our card model, and then we are predicting on the test data. So here also I have excluded the first column. So if you want to exclude the first column of the test data, you can write this. So here it will include all the rows and it will not include the first column, that is our time column of the test data. This is our test data, how it looks like. So if you want to exclude this particular column because we are not going to predict using this column, so you can write -1 here, and after that we have to write type equals class, so it will predict classes for each sample. So either it will be 0 or 1. So now we have predicted the classes of the test data using our model that was built on the original trained data without using smooth. Now let's look at the confusion matrix. So now if you now look at the confusion matrix, you can see that our true negatives is 6. So out of the 9 samples, we are only able to classify 6 samples if we use the data set that we have, that is our trained data, without using the smooth. So now let's compare these two models using the whole data. So now instead of predicting on the test data, we'll predict on whole of the data set, and that will show us how many samples will be correctly classified by a model that was built on smooth and by a model that was built on the original data, that is unbalanced data. So first let's build our model that was built on the credits mode. So this will be our model that we built on the credits mode. Now let's predict on the whole credit card dataset that will contain all the values. So we'll exclude the first column and then we'll predict the classes and we'll store the predictions in predict val, and after storing the predictions, let's see the confusion matrix. So in this confusion matrix, out of the 44 samples that we had in our dataset, 40 fraud cases were correctly classified by using the smooth data or the model that was built on this smooth data, because our true negatives is 1. So these are the samples that was the transactions that were actually fake transactions 1, and our model is also predicted that these transactions are fake. So out of 44, 40 transactions were actually correctly classified. And now let's build the same model using the model that was built on the trained data or the original data without the balancing factor or this mode. After creating this data that is built on the original dataset that is unbalanced, and now let's predict on the top of the whole dataset. And now if you build the confusion matrix, so you will see that we have only 35 right now. So we have using this mode we can easily detect 5 more samples than we can detect using the unbalanced dataset. So that is why using smooth is preferable, because it balances the dataset first and then it predicts. So you can easily see we are able to classify more fraud cases using the smooth, which is 40, instead of using the original dataset that we have, which is unbalanced.
We have come to the end of our session. Hopefully that was informative to you. If you have any queries, you can ask us in the numbers that are listed on the screen. You can chat with us using sales@intellipaat.com. Our course advisors are always there to help you out. If you need help with any course, if you want to buy any course, if you want to understand any other thing, we have courses on a lot of concepts. So you can take a look at that as well. And with that in mind, I'll see you next time.